So you want to be a data engineer in 2024? Well, you landed on the right video. This video is going to be your one-stop solution since we have packed in everything you need to know to kickstart your career from foundational concepts to advanced skill, all in one comprehensive roadmap. We'll begin with outlining the differences between a data engineer and a data scientist to help you decide where your interests lie. We will then introduce you to data engineering, covering the essential skills and the data engineering lifecycle, so you know exactly what this role entails. Moving on, we focus on Python and SQL, the backbone of data manipulation and querying. But that's not all. With the rise of cloud computing, you will learn how to work with platforms like AWS and Azure Data Factory to handle large-scale data processing. We'll also explore big data technologies like Hadoop and Spark, which are crucial for processing massive data sets. Then you will get introduced to data warehousing with tools like Hive and other top solutions in the industry. I hope this sets the context to why this video is perfect for anyone looking to master these key skills required to become a data engineer in 2024. You might be a beginner or someone who is looking to level up, but by the end, you will have all the tools you need to thrive. So hit that subscribe button, make sure you watch this video till the end, and let's get started.
So let us quickly start with the basic of who is a data engineer. A data engineer is an IT professional whose major responsibilities is to prepare data for analytical or operational purpose. These software engineers are often in charge of creating data pipelines that connect information from several source systems. They combine, consolidate, and purify data before structuring it for use in analytics applications. They make data more accessible and maximize the company's big data environment. Data engineers collaborate with data science team to improve data transparency and enable businesses to make more reliable business decisions. Now let's quickly understand the different types of data engineers. Data engineers collect and prepare data for data scientists and analysts to use. They take on three major roles, which are generalists. They often operate in small groups, collecting, ingesting, and analyzing data from start to finish. Pipeline-centric engineers. These data engineers often work on a mid-sized data analytics team as well as on more complex data science projects across remote platforms. Database-centric engineers. These data engineers are in charge of building, maintaining, and populating analytics database. Data engineers frequently collaborate with data scientists as part of an analytics team. Engineers deliver data in usable format to data scientists who use the information to perform queries and algorithms for predictive analytics, machine learning, and data mining applications. Data engineers also give aggregated data to corporate leaders, analysts, and other end users for analysis and application to improve business operations. Data engineers deal with both structured and unstructured data. Information that can be formatted and saved in a usable format such as database is referred to as structured data. Unstructured data such as text, photos, audios, and video file does not fit into traditional data models. To handle both kinds, data engineer must comprehend various approaches to data architecture and application. The data engineers toolkit also includes several big data technologies such as open source data intake and processing framework. We all know that having a good skill set is always a boon. So let me quickly tell you the skill required to become a good data engineer. You need to have a good knowledge of programming languages, Python, SQL, Java, etc. Companies such as IBM and Hadoop vendor Cloudera Inc. have begun offer certification for data engineering expert as the data engineering vacation has grown in popularity. Some prominent data engineer certifications are Certified Data Professionals, Cloudera Certified Professional Data Engineer.
To better understand the data engineering life cycle, let's start with a simple example. Imagine a company like Netflix, which needs to handle massive amount of users' data to provide personalized recommendations. Every time you watch a show, pause or skip a scene, Netflix collects valuable data that helps improve its service. But how does Netflix actually manage and make sense of this massive amount of data? This is where the data engineering lifecycle comes into play. The data engineering lifecycle refers to the process of collecting, transforming, storing, and managing data in a way that makes it usable for decision making, reporting, and analytics. The first step would be data ingestion, where the data is gathered from various sources like database, APIs, or real-time streams. For Netflix, this includes user actions, what you watch, when, and on what device. Secondly, the data transformation is where the raw data is cleaned and formatted for use. Netflix might convert viewing times into preferences or combine data from different sources to improve recommendations. Lastly, data storage is where the processed data is stored in database, ready for analytics and decision making. This life cycle ensures Netflix or any company delivers timely, reliable insight from data.
Now we'll head on to the main component, which is about the different data structures in Python. So we have tuple, list, dictionary, and set. Let's start off with the first data structure, which is a tuple. So till now, when we have worked with single variables, we were able to store only one value or a single value inside a variable. But with the help of these different data structures such as tuple, list, set, and dictionary, we'll be able to store multiple elements inside a data structure. And it's not that we can store only multiple elements of a single data type. We can also store elements of different classes or different types into this data structure. So let's start with tuple. What exactly is a tuple? It is an ordered collection of elements enclosed within round braces, and tuples are immutable. What do I mean when I say tuples are immutable? So what this basically means is if you create a tuple, then you can't go ahead and change any of the values present in it later on. A tuple cannot be modified once you create it. And this is the example of a tuple over here. So we have round braces. Inside the round braces, I have stored the elements 1, A, and true. So as you see, I have elements of different types. So we can store elements of different types into a tuple. So let me create my first tuple in Jupyter Notebook. I'll type in, let me actually have this in a fresh space. I'll add the comment tuple. And over here, I'll type in tup1. I'll have round braces over here. So first element is 1. Then I'll have Sparta. Then I'll have true over here. And then let me just print out tup1. So I have created this tuple. Now let me check the type of this. Type inside this, I will pass in tup1. And this tells us that this is a tuple. Now, if I want to extract individual elements from a tuple, how can I do that? Well, the process is pretty much similar as when compared to strings. So if we want to extract the first element from a tuple, so as you guys see over here, I have created a tuple which comprises of all of these elements. 1, A, true, 2, B, false. And if I want to extract the first element, since the first element is present at index number 0, I'd have to give in the name of the tuple, and inside the parenthesis, I'd have to give in the index value, which will be 0. And I have extracted this particular element from this entire tuple. Similarly, if I want to extract the last element, so if I want to extract the last element, I just have to give in -1. So in tup1, I'll give in -1. And with the help of this, I am able to extract the last element. Now, if I want to extract a continuous sequence of elements, so here if I want to extract A, true, and 2, which is a continuous sequence of elements, I'd have to give something like this. So inside the parenthesis, I'll give in 1:4. So this is the starting value of the index. This is the ending value of the index. Now here, when it comes to Python, you'd have to keep in mind that the ending value is exclusive. The starting value is inclusive. So when you give 1, the starting index value A, right? So we have 1 and we have extracted this element. But when you give in 4, this only goes till index number 3. So that is why we have extracted only A, true and 2. So 2 is present at index number 3. We have extracted A, true and 2. But when we have index number 4, so index number 4 we have the value B, but this is not extracted because index number 4 is exclusive. So let's go ahead and create a new tuple and extract some elements from those tuples. So what I'll do right now is I will have a new tuple called as tup2, and let me just store some random values inside this. I'll have 1, A, true, then I'll have 2, B, and I'll have false inside this. So I have created tup2. Now if I want to extract the first element, so that is obviously present at index number 0, I'll just type in tup2, and inside this I'll give in the index value which is 0, and as you guys see I was able to extract this particular element from this entire tuple. Now similarly, if I want to extract the last element, so I'd have to type in tup2, I'd have to give in the parenthesis, and to extract the last element I'd have to give in -1. And if I want to extract a series of elements, so let's say if I want to extract true, 2 and B. So here true, the index value would be 2. So I'll have tup2, the starting index value is 2, and this is 2, 3, 4, 5. So since this goes till 5, 5 is also included, I would have to give 6. 0, 1, 2, 3, 4, 5. This will go till 6. Let me hit run. And as you guys see, I have included true, 2, B and false. If I let's say wanted only till B, so this will be 2, 3, 4. And if since this has to be included, I'll just give in 5 over here. And I have extracted only true, 2 and B. Now we'll actually try to modify a tuple. So initially I had told you guys that a tuple is immutable. Now when I say a tuple is immutable, I would basically mean that whatever you store inside it cannot be changed. So here I am actually trying to change the value which I had actually stored in a tuple. So as you guys see, tup1, and inside this the whatever element was present at index number 2, I am trying to change it. But we get an error over here, and the error is tuple object does not support item assignment. So let me just print in tup2 over here. I'll hit run, and let's say if I want to change this particular value, so I have this is present at 0, 1, 2 and 3, index number 3. So tup2 and index number 3, I'd want to change that from 2 to 20. Let's see what do we get. We get the same error. Tuple object does not support item assignment because tuple is an immutable object, and that is why you cannot go ahead and change whatever is stored inside a tuple. So we have seen that a tuple cannot be modified. Now let's go ahead and perform some basic operations on top of the tuple. So here we have the same tuple where we have all of these elements over here, 1, A, true, 2, B and false. Now if you want to find out the length of a tuple, or in other words you would want to find out how many elements are present in a tuple, then we can just go ahead and use this len method. So this would give us the number of elements which are present in this tuple, and as you see over here we've got 6 elements, and that is the result over here. Then going ahead, we can also concatenate 2 tuples. That is, we can attach the elements of one tuple to the back end of another tuple. So here we have tup1 where we have elements 1, 2 and 3. Then we have tup2 where we have elements 4, 5 and 6. Now when we are trying to concatenate, all we have to do is use the plus symbol or the plus operator. And when we use tup1 plus tup2, we get the result 1, 2, 3, 4, 5, 6. So let's go ahead and perform these operations in Jupyter Notebook. So I'll just create the tuple again over here. I have tup1 and let me add in some elements. So I'll have 1, A, true, then I'll have 2, B, and then I'll also have false over here. So I have created this tuple. Now if I want to check the length of it, all I have to do is use the len method, and inside this I will be passing in the object. And as you guys see, we have the result which tells us that there are 6 elements present in this tuple. Now I'll create 2 more tuples. I'll have tup2 over here, and inside this I will have the elements 1, 2 and 3. Going ahead, I'll create another tuple with the name tup3, and inside this I will store the elements 4, 5 and 6. Now I would have to perform tup2 plus tup3. Let me change the spelling over here. And as you guys see, we have concatenated these elements at the back end of tup2. So this was a very simple operation. Now, if we want to repeat the elements which are present in a tuple, that is also something which we can perform. So here in this tuple, we just have two elements which are Sparta and 300. Now, if we want to repeat these elements a certain amount of time, then we have to multiply this with a scalar number. So here when I'm multiplying tup1 with 3, I get Sparta 300, Sparta 300 and Sparta 300, which basically means I am just repeating these elements 3 times. Now we can also perform repeating and concatenating at the same point of time. So here we have tup1 and tup2. So first what I'm doing is I am repeating the elements which are present in tup1. So here when I use tup1 into 3, the elements are repeated 3 times. So I have Sparta 300 repeating 3 times. Then I am attaching or concatenating tup2 at the back end of this. So let me add a comment over here. I'll just have repeating elements in a tuple. And now I have this tup1 over here. Let me just print out tup1. And if I want to repeat these elements 3 times, all I have to do is type in tup1 into 3 and let's see. So as you guys see, 1A true, 2B false. So we have this once, then the same thing is being repeated twice and the same thing is being repeated thrice. Now similarly, if I want the entire thing to be repeated 5 times, I would have to multiply this with 5. So as you guys see, I have repeated all of the elements 5 times. Now we'll do repetition and concatenation at the same time. I'll add a new comment over here. Repetition and concatenation. I'll have two tuples over here. I'll have tup1 where I'll have, let's say, A, B, and then I'll have C. Then I'll go ahead and create a new tuple which will be tup2, and inside this I will have X, Y, and then I'll also have Z. And now this is an interesting operation. So I'll have tup1 into 3 plus tup2. And let's see the result. So as you guys see, I have repeated the elements which are present in tup1 3 times. So I have ABC, ABC and ABC. Then I'm adding this at the back end of it and I get X, Y and Z. So this was another simple operation. Now we also have some simple tuple functions. So if you have a tuple and if you want to find out the minimum value and the maximum value which are present in it, all we have to do is use the min method and the max method. So over here I have these elements, and if I want to find out the minimum value which is present over here, all I have to do is use the min method and I pass in the tup1 object inside this. And as you guys see, this method tells us that the minimum value which is present in this tuple is 1. Going ahead, similarly, we use the max method, and when we pass in tup1, this tells us that the maximum value which is present in this tuple is 5. So I'll have tup1, and let me add some numerical values inside this. So I'll add some random numbers in a random order over here. So I have 825107. Now if I want to, I have to remove the C over here. Now if I want to find out the minimum value which is present in it, all I have to do is use the min method, and inside this I'll be passing in tup1, and as you guys see, this method tells us that the minimum value which is present in this tuple is 0. Similarly, if you want to find out the maximum value, I'll use the max method, and inside this I'll again pass in tup1 and we get the result of 8. This brings us to the end of this tutorial on tuples in Python.
So dictionary is an unordered collection of key value pairs enclosed within curly braces. And a dictionary again is mutable. So what exactly are key value pairs? Let's see an example of that. So over here we are creating a dictionary where we have two key value pairs. So the first key is apple, Second key is orange. First value is 10, second value is 20. So you can also consider it this way. Let's say we have the name of the fruit and the cost of the fruit, or maybe the quantity of the fruit. So we have apple, and let's say there are 10 apples. Then we have orange, and let's say there are 20 oranges. And you will be separating the key with the value with this colon over here. Now let me just delete all of this and let's start fresh for our dictionary. So instead of list, I'll just type in dictionary over here. And let's say I'll create this dictionary like this, and I'll have, let's say my first fruit is mango, and I have 10 mangoes with me. Then I'll have apple, and let's say I have 20 apples. Then I have lychee, and I have 30 lychees. And finally, I would have strawberry, and I would have 40 strawberries with me. Let me print out the result over here. So this is our first dictionary which we have just created. And just to ensure that we have actually created a dictionary, let me check the type of it. So type of fruit would tell us that this is of dict type, which is basically a dictionary. Now, once we have created a dictionary, we can actually go ahead and extract the individual keys and values which are present over here. So this is our dictionary, and if you want to extract only the keys, so this what you see on the left side of the column, those are our keys. And if you want to extract only the keys, all you have to do is use the name of the dictionary, follow it up with the keys method, and we'll get all of the keys which are present in this dictionary. Similarly, if you want to extract all of the values, we would have to use the values method. So when I type in fruit.values, I am able to extract all of the values which are present over here. So I'll have fruit, which is a dictionary, which is already present. And if I want to extract all of the keys, I'll just go ahead and use the keys method. And as you guys see, I am able to extract all of the keys which are present. Similarly, if I want to extract the values, I'll type in fruit.values, and I have extracted all of the values which are present. Now, since dictionary is mutable, we can modify it. So that would mean we can add a new element, or we can change an existing element. So here we had only 4 elements, but if I want to add a 5th element, so here we don't have mango initially, but if I want to add mango, all I have to do is use the name of the dictionary, then inside parenthesis, I'll add the new key. So this is what you see. Inside parenthesis, I'm adding the new key and I'm adding the value to it. So here, as you guys see, I have attached this new key value pair at the end of this dictionary. Similarly, if I want to change an existing element, so initially the value of apple was 10. But if I want to change the value, then inside the parenthesis, I'll just give in the key and I'll assign a new value to it. So initially we had 10, now we have modified it to 100. Now we'll see how to add a new element. So I'll have fruit over here. Let me just print it out. We have 4 elements. Now let me add a new element inside this. So I'll have fruit. I'll have the square braces, and let's say the new fruit which I'll be adding is guava. And let's say I have 50 guavas with me. And let me print out fruit right now and let's check the results. So as you guys see, we have attached this new key value pair at the end of this dictionary. And finally, let's see actually how can we modify an existing element. So we've got, let's say if I want to modify this particular key value pair. So I have lychee and the value of lychee is 30. So I'll have fruit inside this. I'll give in the key which is lychee, and I want to change 30 to 300. I'll just assign 300 to this and let me print this out. And as you guys see, initially the value was 30. I have successfully changed it to 100. Now we'll go ahead and work with some dictionary functions. So let's say if we have 2 dictionaries over here, we have fruit 1 and fruit 2. So in fruit 1, we have apple and orange. In fruit 2, we have banana and guava. And if I want to append the elements of fruit 2 to fruit 1, or in other words, if you want to concatenate the fruit 2 values to fruit 1, all we have to do is use the update method. So I have fruit 1 and I'll use update method and I'll pass in fruit 2 inside this. So as you guys see, we have appended banana and guava to the end of fruit 1. Then similarly, we can go ahead and pop an element from a dictionary. So we can, so if we want to pop any key value pair, so inside the pop method, we would have to give in the key which we'd want to pop. So we had orange, but I don't really like oranges. So that is why I went ahead and I popped out orange. So as you guys see, orange is not present in this particular list. Now let's create two more dictionaries. I have fruit1 and I'll have two fruits inside this. So I'll start with mango and I have 10 mangoes. Then I'll have apple and maybe I have 20 apples with me. Then I'll have fruit 2. And in fruit 2, let's say I'll start off with guava and I have 30 guavas with me. Then going ahead, I'll have lychee and I'll have 40 lychees with me. So I have created these two dictionaries. So we have made a mistake over here. Let's actually check what this mistake is. So instead of the equal to operator, I'd have to give in colon over here. That is important. So I have created fruit1 and fruit2. Let me print out fruit1 and fruit2 for your sake. And once we have printed these two, let me go ahead and actually append the values of fruit2 to fruit1. So for this, I'll have to use fruit1, then I'll use in the dot operator over here. And after that, I will use the update method. And inside the update method, I'll be passing in fruit2. And let me print out. Let me close this first. Now, let me go ahead and print out fruit1. Now, as you guys see, I have appended the values of fruit2 to fruit1. Now we have fruit1 already, but let's say if I want to pop out something from this. So let's say from this, if I want to pop out the value of lychee, I'll have fruit1. Then I'll use the pop method. So fruit1.pop. So we have an error because we'd actually have to give a key inside this. So because I'd want to pop out lychee, I'll give in lychee over here and we have successfully popped out lychee from this. Now we'll head on to the last data structure in Python, which is set. So set is an unordered and unindexed collection of elements enclosed within square braces. So when we say unordered, so in whatever sequence you insert the elements in a set, that particular order does not remain intact. And also when we say it is not indexed, you can't extract elements from a set with a particular index value because there is no proper ordering. And also you'd have to keep in mind that in a set, duplicates are not allowed. So you can't have the same element twice. But if you're actually given the same element twice, what happens is the set takes it only once. And we are creating one particular set over here. And if you want to add a new element inside this, so initially we are creating this set where we have all of these elements. So we have 1, A, true, 2, 2, B, and false. And if I want to add a new element at the end of this or somewhere, so I'll just use s1.add, and this is how we can insert the new element inside this. Now let's say if instead of adding just one particular element, if I want to add multiple elements at the same time. So instead of the add method, we'll be using the update method. And with the update method, I am passing in these list of values, which are 10, 20, and 30. And as you guys see, I have inserted 10, 20, and 30 inside this. But then again, you have to keep in mind that the order is not maintained in a set. So these are inserted randomly. And if you want to remove a particular element, you can just use the remove method and you will pass in the element that you'd want to remove. Again, since there is no indexing, you can't remove elements with an index value. You would have to give in the value which you'd want to remove explicitly. So let's create our first set. So I'll have S1. I'll just add some elements over here. I'll have A, B, C, D, E, and F. Let me print out S1 for your reference, and this is what we have. Now let's say I'll add some duplicates inside this and let's see what happens. So I'll have A repeating 3 times, then I'll have B also repeating 2 times, then I'll have C repeating 2 times. Now if I print this out, as you guys see, we have only A, B, C, D, E and F. Even though A is repeating 3 times, we'll only have one unique value of A. Similarly, even though B and C are repeating 2 times, we'll only have one unique value of B. Now, if I want to go ahead and add a new element inside this, I'll use the add method. So s1.add, and inside this, I'll just add Sparta. So when I use s1.Sparta, and when I print s1, so we have inserted Sparta over here. Similarly, if you want to pop out something or remove something, we will have to use the remove method. So I'll have s1.remove over here. And inside this, let's say if I want to remove the element E, I'll just pass in E over here. And let me print out s1 again. So we have successfully removed the element E from this entire set. Now we'll work with some set functions. So here we have two sets, S1 and S2. In S1 we have the elements 1, 2 and 3. In S2 we have the elements A, B and C. Now if we want to combine all of the elements which are present in S1 and S2, then we can use the union operator. So S1 dot union S2 will give us a union of S1 and S2. And as you guys see in the resultant, we have 1, 2, 3, A, B and C. Similarly, we have two sets over here, and if we want only the common elements which are present in both of the sets. So here we have 1 to 6, here we have 5 to 9. If you want the common elements, I would use the intersection method. So when I use S1 dot intersection S2, you will see that we have 5 and 6 common in S1 and S2, and that is the result which we get. Let me have S1 over here. And in this, I'll have 1, 2 and 3. I'll have S2 in which I'll store 4, 5 and 6. Now let me use the union operator. So I'll have S1 dot union, and inside this I'll be passing in S2. And as you guys see, I have appended 4, 5, 6 at the end of S1. Now similarly, if I want to find out the common elements, so let me make some modifications in S1. So in S1, let's say I have from 1, 2, 3, 4 and 5. And then S2, let's say I have the elements 4, 5, 6, 7 and 8. Now if I want to find out the common elements which are present in S1 and S2, I'll have S1 dot intersect, and inside this I'll be passing in S2. And we seem to have an error over here. So this has to be intersection and not intersect. Let me click on run. So as you guys see, by using the intersection operator, we have the common elements which are 4 and 5.
Now we'll understand about flow control statements in Python. And in flow control statements, we'll have decision-making statements and looping statements. We'll start off with decision-making statements. And as you can get from the name itself, decision-making statements would help us to make a decision on the basis of a condition. And we have a very good example over here right in front of us. So let's say you would want to play football, but it's actually raining outside. So the condition over here is, if it's raining outside, then you can't play. You'd have to sit inside. On the other hand, if it's not raining, else it is not raining, then you can go out and play football. So this is a very good example of if-else statement. Then let's look at another example. Let's say you have your main exam coming up and you go ahead and give a mock exam. And in that mock exam, if you score greater than 70 marks, then your parents tell you that they'll buy you an ice cream. But on the other hand, if you score less than 70 marks, then you would have to give another mock test. So this again is an example of if-else statement. So now that we've understood how if-else statements work, let's go to Jupyter Notebook and implement them. So here we have two variables A and B. We have stored the value of 10 in A and 20 in B. And we are trying to see if the value of B is greater than the value of B. That is, we are checking if 20 is greater than 10. And if that is evaluated to true, we will just go ahead and print out B is greater than A. And this is the syntax as you see. We'll give an if, the keyword if.
you'll follow it up with the condition, and in the condition we are checking if B is greater than A. So is 20 greater than 10? That is evaluated to true. And since that is evaluated to true, when I hit on run, I'll get this result, which is B is greater than A. Now let me change the condition over here. So instead of checking if B is greater than A, I want to check if the value which is present in A is greater than the value which is present in B. So I am basically checking if 10 is greater than 20. And obviously this evaluates to false. And since this evaluates to false, whatever is present inside the body of this if will be skipped out. And when I hit run, you'll see that I'll not get any result over here because this is evaluated to false. So whenever if is evaluated to false, you need something else. So that is why we have this else keyword over here. So here we are checking if A is greater than B. And since this has been evaluated to false, I'll give an else keyword over here and I will print out whatever will happen. Since this is false, I would have to print out B is greater than A. And when I hit on this, you would see that I'll get B is greater than A, and which is actually right. So this is about if else condition. Then we have another variation of if else, which is if elif else. So with the help of this, we can compare multiple variables together, or we can have multiple conditions together. And this time I'd want to find out the greatest value among three values. So I have three variables over here, A, B and C. I'm storing the value of 10 in A, the value of 20 in B, and the value of 30 in C. And once I do that, using if, I start off by checking if the value of A is greater than B and also if the value of A is greater than C. So as you can look over here, I am giving two conditions, and those two conditions have been joined with the help of this AND operator. If A is greater than B and if A is greater than C, and if that is the case, I'll go ahead and print out A is the greatest. And if either of these is evaluated to false, then with respect to AND operator, you know that if either of these is false or both of them are false, then this part will be skipped. So here, if A is greater than B, we are checking if 10 is greater than 20. That is obviously false. And here we are checking if A is greater than C. So is 10 greater than 30? That again is false. So false and false will be evaluated to false. And that is why we'll be skipping out this particular line. Then we'll head on to elif. And this time we are checking if B is greater than A and B is greater than C. So if B is greater than A, 20 is greater than 10. This is evaluated to true. After this, we are checking if 20 is greater than 30. This is evaluated to false. So true and false is again false. And that is why we'll skip this as well. And finally, we'll enter the final else statement and we'll just go ahead and print out C is the greatest. So this is about if, elif, else. Then we can also go ahead and use the if statement with a tuple. So here we have created a tuple where we have three elements A, B and C. And once we create this tuple, I am trying to find out if the element A is present in this tuple. So here if A in tup 1, then I go ahead and print out A is present in tup 1. And as you see, since this is evaluated to false, or in other words, this element is present in this tuple, I'm able to print out A is present in tup1. Now on the other hand, if I would want to check if an element Z is present in this tuple, so here I have if Z in tup1, print Z is present in tup1, and as you see, I don't get anything because this element is not present. So here what I'll do is, I'll add the else statement and I'll print out Z is not present in tup1, and this time I'll get the result because this is evaluated to false and will print out whatever is there in the else condition. And this time we are going ahead and using the if statement with a list. So again we are creating a list L1 over here. And we have these three elements A, B and C. And this time what we are doing is we are checking if the value which is present at 0th index of this list is equal to A. And if that value is equal to A, I would want to change that value to 100. So as you see, if L1 of 0 is double equal to A, I am assigning a new value over here, and that value is equal to 100. And after I run this, you would see that initially the value was A and I have changed that value to 100. Now, let's say if I run this back again, and if I would want to change this value from A to Z, I'll just have Z over here. And you would see that initially the value is A and this time I have changed the value to Z. And finally, we will be applying the if statement with a dictionary. So here we have created a dictionary D1 where we have three key value pairs, K1, K2, K3. The value of K1 is 10, the value of K2 is 20, and the value of K3 is 30. And with the help of the if statement, I am adding 100 more to the first key over here. So the condition is if D1 of K1 is double equal to 10. I'm checking if the value for the key K1 is equal to 10, then I will add 100 more to this by using this condition. So D1 of K1 is equal to D1 of K1 plus 100. So I have an error over here. I'd have to initialize D1. And as you guys see, initially the values were 10, 20 and 30, and after using the if condition, I have added 100 more to the first value of the first key. So those were decision making statements. Now we'll head on to looping statements, and these are used to repeat a task a certain number of times. And again, we have a very beautiful example over here. Let's say you have a bucket and you'd want to fill up that bucket with a mug of water. Now what you'll do is consider the mug and the bucket to be empty at this point of time. First, you'll fill up the mug and you'll pour this water into the bucket. Then you'll check if the bucket is full or not. After this, again, you'll take a mug full of water, then pour it back into the bucket. Again, you'll check if the bucket is full or not. Then next time again, you'll take a mug full of water, pour it back into the bucket. And again, you will check if the bucket is full or not. And this process goes on until the bucket is completely filled up with water. And you will stop this only when the bucket is filled. So here what you're doing is you're looping, or you are performing the same task again and again until a condition is met. We have another example over here. Let's say you're listening to your favorite song and you put that song on loop. So here the condition is the same song will be kept on playing until you either close the app or maybe you switch off your phone. So this is the condition over here. The song is on loop until you close the app, you stop the song, or maybe you switch off your phone. Then we have a very interesting example. So at the end of every month, you will get credited with a salary amount. So here what is happening is if the date is equal to 30th or 31st, and if it is the last day of the month, you will have salary credited into your bank account. This again happens in a loop. So these are some examples of looping statements. And we have two types of looping statements in Python, which are for and while. We'll be working with both of them. So we'll go ahead and start off with the for loop. So here we have created a list called as fruits, and this has these three fruits over here: apple, mango and banana. Now, with the help of this for loop, I would want to print out all of the individual elements which are present over here. So I'll have for I in fruits, print of I. So here I, what happens is initially the value of I will be equal to apple. Then the value of I will be equal to mango. Then the value of I will be equal to banana. And this will end once I reaches the last element which is present in this list. And that is how we are printing out each element which is present in this list. So this is a very simple example of how we can work with the for loop. Then we can also have a nested for loop, where we'll have one for loop inside another for loop. And here we have two lists again. We have one list comprising of different colors, and we have another list comprising of different items. So the colors are blue, green and yellow, and the items are book, ball and chair. And what I'm doing is I have an outer for loop which would help me to pick a color. So here it is for I in color. Then inside the outer for loop, I have an inner for loop which goes for j in item, which should help me to choose an item, and I print out I comma j. Let's understand how this for loop works over here. So initially value of I is equal to blue, and we enter the for loop, and the value of j over here will be equal to book. So I print out I comma j, it will be blue book. Then value of j is incremented, it becomes ball, and I print out blue ball. Again value of j is incremented, it becomes chair, then I print out blue chair. Then I go back to the outer loop and blue is incremented, then the color becomes green. Then I have green book, green ball, green chair. Again after this value of green becomes yellow, then I print out yellow book, yellow ball and yellow chair. This is how you can work with nested for loop. After the for loop, we have the while loop. So while again would help us to repeat a particular task, and this task is repeated on the basis of a condition. And over here, I am trying to print out the first 10 numerical numbers using a while loop. Here I have initialized a variable called as I, and I have assigned the value of 1 inside this variable. And after this, I am checking if the value of I is less than or equal to 10. And if the value of I is less than or equal to 10, I enter this while loop and I print out I. Then I increment the value of I. So let's understand what is happening in this while loop. Initially value of I is equal to 1. So the condition is 1 less than or equal to 10. And since that is true, I go inside the for loop, I print out 1. Then I value is incremented, it becomes 2. Then I go back and I check if 2 is less than or equal to 10. This again is true. I head back, I print out 2, then I increment the value of I, it becomes 3. Then I am checking if 3 is less than or equal to 10. This again is true. I head back into the while loop, I print out 3, then I value is incremented, it becomes 4. Then again I am checking if 4 is less than or equal to 10. This is true. I come back into the while loop, I print out 4, then I will increment the value of 5, it becomes 5. Then we will proceed the same way till the value of I is equal to 10. When the value of I is equal to 10, I am checking if 10 is less than or equal to 10. And this condition is true. I print out 10 over here. After this, I have I plus 1. Value of I becomes 11. And this time when I check is 11 less than or equal to 10, this condition fails. And this is when I come out of this while loop. And this is the result which I get over here. Similarly, instead of the first 10 numbers, if I want the first 15 numbers, I'll just go ahead and change this value over here. And you would see that I have printed out the first 15 numbers. Now using the while loop, I can also go ahead and print the 2 multiplication table. Here I have I and I'm assigning the value of 1 to I. Then I have a new variable called as n and I'm assigning a value of 2 to this new variable. And in the while loop again the condition is while I is less than or equal to 10. And while this condition is true, I will print out n into I is equal to n into I. Then I am incrementing the value of I. So let's again understand what is happening inside the while loop. So initially value of I is equal to 1. So the condition will be while 1 is less than or equal to 10, which is true. I come back over here and I print out n into I, which will be 2 into 1 is equal to 2. So I print out this. Then I increment the value of I, it becomes 2. Is 2 less than or equal to 10? Yes, that is true. I come inside, then this time I print out 2 into 2 is equal to 4. Then I value is incremented, it becomes 3. So is 3 less than or equal to 10? That again is true. So this time I will have 2 into 3, which is equal to 6. And I print this out. And this process continues till I value is equal to 10. And when I value is equal to 10, I will have 10 is less than or equal to 10, which is true. So here it will be 2 into 10 is equal to 20, and we'll print that out. And after that, when we increment the value of I, it will become 11. So is 11 less than or equal to 10, which is false. And this is when we will come out of this while loop. So these were some examples with the help of while loop. Now we'll also see how to apply this while loop on top of a list. So here we have this list L1 with all of these numbers 1, 2, 3, 4 and 5. And I would want to add 100 to each individual element of this list. So I start off by initializing this variable I given the value of 0, and this while loop will go on till the length of the list, or in other words, the number of elements which are there in the list. So what is the length? It will be 1, 2, 3, 4 and 5. Initially, value of I is equal to 0. So we are checking if 0 is less than 5, which is true. We come inside the while loop. Here it will be L1 of 0 is equal to L1 of 0 plus 100. So it will be 1 plus 100. We'll print out 1 plus 100 over here. Then we are incrementing value of I. It becomes 1. So is 1 less than 5? It is true. So here we will have L1 of 1 is equal to L1 of 1 plus 100. So it will be 2 plus 100, which will become 102. And this is how we'll go on and print out or add 100 to each element of this list. Now we'll head on to one of the most important concepts in Python, which is object-oriented programming. Now when you look around you, you would see that you are surrounded with objects. The laptop which is there in front of you, that is an object. The phone which is there in your hand, that again is an object. The bottle which is there beside you, that again is an object. Now, if you'd want to represent all of these real world objects in the programming paradigm, you would need an object-oriented programming language. So you would have a lot of object-oriented programming languages, and Python is also an object-oriented programming language because it allows us to represent all of these real world entities in a programming world. Now, to understand the concept of object-oriented programming, we would need to understand two main components of it, which are classes, and then we obviously have objects. So let's start with this term called as class. So what exactly is a class? Simply put, you can consider a class to be a template or a blueprint for real world entities. And we have a very simple example over here. Let's take the example of a phone. Now, when we talk about a phone would again have two things associated with it. It will have some properties and it will have a certain behavior associated with it. Now, when I say properties, the phone will have a color associated with it. The phone will have a cost associated with it, and the phone will also have a certain battery life associated with it. And along with these batteries, when I say a phone will have certain behaviors associated with it. Now, what do I mean by behaviors? I simply mean that with the help of a phone, you can make calls. With the help of a phone, you can watch certain videos on it. And also, some phones allow you to play games in it. So this class, this phone class, has properties and behavior associated with it. And what exactly is a class in Python? You can consider this class to be a user-defined data type. So as we have predefined data types, so we had looked at all of these predefined data types, which were integer, float, boolean, and string. So similar to these predefined data types, we can create a user-defined data type, and that user-defined data type will be this class. So here what we are doing is we are creating this class, this user-defined data type called as mobile. And this user-defined data type will have attributes and methods inside it. So these attributes are nothing but the properties of the class, and these methods are nothing but the behavior of the class. Now that this is clear, let's understand the next component of object-oriented programming, which is object. So we already know what is a class. Now, object is nothing but a specific instance of a class. So when we say we have a mobile class, the specific instances of this mobile. So we have Apple, Motorola, and Samsung. So Apple, Motorola, and Samsung would be objects of this class, phone or mobile. And if you want examples of what exactly is an object, so as we have these predefined data types, so these are integers. So A is an integer variable and I'm storing the value 10 inside this. Similarly, B is an integer value and I'm storing the value 20 inside this. So similarly, if we have the mobile data type, then for this mobile data type, we have the objects Apple, Motorola and Samsung. So that was a brief intro to object-oriented programming. Now let's see how can we actually create a class in Python. So to create a class in Python, we'd have to start off by giving this keyword called as class. Then going ahead, we will give in the name of the class. And by convention, you would have to remember that the name of the class needs to be capital. The first letter has to be capital. So that is why we have given capital P over here. So the name of this class is phone, and inside this we are defining two methods. So with the help of these methods, we can have the behavior of this class. So I am having this first method called as make call, and inside this method I'm just printing out making phone call. And over here, as you see, this method takes in a parameter which is self. So for now, just understand that with the help of this self parameter, you will be able to invoke the attributes which are present in this class. Just understand this for now, and as we'll go ahead through object-oriented programming, it will be much more clear to you guys. So as we have created this particular method, similarly, we will create another method called as play game. And this again takes in one parameter which is self, and all I'm doing is printing out playing game. So now that I have created my blueprint or my class over here, I would have to create a specific instance of it. Or in other words, I'd have to create an object of this phone class. So I'll just write down phone over here and I will store it in this object called as P1. And now that I have the object of this class, I can go ahead and invoke the methods which are present in this class with the help of this object. So when I type in p1.makeCall, with the help of this, I will be able to invoke this method and I am printing out making phone call. Similarly, when I invoke p1.playGame, I am invoking this method and I am printing out playing game. So this is how we can create a class and an object in Python. So let's go to Jupyter Notebook and work with this example. So my task would be to create a class. So I'll have class. I'll give the name of the class as phone. I'll give in a colon over here. And after this, I would have to create a method. And to create a method, we already know that we will be using the def keyword. And I will give the name of this method as make call. And we know that this takes in only one parameter, which is self. And inside this, I will just have a print statement, which will be making a phone call. And once I have this method, I will go ahead and create another method over here. So I will call this method as play game, def of play game, and I'll have self over here. Again, I'll have a print statement, and here I will write down playing a game. So I have created my phone class over here, and now that I have created this phone class, I would have to create an object of this. So here I will have P1 is equal to phone. So I'll have to give in parenthesis over here, and this is how I am creating an object of this phone class. And now that I have the object ready, so with the help of the dot operator, I can invoke both of these methods. So I'll start off by invoking the make call method. So I will have make underscore call. And when I hit on run, you would see that I have successfully printed out making a phone call. Similarly, now when I have p1.playGame, you would see that I have printed out playing a game. So we have created our first class and we have also created the object for this class. And now, in the methods which were present in the previous class, there were no additional parameters. We had only one parameter known as self, and with the help of that self parameter, we were just able to access the attributes which were present. And we did not actually have any attributes in the previous class. So we will modify that. So to our phone class, or actually the methods which are present in our phone class, we will be adding some additional attributes. So we are adding a new method over here called as set color, and this set color method over here takes in two parameters. The first parameter is self because it is compulsory. Then we will have this new attribute called as color. And with this color parameter, what I'm doing is I will have an attribute called as color, and I am assigning this color to the attribute color which is present in my phone class. Similarly, I have another method called as set cost. This again has two parameters. First is self because again it is compulsory. Then we have this additional parameter called as cost. And I would also have an attribute called as cost in the phone class. And what I'm doing is I am assigning this value of cost to my attribute cost in the phone class. So now that I have assigned the value of color and cost to my attributes, what I'd have to do is show the value of color and show the value of cost. So now that I have set these, I would need two methods to show the color and show the cost. So that is why I will create a new method called as show color, and this only has the self attribute or the self parameter over here because I'm not assigning anything, and all I have to do is return the value. And if I have to return the value, I'll just use this keyword return and I'll print out return self.color. Similarly, if I would have to return the cost, I would have this new method called as show cost. This takes in only one parameter, which is self, and I'll go ahead and return. Here, as you see, I will have return self.cost. And these are the additional methods which I have. And then I have the same methods which are make, call and play game. And inside make call, all we are doing is printing out making a phone call. And inside play game, all we are doing is printing out playing a game. So let's go ahead and modify our phone class, which we had created earlier. I'll delete these records from over here. Let me cut this entire thing, or actually I can write it over here itself. So these are the methods which were present earlier. I would have to add 4 more methods inside this. So to create a method, we would have to use the def keyword, and I would have to set a color to the attribute. So I will use this method called as set color. The first parameter is self because it is compulsory. Then I will have this additional parameter called as color, and I am assigning the value of this color to the attribute color by using the self attribute or the self parameter which I have passed in. Now similarly, I will have another method over here. So as I have set the color, similarly I would have to set the cost as well. So def, I will have a new method called as set cost. This would take in 2 parameters. The first parameter would be self and the second parameter would be equal to cost. And over here I will write down self.cost is equal to cost, and this is how I'm assigning the value of cost. And after this I would have to print out the value of color and cost. I would need one method called as show color, and the parameter will only be self. And what this does is it would just return out the color. So it will be self.color. Then I would need another method called as show cost, and this again would take in only one parameter, which is self, and with the help of this I am returning out the cost. So here I will have self.cost. So these are the 4 additional methods which I have added inside this. So it seems that we have an error over here. Let me see what exactly is this. So this is line number 7 and this is set.cost. So here I would actually have to give in a comma instead of full stop over there. And now we see that we have successfully created this. Now after creating this class, I would have to create an object. So I will have p1 is equal to phone. And now that I have created this object, with the help of this object, I can access these methods and assign values to the color and cost. So I'll just invoke p1 dot set color, and I will set the color of this phone to be equal to, let me keep it blue over here. Now similarly I will also set the cost of it. So I'll have p1 dot set cost, and I will set the cost to be equal to, let's say, $999. Now that I have set the value of color and cost, I can print out these 2 values. So let me delete this. So I will have p1 dot show color. And now when I hit on run, you would see that the color is blue. Similarly, when I have p1 dot show cost, you would see that the cost is equal to 999. So this is how we can have additional attributes and pass in values to the attributes which are belonging to a class with the help of these additional parameters. Now there's a special example or a special concept in object-oriented programming which is known by the name of a constructor. So if you have worked with other languages such as C++ or Java, and if you have learnt about the concept of inheritance, you would know about a constructor. So normally in C++ or Java, a constructor is a special method which would have the same name as that of the class. And this would help us to initialize the values of the attributes during the object creation itself. So that is what a constructor is in Python itself. It's just that the constructor in Python, the name of this method will not be equal to the name of the class. So the constructor in Python goes by the name of init method. So here, as you see, this is our constructor. We have our init method over here and I have def. So in it, we have the prefix of 2 underscores, and also after init, we will have 2 underscores over here. So we have our constructor ready. And as I've told you, with the help of a constructor, we will be able to assign values to the attributes during object creation itself. So obviously we will have some parameters inside this, and with the help of these parameters, we'll be able to assign values to the attributes. So in this employee class, let's say I would have 4 attributes called as name, age, salary, and gender. So I'll have these 4 additional parameters over here. And I am assigning the value of name to this attribute. Similarly, I am assigning the values of age, salary, and gender. Now that the constructor is ready and I have assigned the values, I would have to show the values out. And to show the values, I have this new method called as employee details. And I will create this method like this. So I'll have def employee details and I will pass in self inside this because I'm not assigning anything, and this is the default or and we definitely have to give in the self parameter inside this. And inside this method, I'm just printing out the name of the employee, the age of the employee, the salary of the employee, and the gender of the employee. And once we create this class, we will go ahead and create an object of it. So here, when we are creating an object, as you see, we have E1 is equal to employee, and during the instantiating of the object itself, as you see, I am passing in the values for all of the attributes. So as you see over here, the name, I am assigning the name to be equal to Sam. Similarly, the age, I am setting it to be equal to 32. Then the salary, I am setting it to be equal to 85,000. And the gender, I am setting it to be equal to male. And this is how I am assigning all of the values during instantiating of the object. And once I have created the object, and since I have also given all of the values to the attributes, I can directly invoke the employee details method. And when I invoke the employee details method, you would see that I am able to print out all of the details. Name of the employee is Sam, age of the employee is 32, salary of the employee is 85,000, and gender of the employee is male. So let's go to Jupyter Notebook and implement this concept of constructor. So I'll just add this comment over here, constructor, and I will create this new class. So I will have class employee, and inside this I will go ahead and create the init method. Def, I will have 2 underscores, then I'll write down init, then again I'll have 2 more underscores over here. So I'll start off by giving the self attribute inside this, then I will start off by giving the name attribute, then I'll give in the age of the employee. After this I will give in the salary, and then finally we have the gender of the employee. And all I have to do is assign these parameters to the attributes which are present. So I will have self.name is equal to name, self.age is equal to age, self.salary is equal to salary, and self.gender is equal to gender again. So I have created this constructor over here. After this, I would have to create a new method called as show employee details. Let me just write down the name of this method. So I will have show employee details, and this will have only one parameter, which will be self. And inside this method, I'm going to print out all of the values of the different attributes which are present. So I'll start off by printing the name. So I'll have name of the employee is, I'll have self.name. Then I will have age of the employee is, here I'll have self.age. Then I will have salary of the employee is, here I will have self.salary. And finally I will have gender of the employee is, and here I will have self.gender. So let me hit on run, and I have successfully created this class where I have a constructor inside this. Now I can go ahead and create an object of this. So I will have E1 over here, and what I will do is I will give in the name of this class, which will be employee. The first value inside this should be the name of this person. So let's say this employee's name is Sam. Then Sam is 28 years old, and let's say Sam earns around $75,000. Let's make this $75,000, and Sam is male. So I have created this object over here. Now that I have assigned all of the values, I can go ahead and invoke the show employee details method. Here I will have E1 dot show employee details. And when I invoke this, you would see that I have this result. Name of the employee is Sam, age of the employee is 28, salary of the employee is 75,000, and gender of the employee is male. Now we'll understand the concept of inheritance. So simply put, inheritance is when you derive some properties from something else. And a real world example of inheritance would be, you'll be inheriting some of your features from your parents, and your parents will be inheriting some of their features from their grandparents. Or in other words, let's say you will sort of look like your parents in a way, and your parents might look like your grandparents in a way. So you're inheriting some physical features from your parents. Now, if we have to relate this concept of inheritance in Python, this basically means that we will have a child class and a parent class, and the child class would inherit some features or all of the features from the parent class. And we have an example of inheritance over here. So what we're doing is we are starting off by creating the parent class. So the parent class is called as vehicle. So we will have class of vehicle. And inside this, I have two methods. The first method is the default constructor. And in this constructor, I have two additional parameters, which are mileage and cost. And I am assigning the value of mileage. Then I'm also assigning the value of cost. And once this is done, I will go ahead and create another method called as show details. And inside show details, I'm printing out I'm a vehicle. Then I'll go ahead and print out the mileage of the vehicle. And also I'll print out the cost of the vehicle. So now that the parent class is ready, I would have to create an object of the parent class. So here I have V1 is equal to vehicle, and I pass in 500 and 500. So this 500 would denote the mileage of this vehicle. So this might basically mean 500 miles per gallon. Then we have the cost, which is 500 again. So this would mean that the cost of this vehicle is $500. So now that we have created this object, we can directly invoke the show details method with this object. So I have v1.showDetails, and as you have in the result, I'm a vehicle, mileage of the vehicle is 500 and cost of the vehicle is 500. Let's go to Jupyter Notebook and implement this. Let me delete all of these previous examples from over here. Let me keep it fresh. And I will create this new vehicle or new class called as vehicle over here. We will start off by creating the constructor. I would need the init method over here. And the first parameter is obviously self. After this, I would need the mileage of the vehicle and I would also need the cost of the vehicle. Then I'll go ahead and set out these two values. So I'll have self dot mileage is equal to mileage. After this, I will have self dot cost is equal to cost. Now that I have created this constructor, I would have to show the details. So I will have show vehicle over here, and this will just have one parameter, which is self. And inside this method, I will go ahead and print out some basic things. So first I'll be printing out I am a vehicle. Then I will go ahead and print out mileage of the vehicle is. Here I'll have self dot mileage. Then I'll go ahead and print out the cost. So I'll have cost of the vehicle is. Here I'll have self dot cost. And this is how I have created this class. And after creating this class, I would have to create an object of it. So I will have v1 is equal to vehicle. And inside this, I would have to pass in the mileage value first. So let's say this vehicle would give me around 120 miles per gallon and the cost of this vehicle is around $800. So I have set these values over here. Then I can just go ahead and invoke the show vehicle method. So here I will have v1 dot show vehicle, and when I run this, we have an error over here. Let's understand what exactly is this error. So we have self.mileage, we have self.cost inside this. Vehicle object has no attribute mileage. So I'm setting mileage. Let me keep it over here. Now when I run this, so as you see, I have successfully printed out I'm a vehicle, mileage of the vehicle is 120 and cost of the vehicle is 800. So we have created our parent class. Now it's time to go ahead and create our child class. So to create the child class, we will again go ahead and give the name of this class, which is car. So we'll have class of car, and to inherit something inside the parenthesis. So as you see, this class, we did not have any parenthesis over here, but after this child class, we'll have a parenthesis, and inside this, we will pass in the name of the parent class, which is vehicle. And this child class will have a method of its own, which is show car. This takes only one parameter, which is self. And I'm going ahead and printing out I am a car with this method. Now, once I create this child class, I will create an object of it, which is C1. Now here, as you see, even though I don't have a constructor inside this child class, but I'm passing in some values. This is because since this car class is inheriting the vehicle class, this will automatically have these two methods inside it. So this car class will have the init method and also the show details method. So this car class will have three methods in total, which are the constructor from the parent class, then the show details method from the parent class, and also this show car method, which is explicit for this car class. Now, since this also has the constructor, we would have to pass in the values for the mileage and the cost. And as you see, I am passing in the value for mileage, which is 200, and the value for cost, which is 1200. Then I'll go ahead and invoke the show details method with the help of this object of the child class. So as you see, this object is of child class, but this method is of parent class. But since this child class inherits the parent class, that is why we are able to invoke this method. And when you see the result, we have I'm a vehicle, mileage of vehicle is 200 and cost of vehicle is 1200. And since we also have this show car method, which is part of the car class, we can directly invoke it. So when I have c1.showCar, I get the result I am a car. So we already have our parent class over here. Now let me go ahead and create the child class as well. So I will have class of car, and I'll have this parenthesis, and inside this I will pass in this vehicle class. Then I would have to go ahead and create a method which is explicit to the car class. So I will have def, and I'll name this method as show car. This takes in only one parameter, which is self. And inside this, I will have the print method, and I will go ahead and just print out I am a car. And when I hit on run, you would see that we have successfully created this class. So after creating this class, I would have to create an object of this. So I will have C1 is equal to car. And since this inherits this will also have a constructor. So I would have to pass in a value for mileage. Let's say this car would give me a mileage of around 300 miles per gallon. And the cost of this car is around, let's say $10,000. So I'll pass in these two values over here. Now that I have passed the values, let me invoke the show details method. This is actually show vehicle method, which is there in the parent class. So C1 dot show vehicle, and as you see, I have the result. I'm a vehicle. Mileage of the vehicle is 300 and cost of the vehicle is $10,000. And since we also have this particular method over here, I can go ahead and invoke it. I will have C1 dot show car. This has to be small c. Now when I hit on run, you would see that I'm able to print out I am a car. Now we'll see how to override the init method in the child class. So in the previous example, we had created a child class where we had only one method over here. But what we'll do is we'll also have an init method in this child class, and this init method will take in 4 parameters. The first 2 parameters will just be the 2 parameters for the parent class. And since the vehicle class has mileage and cost parameters, I'll have them over here. I'll also have the self parameter, and I will add 2 new parameters for the car class itself. So I'll have tires and HP. Now to pass in the values for the super class or the parent class, I would need this super method. So I will write down super.init, which would basically mean that I am invoking the init method of the super class, or I am invoking the init method of the parent class. And inside this, I am passing in mileage and cost. So these are just values of the parent class which I am passing in. And after passing in the values of the parent class, I'll go ahead and assign the values for the child class as well. So here, as you see, self.tires is equal to tires. I am assigning the value of tires over here to the attribute of the car class. Similarly, I am assigning the values of HP over here to the attribute of the car class. And once I assign these values, I would have to show them out. So here I will have def of show car details, and I will print out I am a car. Number of tires are self.tires, and value of horsepower is this. And after I create the template of this child class, I can go ahead and create an object of this. So here, as you see, I will have C1 is equal to car, and I given 4 values over here. The first value will be for the mileage of the vehicle class. The second will be the cost of the vehicle class. So here, as you see, I'm a vehicle. And when I invoke C1.showDetails, so here, even though show details is part of the parent class, I'm able to invoke this because car class is inheriting from the vehicle class. And here I have mileage of vehicle is 20 and cost of vehicle is $12,000. And I also have 4 and 300. And as you see, when I invoke C1.showCarDetails, I have the result I'm a car, number of tires are 4, and value of horsepower is 300. So I'll go ahead and create the parent class again and child class again over here. So I will have class of vehicle, and this will take in, this will have init method. So I'll write down def over here. I will write down init, and this will definitely have the self parameter over here. And this has 2 values, which are mileage and cost. Now I would have to assign these values. So it will be self dot mileage is equal to mileage over here. Then I will have self dot cost is equal to cost. And this is how I am assigning the values for mileage and cost. Once I do this, I would have to go ahead and print out the values. So I will have a new method for it. I will have def of show car details over here. and this will only have one parameter, which is self. And I will start off by printing I'm a vehicle. And after this, we would have to print out the mileage of the vehicle is. The mileage of the vehicle is, here it will be self dot mileage. Then I'd have to also print out the cost. The cost of the vehicle is, here it will be self dot cost. And this is how we have created this template for the vehicle class. Now I'd have to create the template for the child class as well. So here it will be class of car, and since this is inheriting from the vehicle class, I'd have to pass the vehicle as the parameter inside this. And after that, I would have to override the init method. And since I have to override, I need to create an init method of the car class itself. And I'll start off by giving the self parameter. Then this will have mileage and cost for the parent class. Then it will have tires and HP, which are exclusive to the car class itself. And after this, I will invoke the super method. So this is, with the help of this, I'll be able to invoke the init method of the super class. So I will have super dot init, and inside this I will just pass in mileage and cost. And once I do this, I would have to assign the values for tires and HP. So it will be self dot tires is equal to tires and self dot HP is equal to HP. And now that I have created this init method or overridden this init method, I would need an explicit method for the car class itself. Let me give it a space over here, and this time it will be def of show car details, and I'll have self over here. And after this will actually only have self and nothing else, and I'd have to go ahead and print out I am a car. And after this, I'd have to print out the number of tires are. Here it will be self dot tires, and after that I'd have to print out the horsepower as well. So here it will be the horsepower is, and the value will be equal to self dot HP. And now that I have created the parent class and the child class as well, I'd have to create an object of it. Here it will be equal to C1 is equal to car. And I'd have to give in the value of mileage and cost. Let's say the value of mileage is around 30. So it would give around 30 miles per gallon. And the cost, I would say this is $5,000. And after that, let's see, this car would have 4 tires, and the horsepower of this would be equal to 499. And we have created the object of this. Now that we have also assigned the values, I can go ahead and invoke the methods of the parent class and the child class. I will have C1 dot show car details over here, and you would see that I have printed out I'm a car. The number of tires are 4 and the horsepower is 499. So these are the details of the child class or the car class. Now I'll print out the details of the parent class. So here I will have C1 dot show vehicle details. And when I print this out, this is, so seems like I've overridden this. I will keep the name as show vehicle details over here. So this method in the parent class will be show vehicle details, and this method in the child class will be equal to show car details. And once I have done this, you would see that I have this result. I'm a vehicle, the mileage of the vehicle is 30, and the cost of the vehicle is equal to 5,000. Going ahead, we'll look at the different types of inheritance. So we've worked with single inheritance. Now we'll see what is multiple inheritance and what is multi-level inheritance. So we'll start off with multiple inheritance, and in multiple inheritance, will have a child which inherits from more than one parent class. So let's say if you have a mother and a father, obviously you will have a mother and a father, and you would be inheriting some of the features from your mother and some of the features from your father. And thus what is happening over here is known as multiple inheritance. So as you see, if there's a child class, this child class will be inheriting some features from parent 1 and some features from parent 2. And this is what is known as multiple inheritance. And let's have a look at this over here. So we are starting off by creating the first parent class of parent 1. I have two methods over here. In the first method, I am assigning the value for string 1. So assign string 1, I have self and str1. And with the help of this, I am assigning the value for this attribute of str1 in this parent 1 class. Then once I assign the value for this str1, I'll go ahead and show out this value or return this value with show string 1. So in parent class 1, I'm assigning the value for string 1. Then I have parent class 2, and with the help of parent class 2, I am assigning the value of str2 first. Then I will go ahead and return the value of str2. Then I will have a child class. I will name this child class as a derived class, and this over here takes in two parameters, or in other words, this is inheriting from parent 1 and parent 2. And this again has two methods over here. The first method is assign string 3, and I am assigning the value for string 3 over here. Then I will go ahead and show it out. As you see, I am returning, or I am printing out self.str3. So parent class 1, parent class 2, and child class. And after that, what I'm doing is I am creating an object of the derived class or of the child class. And here I have d1.assign string 1. So even though assign string 1 and assign string 2 belong to the parent class, I'm able to invoke them because child class is deriving from both of the parent classes. So here I am assigning the value of 1 to string 1, I am assigning the value of 2 to string 2, and I am assigning the value of 3 to string 3. Once I given the values, I go ahead and show out the values over here. So d1.show string 1, I get 1, d1.show string 2, I get 2, and d1.show string 3, I get 3. Now this is a bit confusing. Let's go to Jupyter Notebook over here, and let's create our two parent classes and one child class. So for this purpose, I'd have to given this keyword class, and I'd have to given the name of the first parent class, which is parent 1. And after this, I will create a method def, and I will name this method as assign str1. This will have two parameters. The first parameter will be self, next will be str1 over here. And I'll just write down self.str1 is equal to str1 over here. And once I assign the value, I'd have to print out this value or show out this value. So for that purpose, I would need another method. Here it will be show str1. And what I'll do inside this is this will only have the self attribute, and I would have to return the value of string 1. So this will be equal to return of self.str1. And you would see that I have created the first class, first parent class. Similarly, I'll go ahead and create the second parent class. This time it will be equal to class of parent 2. And here I will have def of assign str2. It will be self. I will have str2 over here, and I'd have to assign the value. This will be equal to self.str2 is equal to str2 over here. And I'll go ahead and create the next method. I will have show str2. I'll have self over here, and I'd have to return str2. And I have also created the second parent class. Now that both of my parent classes are ready, I can go ahead and create the child class. So here class of, I'll just name this child class as child because that is more intuitive. And inside this, I will be passing in both of the parent classes. I'll have parent1 as well as parent2. And now that I pass in both of the parents, I'll create one method exclusive for the child class itself. And inside the parent class, I'll be assigning the string 3. Assign str3 over here. This will have the self parameter. And I'll have str3 over here. And this is how I'll be assigning the value. Self.str3 is equal to str3. And once I assign the value, I would have to go ahead and print it out. So here it will be show str3. It will be self over here, and I will go ahead and I will return. So again, here I'd have to keep in mind that this is self of str2, and here again it will be equal to self of str3. And as you see, I have created all of the 3 classes, 2 parent classes and 1 child class, which is inheriting from these 2 parent classes. Now I can go ahead and create an object of this. So here I will have C1 is equal to child. Once I have created this object, I can go ahead and invoke the methods. So I'll start off by invoking the method of the first parent class. So C1.assign str1. Inside this, I will pass in the value of 1 over here. Then I will go ahead and invoke the method of second parent class. This will be equal to assign str2. Inside this, I will pass in the value 2. Then I will go ahead and invoke the method of the child class itself, assign str3, and inside this I will pass in the value 3. Once I invoke all of this, then I can go ahead and print them out. So I will have show str1, and you would see that I have printed out 1. Then I will have c1.show str2. Then I would have, we have an error over here. So let's check this properly. Self.str2, we are assigning the value over here and we are returning this over here. C1.show str2, name str2 is not defined. So what I'll do is I'll run all of these again because I had added the self parameters. And this time we need to get the result. And this time, as you see, when I have c1.show str2, I get 2 over here. Now, similarly, I'll go ahead and invoke the third string. So I will have c1.show str3. And this time, when I hit on run, you would see that I get the result 3. So this is how we can implement multiple inheritance. Going ahead, we have something known as a multi-level inheritance. And you can consider multi-level inheritance to be grandfather father child relationship, and as a grandchild inherits his or her features from maybe his parents, and those parents inherit their features from their grandparents. So here you have multiple levels, and this is what is known as a multi-level inheritance. So here we have 3 classes. We start off by creating the parent class first, and in the parent class we are assigning the name of this person. And then we are showing out the name of the person. Then in the child class, we are assigning the age of the person and we are showing out the age. And as you see, this child class is inheriting from the parent class. Then we have the grandchild class where we are assigning the gender and we are showing out the gender. And here you see that the grandchild class is inheriting from the child class. So here there are 3 levels. Child class is inheriting from the parent class and the grandchild class is inheriting from the child class. Now let's go to Jupyter Notebook and implement this. We'd have to start off by creating the parent class. I will have class, I'll have parent over here. And inside this, I will create a new method called as assign name. This will have self and then we will have name over here. And inside this, I'll just write down self.name is equal to name. This is how I'm assigning the name. Then I'd have to show out the name. And for that purpose, I will have show name. This will only have self over here, and I need to return self.name. And I have created the parent class. Now after this, I would have to create the child class. So here I will have class of child. I will create a new method over here, and I will name this method as assign age. I will have self. I'll have age over here, and I need to assign this age. So here it will be equal to self.age is equal to age. Then I would have to show out the age. I'll have to create a new method. This will be equal to show age. I'm writing down self over here, and I would have to return this. So this will be equal to return self.age, and this child class is inheriting from the parent class. So that is why I'll pass in the parent class as a parameter to the child class. Then finally, I will create the grandchild class. Here I will have class of grandchild, and this grandchild class will be inheriting from the child class. This again will have two methods. The first method will be assign gender, and this is how I am passing in the two parameters. I'll have self and gender, and here I would have to set self.gender is equal to gender. Then I will create a new method over here, show gender, and here I will only have self, and I would have to return this. It will be equal to return self.gender. And now that I have created these three classes over here, I have my parent class, the child class, and the grandchild class. I can go ahead and create the object of the grandchild class. I'll call it GC, and I will invoke it like this. And once I create this grandchild class, I can assign the name, age, and gender. So I will have gc.assign. Let me write it down again. So here it is gc.assign name, and the name which I am setting or giving to this person is Bob. Then I'd have to give him some age. So here it will be gc.assign age, and let's say Bob is 54 years old, and I'll also assign the gender. This will be equal to gc.assign gender, and the gender is male. I have assigned these three things. Now I'd have to go ahead and show them out. So here it will be gc.show name, and I am setting the name to be equal to, I don't have to give anything over here. I just have to invoke it, and as you see, I get the name of this person as Bob. Now let me also invoke the age over here, gc.show age. You would see that the age of this person is 54. Then I will have gc.show gender, and here as you see, the gender of this person is male. Now that we have created these NumPy arrays, we'll now see how to create or how to initialize a NumPy array with different ways. So now let's say if I want to initialize a NumPy array with only zeros, then we have a method called as zeros. It's very intuitive, isn't it? So here we are importing the NumPy array, then we are using np.zeros, and it takes in two parameters. So these two parameters basically indicate the dimensions of the NumPy array. So if I want to create a 1x2 NumPy array where all of the values are zeros, then I can just go ahead and type in np.zeros, and inside this I'll pass in the dimensions, which is 1, 2, and I get a 1x2 NumPy array where the values are only zeros. Similarly, over here, I am creating a 5x5 NumPy array where all of the values are zeros. So I'll just use np.zeros, and inside this, I'll pass in 5, 5. Now let me go ahead and implement this in Jupyter Notebook. Here, I'll add the comment np.zeros. Now I'll go ahead and let me just create this in n1, and inside n1 I'd have to use the np.zeros method, and over here I'd have to pass in the dimensions. So the dimensions would be 1, 2, and let me go ahead and print out n1 over here. So as you guys see, I have successfully created this numpy array. Now if I want maybe a numpy array with a different dimension, so the method would be the same. I'll have np.zeros over here, and inside this, let's say I want to create a 3x3 numpy array which consists of only zeros, and this I'll go ahead and store it in this object called as n2. Now let me print out n2 over here, and we have a 3x3 numpy array which comprises of only zeros. Now if I want to initialize a numpy array with the same number, then we can go ahead and use the full method. So here I am using np.full, and this takes in two parameters. The first parameter is the dimension of the numpy array. The second parameter is the value which we'd want to insert into this numpy array. So here we are creating a 2x2 numpy array where the value is filled with 10. So as you guys see, it's a 2x2 numpy array where we only have tens. So it's time for np.full. I'll just type in np.full. I'm adding a comment over here. Then let me add np.full, and I'd have to give in two parameters. Let's say I'd want a 4x8 numpy array, and I'd want the value 5 inside this. Now I'll store this in this object called as n3, and I'll just print out n3 over here. And as you guys see, I have created a 4x8 numpy array where the value is only 5. Now similarly, if I want to initialize a numpy array within a particular range, then I can go ahead and use the arange method. So here, as you guys see, I am using np.arange, and this again takes in two parameters. The first parameter is the initial value from which the range has to start. So here when I give in 10, as you guys see, the range starts from 10. And when I give in 20, so here again you'd have to remember that 20 is exclusive, or maybe the second parameter is exclusive. And since this is exclusive, we'll only have values starting from 10 and going on till 19. And that is why 20 is not included in this result over here. Now we can go ahead and add another parameter. So here the initial value is 10, the final value is 50, and we have the skip value. So the skip value is 5, which would mean that after 10 we'll have 15. So 15 plus 5 becomes 20, 20 plus 5 becomes 25, and that is how this keeps on proceeding. Now when we reach 45, when you add 5 more to 45, that becomes 50. And since 50 is exclusive over here, that is why we end at 45. But on the other hand, if we had given the final value as 51, then we would also have the element 50 over here. So let's go ahead and implement arange method over here. np.arange, and I'll store this in n4. Now I'd have to use np.arange, and I'll go ahead and give in the initial value as, let's say, 100. Then I'll give the final value as 200, and I'll print out n4 over here. And as you guys see, we have all of the numbers in sequence starting from 100 going on till 199. Now if I actually want the value 200 to be included in this as well, let me make the final value to be 201. And as you guys see, this time the range starts from 100 and also includes 200 over here. And we can also add a skip value. Now let's say if I give them the skip value of 10. So here after 100 we have 110, then 120, and this goes on till 200. Now instead of 201, if I keep the final value as 200, we see that this numpy array ends at 190 because 200 is exclusive. Now we can also go ahead and initialize a numpy array with random numbers. And to initialize numpy array with random numbers, we can use random.randint. So here we are invoking np.random.randint, and over here we have three parameters. The first parameter is basically And over here we have three parameters. The first two parameters basically indicate the range from which we would want the random numbers. So we would want the random numbers in this range of 1 to 100. And this third parameter would tell the Python interpreter how many random numbers do we need. So in the range of 1 to 100, we would need 5 random numbers. And as you guys see, this is the result which you get over here. So we have 95, 88, 26, 22 and 76, which are 5 random numbers generated between the range of 1 and 100. I'll add this comment random. Now let's go ahead and initialize a NumPy array with some random numbers. So I'll have np.random.randint because I want a random set of integers. And this will take in 3 parameters. Let's say I would need values between 50 and 100, and I would need 10 random values over here. And let me store this in N5. Let me go ahead and print out N5 over here. And as you guys see, I have 10 random values which are generated between the range of 50 and 100. Similarly, if I go ahead and run this again, I'll get a different set of values. As you guys see, we have a different set of values again. When I click this, we again have a different set of values. That was all about initializing a NumPy array with different methods. Now you can also go ahead and check the shape of a NumPy array. And to check the shape of a NumPy array, we have the shape method, which again is very intuitive. So here we are creating a NumPy array where we are passing in a list of lists. So in the first list, we have 1, 2 and 3. In the second list, we have 4, 5 and 6. So obviously we will have a NumPy array where we'll have 2 rows and 3 columns. And this is what the n1.shape gives us. Now, if we want to change the shape of this, then we can use the same method. So here what I'm doing is I'm typing in n1.shape and I'm changing the shape from 2, 3 to 3, 2. That is, instead of having 2 rows and 3 columns, I will have 3 rows and 2 columns. So this same shape method can be used to check the shape of the NumPy array and also reshape the dimensions of the NumPy array. So let me create a NumPy array over here. So we would have to create a multi-dimensional NumPy array. So this will be n6 is equal to, I'll have np.array, and inside this I'll have to create a list of lists. So in the first list, I'll have values 10, 20 and 30. And in the second list, I'll have values 40, 50 and 60. And I'm storing this in n6. Now, once that is done, let me just print out n6 over here. So you guys can see this NumPy array. Now I'll also go ahead and check the shape of it. So I'll have n6.shape. And we get the result that this is a NumPy array where we have 2 rows and 3 columns. Now I can also go ahead and change the shape of this. So I'll have n6.shape. And over here, I am changing the shape to be equal to 3, 2. Then I'll go ahead and print out n6. And as you guys see, we have converted this from a 2 x 3 NumPy array to a 3 x 2 NumPy array. So you had 10, 20, 30 in the first row. We've got 10, 20 in the first row here. So similarly, this is how this has been changed. Then we have some stacking methods over here. We have vstack, headstack and column stack. So let's just start with vstack. So we are creating a NumPy array n1 where we have the values 10, 20 and 30. Then we are creating the NumPy array n2 where we have the values 40, 50 and 60. Now when we use vstack over here, this again takes in 2 parameters where we'll just pass in 2 NumPy arrays inside this. So as you guys see, we are vertically stacking over here. So when I say vertically stacking, I have one NumPy array on top of another NumPy array. So because I'm using n1, n2, n1 comes at the top, n2 comes at the bottom. So this is how vertical stacking works. Then we can also go ahead and horizontally stack 2 NumPy arrays. So n1 and n2, we've got the same NumPy arrays over here. And instead of using vstack, I'm using the headstack method. I'm passing in n1 and n2. And as you guys see, 40, 50 and 60. So n2 has been stacked horizontally to n1. Then we have the column stack. So if we want to stack these NumPy arrays into separate columns, so we have N1 and N2, and when I'm using column stack over here, as you guys see, N1 goes into the first column, N2 goes into the second column. And this is how we can work with these stacking methods. So I'll have to create these two NumPy arrays over here. I'll have N1, which will be np.array, and inside this I'll have 1, 2, and 3. Then I'll also go ahead and create N2. So this will be np.array, and inside this I'll have 4, 5, and 6. So I have my N1 and N2 ready. Now I'll start off with vertical stacking. So I'll use np.vstack, and inside this I'm passing in N1 and N2, and let's see what would be the result. So we have vertically stacked N1 with N2. N1 is at the top, N2 is at the bottom. You can also change how these are stacked. So instead of giving N1, N2, let's say if I give in N2 and N1, you guys would see that N2 is at the top and N1 is at the bottom. Now we can similarly work with the head stack method. So here I'll type in np.hstack, and inside this again I'll pass in N1, N2. And as you guys see, I have stacked N2 at the back end of N1. Now, if I want N2 first and N1 second, I just have to change the sequence. So inside np.headstack, I'll give in N2, N1. And I have 4, 5, 6 first, and N1 is attached at the back end of N2. Then we have column stack. So I'll just have np.column stack over here, and inside this I'll pass in N1, N2. And as you guys see, I have N1 in the first column, N2 in the second column. Similarly, if I give in N2, N1, you will see that I have N2 in the first column and N1 in the second column. So this is all about stacking the NumPy arrays. Now we'll also work with intersection and difference methods. So here again we have two NumPy arrays. So in the first NumPy array we have the values from 10 to 60, and in the second NumPy array we have the values from 50 to 90. And if I want the common elements between these two NumPy arrays, then I can use the intersect1d method. So here in the intersect1d method, I would just have to pass in these two NumPy arrays. And as you see in the result, we get a new NumPy array comprising of the common elements in these two NumPy arrays. Then over here I have N1 and N2. If I want to find out all the elements which are unique to N1, then I can use the setDiff1d method. So here in N1 we have the elements starting from 10 going on till 60. In N2 we have elements starting from 50 going on till 90. So here as you guys see, 50 and 60 are common in N1 and N2. And if I want the elements which are unique to only N1, then I would have to use setDiff1d, and I'll pass in N1 and 2. As you guys see, I get only 10, 20, 30 and 40 because 50 and 60 are present in both the NumPy arrays. I can also change the sequence over here. So instead of passing in N1, N2, when I pass in N2, N1, then this will give me all of the unique elements which are present in N2. And since 50 and 60 are common in both the NumPy arrays, the resultant will be 70, 80 and 90 because these are the only unique elements in N2. So let's go ahead and work with intersect1d and setDiff1d. I'll just add a comment over here, intersect1d, and I would have to create two new NumPy arrays. I'll have N1 over here. So I'll have np.array, and inside this I'll pass in 1, 2, 3, 4, 5, 6, and I'll have N2, and inside this I'll go ahead and create a list of elements where the elements start from 5, 6, 7, 8 and 9. So I have these two set over here. Now that my two NumPy arrays are ready, if I want to find out the common elements which are present in these two NumPy arrays, I'd have to use intersect1d. So I'll have np.intersect intersect 1D, and inside this I'm passing in n1, n2, and when I hit on run, we see that the common elements between n1 and n2 are 5 and 6. Now if I want only the elements which are common to n1, then I can use the setDiff1D method. So here I'll have np.setDiff1D, and inside this again I'll be passing in n1, n2, and as you guys see I have 1, 2, 3 and 4 which are common to only n1. Now similarly, if I want all of the elements which are only common to n2, then I can have np.setDiff1D, and I'll just change the sequence over here. Instead of passing n1, n2, I'll have n2, n1, and the only unique elements which are there in n2 are 7, 8 and 9. Now we'll go ahead and perform some simple NumPy array mathematics. So we'll see how to add two NumPy arrays. So again over here we have two NumPy arrays. In n1 we have 10 and 20, in n2 we have 30 and 40. Now if I want the total sum of all of the elements which are present in both of these two arrays, I can just directly use the sum method. So I'll have np.sum, and inside this as a list I'll pass in n1, n2, and you will see that the resultant value would be 100 because 40 plus 30 plus 20 plus 10 is equivalent to 100. Now if I want to find out the individual sum along the rows and along the columns, then I can use the additional parameter called as axis. So if I want to sum the values along the column, then I'll set the axis to be equal to 0. So when I have the axis value to be equal to 0, as you guys see, I have 30 plus 10 equal to 40 and 40 plus 20 equal to 60. Similarly, if I want to sum these up along the rows, then I'll set the axis value to be equal to 1. And over here I have 10 plus 20 equal to 30 and 30 plus 40 equal to 70. I'll add a new comment over here, addition of NumPy arrays, and let me create new n1 over here. So I'll have np.array, and inside this I'll have 10 and 20. Then I'll go ahead and create n2, and inside n2 I'll again have np.array, and over here I'll have 30 and 40. I'd have to pass this on as a list of values, so I'll have 30 and 40 inside a list. So I have created n1 and n2. Now it's time to find out the total sum which is present along all of these. So I would have to use np.sum, and inside this I'll just pass in n1, n2, and actually I'd have to pass this as a list. So I'll have n1, n2 over here, and as you guys see, the resultant comes out to be 100. If I want to add the values along the column, so I'll have np.sum, then I'll have this list over here, I'll have n1, n2, then I'll have this new attribute called as axis, and I'll set the axis value to be equal to 0. And I get the resultant 40 and 60 because 30 plus 10 is equal to 40 and 40 plus 20 is equal to 60. Now going ahead, if I want to add the values along the horizontal rows, so here it will be np.sum, and over here I'll have n1, n2 again, and this time I'll set the axis value to be equal to 1, and I have 30 and 70 because 20 plus 10 is equal to 30 and 40 plus 30 is equal to 70. Now we'll see how to do some scalar operations on these NumPy arrays. So here we have a NumPy array where we have values 10, 20 and 30, and if I want to add the scalar value 1 to each individual element of the NumPy array, all I have to do is add this value 1 to this NumPy array, and as you guys see, n1 plus 1 becomes 11, 21 and 31. Similarly, if I want to multiply each individual element of a NumPy array with a particular value, so here if I want to multiply it with 2, I'll just write down n1 into 2. So 10 becomes 20, 20 becomes 40 and 30 becomes 60. And if I want to subtract a value, all I have to do is perform n1 minus 1. So 10 becomes 9, 20 becomes 19 and 30 becomes 29. And if I want to divide it, I'll just have n1 divided by 2. So 10 becomes 5, 20 becomes 10, and 30 becomes 15. So this was some basic idea about NumPy. Now let me just see what is there in n1 over here. Let me actually add some more elements inside this. So I'll have n1 is equal to np.array. And inside this, I'll have 10, 20, 30, and 40. Let me also print out n1 over here for your reference. So now that we have n1, what I can do is I will just go ahead and add some scalar values to it. And let's say if I want to add 5 more to each individual element of this NumPy array, so I'll just write down n1 plus 5. And as you guys see, 10 becomes 15, 20 becomes 25, 30 becomes 35, and 40 becomes 45. Similarly, if I want to subtract a value, I'll just write down n1 minus 5 over here. And 10 becomes 5, 20 becomes 15, 30 becomes 25, and 40 becomes 35. We can also go ahead and multiply something to this. So I'll have, let's say, n1 into 10. Let me print this out. And as you guys see, we have multiplied these values with 10. Similarly, I can go ahead and divide this with something. So if I have n1 divided by 10, so we see 10, 20, 30, 40 becomes 1, 2, 3, and 4. So this is some basic scalar operation on top of the NumPy arrays. And we can also go ahead and use some mathematical functions. So we have this mean function over here, which would give us the mean value of all of the elements which are present. So the mean value of all of these elements comes out to be 35. Similarly, if we want to find out the median, then all we have to do is use this median method. We have to use np.median, we'll pass in this NumPy, and we see that the median value comes out to be 55.5. And if you want to find out the standard deviation, I'd have to use std, and I'm passing in n1 inside std, and the value becomes 36.59. So we have n1 over here, and if I want to find out the mean value, I'll just have np.mean, and inside this I'll be passing in n1. And as you guys see, the mean or the average value of all of the elements which are present in n1 comes out to be 25. Let me go ahead and create another NumPy over here. So I'll have np.array, and inside this I'll be passing in some random values. So let's say these are all of the values which are present in n2. And if I want to find out the median of all of the values which are present, so I'll just use np.median method, and inside this I'll be passing in n2. And the median of all of these values comes out to be 5. Similarly, if I want to find out the standard deviation, so here I'll have np.std. And if I want to find out the standard deviation of this particular NumPy array, so I'll pass in n2, and you would see that the standard deviation of all of the elements of n2 would be 2.397. So till now we've worked with some basic NumPy arrays. Now let's go ahead and work with a NumPy matrix. So here we are creating a 3x3 NumPy matrix, and to do that you'll again need a list of lists. So over here we'll have 1, 2, 3, 4, 5, 6, and 7, 8, 9. So this first list goes into the first row, second list goes into the second row, and third list goes into the third row. Now that we have created this NumPy matrix, let's see how can we access individual rows and columns from this entire NumPy matrix. So here, let's say if we want to access the first row, again you'd have to remember that the indexing in Python starts from 0. If we want to extract the entire first row, we'll just have n1, and inside parenthesis we'll pass in 0. And as you guys see over here, I have successfully extracted the entire first row. Similarly, if I want to extract the entire second row, then the index value for second row will be 1, and I have extracted the second row. And if I want to extract a column, then I'd have to do something like this. So in a column, I would want all of the rows. So here from this NumPy matrix, I would want the second column and all of the rows from the second column. So here, since I would want all of the rows, I'll just put in a colon over here. And since I want the second column, I'll give in the index value as 1. And as you guys see, I have extracted the entire second column over here. Similarly, if I want to extract the entire third column, the index value will be 2, and I have extracted the entire third column. Let's perform this in Jupyter Notebook. So I'll just write in Numpy metrics over here. Now that this is set, I'll have np.array, and over here I'll have a list of lists. So in the first list I will have 10, 20 and 30. In the second list I will have 40, 50 and 60. In the third list I will have 70, 80 and 90. And I will go ahead and store this in n1 again. Now I'll go ahead and print out n1 and let's see what would be the result. So this is our NumPy array which we have just created. Now if I want to access individual rows from this, I'll have to give in n1, and inside parenthesis, let's say if I want to extract the third row, then the index for the third row will be 2. I'll just have 2 over here. And as you guys see, I have successfully extracted the entire third row. Now similarly, if I want to extract the entire third column, then this time I would have to write n1. And over here, since I would want all of the records from the third column, so I'll just have a colon over here, then over here. So here you'd have to understand whatever is given on the left side of the symbol would indicate rows, and whatever is given on the right side of this comma would indicate all of the columns. So I'd want all of the rows, and all of these rows need to be from the third column, and the index for the third column is 2. And I have successfully extracted all of the elements which are present in the third column. Now we'll see how to transpose a matrix. So what is transposing? Transposing basically means when you're interchanging the rows and columns. So here, as you guys see, we have 1, 2, 3, 4, 5, 6 and 7, 8, 9. Now the rows should be interchanged with the columns. So here 1, 2, 3 which is present in the first row comes into the first column. 4, 5, 6 which is present in the second row comes into the second column. 7, 8, 9 which is present in the third row comes into the third column. Let's go ahead and perform transpose as well. So all I have to do is use np.transpose, and inside this I'll just pass in n1 over here. So as you guys see, initially I had 10, 20, 30 which was in row. This became in column. 40, 50, 60 was in second row, became the second column. 70, 80, 90 was the third row, which became the third column over here. Now we'll see how to perform two matrices. So over here we have n1 where we have the elements starting from 1 going on till 9. Then we have n2 where we have elements starting from 9 going on till 1. Now if we perform the dot operator on this, which is basically matrix multiplication, this is how the multiplication happens. So the multiplication is row by column, which would basically mean, so here we have 1, 2, 3, here we have 9, 6, 3. So it will be 1 into 9 plus 2 into 6 plus 3 into 3, which will give you a result of 30. Then again we'll have row by column. So here it will be 1 into 8 plus 2 into 5 plus 3 into 2, which will give you a result of 24. Then it will be 1 into 7 plus 2 into 4 plus 3 into 1, which will give you a result of 18. And this is how this progresses, and finally we'll get this result over here. And the dot product of n1 into n2 and n2 into n1 will be different. So as you guys see, this is the dot product of n1, n2, and this is the dot product of n2, n1. Both of these will be different. So I already have n1 over here. Let me go ahead and also create n2. So here I'll write n2 is equal to np.array, and over here I'll have the elements in reverse order. So I'll have 90, 80, and then I'll have 70. Going ahead, I'll have 60, 50 and 40. After this, I'll have 30, 20 and 10, and I am storing this in this object called as n2. Let me also go ahead and print out n2 for you guys over here. So this is what we have. Now if I want to perform the dot product, so I'll have n1. I'll actually have, if I want to perform the dot product here, I'll have n1 dot dot. Inside this, I'll pass in n2. And as you guys see, this is the dot product of n1 cross n2. But we know that n1 cross n2 and n2 cross n1 is different. So when I perform n2 dot n1, the result will be different from n1 dot n2. So this was about matrix multiplication. Now we'll go ahead and see how can we actually save a NumPy array and then load it from somewhere else. So here we are creating this NumPy array where we have elements from 10 to 60. Then to save this NumPy array, we just have to use the save method. And over here we are saving this NumPy array with this name called as my_NumPy. So this takes in two parameters. First parameter is the name by which we'd want to save this NumPy array. Second is the array which we'd want to save. Now once that we save this, to load this NumPy array, we will have to use np.load, and over here we'd have to give in the name by which we save this NumPy array. So we save this NumPy array as my_NumPy, and we'd have to give the extension which is .npy, which basically stands for NumPy, and we go ahead and store this in n2 and we print out n2. We see that we have successfully loaded this NumPy array over here. Now I'll go ahead and save this. So I'll have np.save, and this, as we have seen, takes in two parameters. The first parameter is by which I save this. So I'll have save n1, and I would want to store n1. So I have saved this. Now if I want to load this, I would have to use np.load, and over here I'd have to give the name of the NumPy array. So it will be save_n1.npy. Let me actually remove this over here, and I will store this in, let's say, n9. Let me click on run over here. So we have an error over here. We have this error because I'd have to give this inside single quotes. Now if I click on run, we'll get the result. Now if I print in n9 over here, we finally get the result. So Pandas stands for panel data and is the core library for data manipulation and data analysis. So if you want to perform any sort of data analytical task, Pandas should be your go-to library. And Pandas provides single and multi-dimensional data structures for the purpose of data manipulation. So the single dimensional data structure is known as the series object, and the multi-dimensional data structure is known as the data frame. We'll start off by understanding about the series object. So series object is a one-dimensional labeled array. So we have already worked with the NumPy array. So in NumPy array, we had no labels along with it. It was just a simple blank array where we had stored some values. But over here in a series object, as you guys see, we have labels, or you can consider them to be indexed with labels over here for these. So first we'd have to start off by importing Pandas, which is the library, and we are giving this alias as PD. So import Pandas as PD. Then if we want to create a series object, we'll have pd.series, and inside this I am passing in the values 1, 2, 3, 4 and 5. And when I print it out, I get this series object. So when I check the type of this, type of S1, this gives me pandas.core.series.series. Now over here, you'd have to keep in mind that S is capital over here. So if you're given a small s, you will get an error. So let's go ahead and create our first series object. So I'll just add the comment pandas. Now our first task could be to import the Pandas library. So I'll go ahead and type in import Pandas as PD. Let's just wait for this to be loaded properly. Now that we have loaded the library, I can go ahead and create the series object. So I'll type in pd.series, where S is capital. Inside this, I'll pass in the list of values. So let's say I'll just have 10, 20, 30, 40 and 50, and I'll go ahead and store it in this object called as S1. Let me print out S1 over here, and as you guys see, I have created this series object. Let me also check the type of this. So inside the type method, when I pass in S1, you guys would see that this is a series object. And over here, we have the labels. So the labels are 0 to 4. So by default, the label or the index starts with 0 over here. So 10 is present at label or index 0, 20 is present at index 1, 30 is present at index 2, and that is how it proceeds further. Now, since we have labels in a series object, we can change how the label of the index looks like. So over here, we just had numbers starting from 0. But instead of numbers, let's say if I wanted alphabets over here, then I can add a new attribute called as index. So over here with this index attribute, I am setting the values to be equal to A, B, C, D, E. So here initially we had index 0. 0 has been changed to A. Then we had 1, 1 has been changed to B. We have 2, 2 has been changed to C, and that is how it proceeds. So now over here, let me go ahead and change these index values. So it is the same command over here. And with this same command, all I'm doing is adding a new attribute called as index. And I'll pass in a list of values for the indices. So I'll have A, B, C, D. Let me have D over here, and I'll have E. Now, when I click on run and I print out S1 over here, you guys would see that I have changed the indices from 0 to 4 to A to E. Now we can go ahead and see how to create a series object from a dictionary. So we have already worked with dictionaries. We know that the dictionary is a key value pair. So here we'll just give in pd.series, and over here we have 3 key value pairs, A10, B20, C30. So here automatically the keys are taken as the labels, and these values are taken as the series values over here. Let me create a new dictionary. So I'll have D1, and inside D1, let me have 4 key value pairs. Maybe I'll have A and 10. Then I'll have B and 20. After that, I'll have C and 30. Going ahead, I'll have D and 40. Now I'll just go ahead and print this out. As you guys see, I have successfully created this dictionary. Now I would have to create a series object out of this. So I'll just have pd.series, and inside this I'll pass in D1, and let's see what would be the result. So these 4 keys which were present became the labels, and these values over here in the dictionary became the series values as well. Now we can also go ahead and change the index position. So similarly, as we had actually changed the index values from numerical to alphabetical. So when I given the index values as B, C, D, A, this sequence is maintained. So I have B and C first. So for B, I have the value 20, C, I have the value 30. And D, we had not created any key with this particular index. So that is why we have NaN over here. And then we have A, for which we have the value 10. So this is how we can maybe add a new index position or change the existing index positions. So this is what we had over here. This was our series object. And now what I'd want to do is, so instead of A, B, C, D, I would want, let's say, C, B, A, and D. And if I click on run, you guys see that the sequence has changed over here. Now we'll also see how to extract individual elements from the series object. So here we have all of these elements starting from 1 going on till 9. And again, you'd have to keep in mind that the indexing starts from 0. So if I want to extract this particular element over here, so the index value for this would be 3. So 0, 1, 2, and 3. And when I given the index value as 3, I am able to extract this particular element. And if I want to extract a sequence of elements over here, so if I want the first 4 elements, then I'll have S1 colon 4. This would mean that I've been extracting all of the elements starting from index number 0 going on till index number 4. And since 4 is exclusive, so that is why we will only have till index number 3. So we'll have index number 1 going on till index number 3. And if you want to extract elements from the back side, here we'll have S1 and we'll type in -3 over here. So -3 basically means third element from the end. Third element from the end, when I give in colon, this would mean third element from the end going on till the end. So this is the third element from the end over here. So that is why I'll have 7, 8, and 9. And this is how I'll be able to extract a single element, a sequence of elements from the beginning, and a sequence of elements from the back. Let me just create a new series object over here. So I'll have S1 is equal to pd.series, and inside this I'll pass in a list of elements. I'll have 10, 20, 30, 40, 50, 60 and 70. Now that I have this, let me extract this element which is present at index number 3. So I'll have S1, I'll have parenthesis, then I'll just go ahead and give in the index value. So index value will be 3. And as you guys see, I have successfully extracted this particular element. Now if I want to extract the first 4 elements, then I'll just give in the colon over here and I'll have 4. And as you guys see, I have extracted the first 4 elements. Now if I want the last 3 elements over here, then I'll have S1. Then I'll have colon and I'll type in -3, which would mean the third element from the last going on till the last element over here. And I have 50, 60 and 70, which are the last 3 elements. Now we can also go ahead and perform some simple operations on top of the series object. So if I want to add a scalar value, so initially we had this series object where the number started from 1, went on till 9. And if I just wanted to add the scalar value phi to all of the individual elements which are present in the series object, all I have to do is use plus phi. And as you guys see, 1 becomes 5, 2 becomes 7, 3 becomes 8 and so on. And we can also go ahead and add 2 series objects. Over here I have S1 where the elements are from 1 to 9 and S2 where the elements are from 10 to 90. And when I perform S1 plus S2, this would add the elements which are present at the same index position. So here we'll have 10 plus 1, 11, 20 plus 2, 22, 30 plus 3, 33, and this goes on till the last index position over here. So let's go ahead and perform some basic operations on top of the series object. So I already have S1 over here. And these are the original values which are present in S1. Now I'd want to add 10 more to these existing values. So I'll just type in S1 plus 10. And as you guys see, the values, all of the values which are present in the series object have been incremented by 10. Now also I can add 2 series objects together. So in the series object, I have 7 elements. I'll go ahead and create S2. Where I'll have 7 more elements over here. So I would have to type pd.series and inside this, let me just have 7, 6, 5, 4, 3, 2 and 1. Let me print out S2 for your sake over here. So we have S1 and S2, and when I perform S1 plus S2, this is the result which we get. So 10 plus 7 becomes 17, 20 plus 6 becomes 26, 30 plus 5 becomes 35, and this proceeds to the last index value. So that was all about the series object, which was a single dimensional labeled array. Now we'll work with a data frame, which forms the major part of all of the machine learning data science projects. So what exactly is a data frame? It is a 2-dimensional labeled data structure. And if you'd have worked with SQL or maybe Excel, you would have dealt with tabular data. And a data frame helps you to deal with tabular data in Python seamlessly. So a data frame, because this is a tabular data, consists of rows and columns. Now let's see how can we go ahead and create a data frame from a dictionary. So to create a data frame, we'd have to use this particular method over here. We'd have to type in pd.dataframe, where D is capital and F is also capital. So by any chance, if you give maybe D as small or F as small, you'll get an error. So both of them have to be in capital case. And over here, I have 2 key value pairs. So the first key is name, and then we have a list of values which are Bob, Sam and Annie. Then we have the next key, which is marks. Then we have the list of values for marks, which are 76, 25 and 92. So here, as you see, the keys become the column names and the values become the records over here. So name and marks become the column names, and these values over here, the list of values Bob, Sam and Annie, which are the values for this key, become the records of this particular column. Similarly, these values are there for this particular key, and these become the records for this particular column. So let me go ahead and create a first data frame over here. So I'll just go ahead and type in data frame. Now to create a data frame, I'd have to type pd.dataframe, and D and F both have to be capital. And inside this, I'll create a dictionary. So to create a dictionary, I would need curly braces. So the first key would be name, and I'll go ahead and give in a list of names over here. Let's say the first name is Sam, then we have Annie, going ahead we have Jennifer. Now once we have the first key value pair, I'll go ahead and also add their marks over here. So the second key would be marks, and I'll have a list of values over here. Let's say Sam has scored 50 marks, Annie has scored 60 marks, and Jennifer has scored 70 marks. And I'll go ahead and store this in df. Let me print out df over here. And we have created our first data frame where the column names are name and marks, and the values are these over here. And let me go ahead and also show you guys the type of this object which I've just created. So inside this type method, I'll be passing in df. And as you guys see, this is pandas.co.frame.dataframe, which basically means this is a data frame object. Now that we have created our first data frame, we'll perform some basic functions on top of a data frame. We've got head, tail, shape, and describe. So we'll just implement all of these. Now to implement this, we will be performing them on a dataset called as the iris dataset. Now to read any CSV file, we have a method called as pd.read_CSV. So here I'll have pd.read_CSV, and inside this I'll give in single quotes and given the name of the file. So the name of the file will be iris.csv, and I'll go ahead and store this in a new object called as iris. Now let me hit on run. Let me check the first 5 records which are present in this iris data frame. So if I want to check the first 5 records which are present in this iris data frame, I need to use the head method. So iris.head, as you guys see, I have the first 5 records. So this iris data frame comprises of 5 columns, which are sepal length, sepal width, petal width, and species. And we'll have 3 different species, which would be Setosa, versicolor, and virginica. So this is how we can work with the head method. Now, similar to the head method, we would also have the tail method, which would give us the last 5 rows which are present in a data frame. So here I'll type iris.tail, and when I click on run, you guys would see the index value over here. The index value starts from 145 and goes on till 149 because there are 150 records in this iris data frame. So we have extracted the last 5 records and we have printed it onto the console. Then if you want to check the number of rows and number of columns which are present in this iris data frame, we can just use the shape method. So here I'll have iris.shape, and as you guys see, this gives us a dimension value of 150, 5, which means there are 150 records and 5 columns. Then we'll have the describe method. So here I'll have iris.describe. And now when I click on run, we have all of these numerical quantities over here. So let's say if I want to find out what is the minimum value which is present in the sepal length column. The minimum value present in this sepal length column will be 4.3. Similarly, what is the maximum value in sepal length column? It will be 7.9. What is the mean value? It will be 5.84. So these are some interesting metrics which you can find out with the describe method. So now that we know this, let's actually see how can we extract individual records or individual columns from a data frame. So for that purpose, we can use the .iloc and loc methods. So let's start off with the .iloc method. So .iloc method, with the help of it, we can extract rows and columns on the basis of index. So here iloc basically stands for index location. And over here, as you see, I have a comma, and on the left side of the comma, that would indicate all of the rows, and the right side of the comma, that would indicate all of the columns. So from this entire iris data frame, I am extracting the first 3 records. So here the rows would be 0 to 3 and 3 is exclusive over here. That is why I'll have the records where the index values are 0, 1 and 2. And similarly, the columns would be 0 to 2, which would mean the column which is present at index 0, which will be sepal length, and the column which is present at index 1, which is sepal width. 2 again over here is exclusive. So let me go ahead and extract some rows and columns with this iloc method. So we already have this iris data frame with us. Let me again print out the head for you guys so that will be easier for you to have a glance at this. Now, let's say from this entire data frame, I would want the records from index number 30 going on till index number 40, and I would want the columns which are present at maybe index number 3 and index number 4. So index number 3 will be 0, 1, 2 and 3. This is index number 3, this is index number 4. So here I'll have index number 3 going on till the end because this is the last column. Let me print this out and show you guys the result. As you guys see, I have extracted all of the records starting from index number 30 going on till index number 39, and the columns which you see starts from index number 3, which is this particular columns index, and goes on till the end over here. So this is how we can extract individual rows and columns with the .iloc method. Now we have the .loc method. So instead of giving the column index, if I want to extract columns on the basis of their names, then I can go ahead and use the .loc method. And over here, when it comes to rows, you see that I've given 0 to 3. Here, when it comes to .loc, you'd have to keep in mind that 3 is inclusive. This is the only case where maybe you will find that the final value over here is inclusive. So when I given 0 to 3, you will get all of the records starting from index number 0 going on till index number 3, which is also inclusive. And over here I'm giving in the column names which are sepal length and petal length, and that is what I'm extracting over here. So I have this iris data frame, then I'll just go ahead and use this .loc method. Now from all of these records, let's say I'd want all the records starting from index number 10 going on till index number 20, and the columns which I'd want to extract are sepal length and petal length. I'll just have sepal.length over here, and the next column which I want would be petal.length. Let me hit on run, and as you guys see, I have all the records starting from row number 10 going on till row number 20, and 20 is also inclusive over here. And the columns which I've extracted are sepal length and petal length. Now we'll see how to drop a particular column. So many a times it would happen that not all columns which are present in a data frame are important. So from this entire data frame, if we want to drop a particular column, then we can just go ahead and use the drop method. So here I'll have iris.drop, and I am dropping or removing the sepal length column from this entire data frame. So here, when I set the access value to be equal to 1, this would basically mean that I am dropping a column. So if you want to drop a row, then you'd set the access value to be equal to 0. And if you want to drop a column, then you'd set the access value to be equal to 1. So if from this entire iris data set, again, I'll show you guys the head of this so that you guys can have a glance at all of the columns which are present over here. So from all of the columns, if I want to drop the species column, all I have to do is type in iris.drop, and inside this I'd have to give in the name of the column, which would be species, and I'd have to set the access which will be equal to 1 because I'm dropping a column. And as you guys see, I have successfully dropped the species column from this entire data frame. Now similarly, if I want to drop some particular rows which are present in this data frame, so here, as you guys see, the index value, it starts from 0, goes on till 4 over here. But if I want to drop the row indexes of 1, 2 and 3. Here, as you guys see, I have two parameters. First parameter, I'll give in a list of all of the indices that I'd want to drop. So I'd want to drop the index value 1, index value 2 and index value 3. And the resultant which you see over here, after 0, we directly jump on to the index number 4. So now from this entire data frame, this what you see over here, I'll just use iris.drop, and I would want to drop the index values of 1, 2 and 3, and I'll set the access to be equal to 0. And when I hit run, you would see that after 0, we are directly jumping onto index number 4. So this is a very simple example of how to drop some records and how to drop some columns from your data frame. Now we'll go ahead and work with some simple pandas functions. So from the iris data frame, if I want to find out the mean values of all of the columns, I can just go ahead and use the mean method. Similarly, if I wanted the median values of the records of all of the columns, then I'll just go ahead and use the median method. Similarly, if I wanted to find out the minimum value, I'll use the min method. And if I wanted to find out the maximum value, I will use the max method over here. So very basic operations. So when I use iris.mean, this would give me the average values of all of the columns. So average sepal length of the entire data frame is 5.8. Average sepal width is 3.05, average petal length is 3.75, and average petal width is 1.19. Similarly, if I want to find out the minimum value of all of the columns, so I'll have iris.mean, and this will give me all of the minimum values. And if I want to find out the maximum values, I'll just go ahead and type iris.max, and this would give me the maximum value of all of the columns over here. So I've got the mean value, the minimum value, the maximum value, and I can also find out the median value. So I'll just type in iris.median, and when I click on run over here, this would give me the median values with respect to all of the columns which are present. Now we will get on with this library called as Matplotlib, which is mostly used for data visualization. And with the help of this library, we can create stunning plots such as bar plots, scatter plots, histograms, and a lot more. So we'll start off by creating our first plot, which will be a line plot. So we would require two libraries over here. The first library would be Numpy, because we would want to create our data with this Numpy library. Then we would import this pyplot submodule from this Matplotlib library. So we'd have to type in from Matplotlib import pyplot as plt, and the alias which I'm giving for pyplot is plt. Then I'll create two NumPy arrays over here. The first NumPy array will be X, and I'm creating this NumPy array with the help of this np.arange method, and the range will be from 1 to 10. And then I'll create the next NumPy array, which is basically 2 times of X. So all I have to do is multiply X with 2, and then I'll get Y. So here we have 1, we have 2. 2 becomes 4, 3 becomes 6, and this is how it proceeds. Now once we create the data, all we have to do to create a line plot is use this plt.plot. So we'll have the plot method in this pyplot module. So this takes in two parameters, which are X and Y. So we have already created our data X and Y. So X will be plotted on the X axis, Y will be plotted on the Y axis. And as you guys see over here, X goes from 0 to 10 and Y goes from 1 to 20 over here. And we see that there is a linear relationship between X and Y, or in other words, as the value of X increases, the value of Y also correspondingly increases. So let's go to Jupyter Notebook and create our first line plot using Matplotlib. So I'd have to start off by importing the required libraries. So I would need NumPy. Here I'll type import NumPy as np. And after this, I would also require Matplotlib. So I'll type from Matplotlib import pyplot as plt. Let me write the spelling properly over here. And once I've imported these two libraries, I'd have to create the data. So first I'll have X, and this I'll be creating with np.arange, and the range will be from 1 to 10. Since I want the numbers from 1 to 10, I'd have to give the value 11 because 11 will be exclusive over here. Then let me just go ahead and print out X for you folks over here. As you see, we have the numbers starting from 1 going on till 10. Now, if I have to create Y, Y will just be 2 times of X. So here I'll have 2 into X, and then let me print out Y for you folks over here. And as you guys see, this is all of the elements are just 2 times of the elements which are present in X. Now, since I have to create a simple line plot, I would have to use plt.plot, and this would take in 2 parameters, which are X and Y. So this data would be plotted onto the X axis. This data would be plotted onto the Y axis. and I'll just show this as a result. So as you guys see, we have this object X mapped on the X axis, this object Y mapped on the Y axis, and this is the corresponding line plot. Now that we have created this, we can also add the title X label and Y label. So we'd have to use this title method. So we'll have plt.title, and inside this we'll give the title as line plot. Similarly, we can also add X label and Y label by using these two methods. And as you guys see, we have added these two labels over here. So let me add the title X label and Y label, plt. So I'll copy this entire code over here and then I'll paste it over here. Now after this, I'd have to add the title. So for that, I'll use plt.title, and I'll just give the title as first line plot. Then I'll have X label. So here I'll have plt.x label, and here I'll give the X label as X axis. Then I would have the Y label, so plt.y label, and inside this I'll give the Y label as Y axis. Let's run this and wait for the results. So as you guys see, initially this was just a bland plot without the title and the X and Y axis labels. Now with the help of these three methods, we have added the title, the X axis label, and the Y axis label. Now we can also go ahead and change some more attributes with respect to this line plots. So we have color, line style, and line width. So initially, as you see over here, the color of this line by default is blue. But if I don't want the blue color and if I want some other color, then I can just use this color attribute and assign it a new color. Since I'm giving it a value of G, which basically means green color, and as you guys see, this is a green color. Similarly, we have this next attribute called as line style. So initially we have a solid line, but instead of a solid line, if I want a dotted line, then I can go ahead and use a colon over here. And as you guys see, we have a dotted line right now. And by default also the line width is 1. So we can go ahead and increase or decrease the line width. So here we are setting the line width to be equal to 2. And this is the final result which we get. So let's go ahead and add some color, line plot, and line width. I have the same code over here. Now what I'd have to do is add in some color. So I'll have this attribute called as color, and I'm setting, let's say I'll give it orange color to this. Now I would have to change the line style. So I would want a dotted line instead of this solid line. So I'll give in a colon over here, and I'll also change the line width. So I'll give the line width as 3. So as you guys see, initially this was the line which we had, but now I have changed it to this. So from blue, we have converted it to orange. From a solid line, we have converted it to a dotted line. And also you see that this is a thin line, and we have increased the width of this line by 2 points. Now we have only created one line in one plot, but we can also have 2 lines in the same plot. So for this purpose, I'll have 2 y variables. So x variable will be the same, which will be the numbers starting from 1 going on till 10, but I'll have 2 y variables, y1 and y2. y1 is 2 times of x, y2 is 3 times of x. So now that we have y1 and y2 ready, I'll have to make 2 plots because I want 2 line plots in the same graph. So first I'll have plt.plot, and this line will be between x and y1. So this first line which we are making, it will be between x and y1. And for this particular line, I'm setting the color to be equal to green, the line style to be equal to, so this will be a dotted line. Then we'll set the line width to be equal to 2. Then we'll have our next line, which will be between x and y2, and the color of this line will be red, and this will be a dashed line, and we are setting the line width to be equal to 3. Then again we have the title, x label, and y label, and we also have this new method called as grid. So in the earlier plot, as you guys see, we don't have any grid over here, but when we set plt.grid to be equal to true, we'll have a grid as well. And this is the resultant line which we get. So here we have the green line over here, which is this dash line. Then we also have this next line over here, which is between x and y2, and this is the line. And since I've also set the grid to be equal to true, we also have a grid over here in this particular graph. So I'll go back. We already have x. Now let me just print out x for you guys over here. These are all the numbers which are present in x. Now y1 I'll set it as 2 times of x, and then I'll have y2 which will be equal to 3 times of x. So I have y1 and y2 ready. Now after this I would have to make a plot between x and y1. So I'll have plt.plot, and onto the x-axis I'll obviously have x, then onto the y-axis I'll have y1, and the color for the first line I'll have green, and let's say the line width I'll set this to be equal to 2. Then I'll have the next line which will be between x and y2. So here I'll just write down x comma y2, and for this line I'll set the color to be equal to red, and I'll change the line width over here again. So I'll set the line width to be equal to 5, and I would just have to print it out. So it'll be plt.show, and I would also want a grid over here. So before this I'll set plt.grid, and I will set this to be equal to true. Let's hit run, and as you guys see, I have 2 lines in the same plot. Now in the earlier example we had 2 lines in the same plot, but if we actually want 2 subplots itself, that is, as you guys see over here, this is one subplot, this is one subplot, and this line is present in the first subplot, this line is present in the second subplot. So this is also something which we can create. So first we have x, y1 and y2. So these would be the same variables. Once we have our variables ready, we would have to use the subplot method. So we'll have plt.subplot, and inside this I am passing in 1, 2, 1. So here 1, 2 basically means that I would have 2 plots over here, and those 2 plots would be present in this way. So I'll have 1 row, 2 columns. As you guys see, I have 1 row and 2 columns. So this is column number 1, column number 2, which are present in the same row. Then I will give in the index of this subplot. So this is index number 1. And for this first index, this will be the plot which we'll be creating. So for the first index, the plot will be between x and y1, color will be green, line style will be dotted, and line width will be 2. And as you guys see, at index number 1, we have this green colored line between x and y1. Then we'll have plt.subplot, which is our next subplot, and the first 2 parameters will be the same. The third parameter here will set the index value, which is 2. So this is what we'll be getting over here. And the second index will have the line plot between x and y2, and the color, as you see, is red, line style is dotted, and line width is equal to 2. Then we'll just go ahead and print it out. So we already have x, y1 and y2 ready with us. Now after this, we would have to start off by creating a subplot. So here I'll have plt.subplot, and I'd have to give in the dimensions over here. So I'll have 1, 2, 1. So I'm creating my first subplot over here, plt.plot, and this plot will be between x and y1, and I'll set the color to be equal to yellow. Then after this, I'll go ahead and create the second subplot, and the first 2 parameters will be 1 and 2 because I'd want these 2 plots along the columns, and I'll set the index to be equal to 2. Then I'll have plt.plot, and the next plot will be between x and y2, And over here, I am setting the color to be equal to orange. Then I can just go ahead and show you guys the result. So as you see, I have two subplots over here. The first subplot is between X and Y1 and the color of this line is yellow. The next subplot is between X and Y2 and the color of this line is orange. Now, if I want the subplots along the row and not along the column, that is also I can set. So all I have to do is make this change over here. I'll set this to be equal to 2, 1. And similarly over here, I'll make this to be 2, 1, which means that I will have the plots along the rows. I'll have 2 rows and only 1 column. When I hit run, as you guys see, I have 2 rows and only 1 column. This is the first subplot. This is the second subplot. So that was a line plot which helped us to understand the relationship between two numerical entities. So whatever we mapped onto the x-axis was a numerical entity, and whatever we mapped onto the y-axis was also a numerical entity. Now we'll go ahead and work with something known as a bar plot, which would help us to understand the distribution of a categorical column. So for this, we are creating a dictionary called as student, and it comprises of 3 key value pairs. We have Bob 87, Matt 56, and Sam 27. Now we'll go ahead and extract the names and values individually. So the names of these students are basically the keys. So I'll have student.keys, which will give me all of these keys, and I'll go ahead and convert these keys into a list. So I'll pass this into this list method and I'll store the result in this names object. Similarly, I'll extract all of the values, I'll convert all of the values into a list, or I'll store all of the values into a list, and I'll store that list in this object called as values. So I've got names, I've got values, and to create a bar plot, all I have to do is use plt.bar, and this takes in 2 parameters. The first parameter will have the categorical values, the second parameter will have the numerical values. Since the first parameter comprises of the categorical values, I'll pass in names over here, and the second parameter will be the values. And as you guys see over here on the x-axis, I have the names which are Bob, Matt, and Sam, and on the y-axis, I have the corresponding values. So we see that Bob has scored the highest marks, followed by Matt, followed by Sam. Now, since we are creating a bar plot, I'll just add this comment bar plot over here, and I'd have to create a dictionary so that we get the data for this bar plot. So I'll name this dictionary as student, and we can create a dictionary with these curly braces over here. So I'll have the first student, who is Bob. Let's say Bob has scored 45 marks. Then we'll have the second student, Sam, and Sam has scored, let's say, 97 marks. Then we'll have Matt, and let's say Matt has scored only 23 marks. So we've got 3 key value pairs. Now that this is done, I'd have to extract the keys. So I'll type in student.keys, and I will convert this into a list. So I'll cut this, I'll put this inside the list, and I will store this in a new object called as names. Now that I have names of all of the students, I'll go ahead and also extract marks of all of the students. So I'll store that in this object called as values. I'll have to convert the result into a list, and inside this, I would basically have to extract all of the values. So it'll be student.values. I have names and values ready, and to create the bar plot, I would just have to use plt.bar. The first parameter will be names and the second parameter will be values. Then I can just go ahead and show out the result. So we have Bob, Sam, and Matt mapped on the x-axis and their corresponding values, and we see that Sam has the highest marks and Matt has the lowest marks. And now, the plot which we had created earlier was very bland, and we can go ahead and add the title, X label, and Y label to it, and also assign a grid. So we'll be using the same methods. To add the title, we'll have plt.title, and to add the X label and the Y label, we'll be using plt.xlabel and plt.ylabel, and we'll also set the grid to be equal to true. I'll copy these two set of commands over here, and I would have to set the title. So here I'll have plt.title, and I'll set the title to be equal to marks of students. Then I'll have something on the x-axis, plt.xlabel, and I'll just have names on the x-axis. Then I'll have something on the y-axis. Here I'll just write down plt.ylabel, and on the y-axis I'll just write down marks, and I would also have to set the grid to be equal to true, so it'll be plt.grid, and here I'll set the value to be equal to true. And as you guys see, I have names on the x-axis, marks on the y-axis, and I've also set the grid to be true. Now after this, we can also create a horizontal plot. So the plot which we had created earlier was a vertical plot. So here we are basically doing two things. So if we have to create a bar plot, we have to use bar h instead of using just bar, and we are adding a color as well. So by default we had the blue color, and if I want to change the color from blue to green, I'll use this color attribute and I'll map the green color to this. Rest everything will be the same. Let me add a new comment over here, which will be horizontal bar plot. Now that I have added this comment, let me go ahead and copy everything. I'll paste it over here, and instead of just having bar, I'll have bar h, and I'll set the color to be red, and we have this bar plot over here. So it's just that we have to interchange the labels. So on the x-axis, now we have the marks. So let me keep this as marks, and on the y-axis we'll have names. Let me change this to names, and as you guys see, we have successfully created this horizontal bar plot. Now that we are done with the bar plot, we will head on to the next geometry, which will be a scatter plot. A scatter plot again is used to understand the distribution between two numerical entities, and these entities are represented in the form of data points. So we'll be creating two lists over here. The first list will be storing in X, which basically comprises of the elements starting from 10 going on till 90. Then we'll have the next list A, which comprises of some random elements. And here you'd have to keep in mind that both of the lists have same number of elements, else there'll be an error. And to create a scatter plot, we'll just use plt.scatter. We'll pass this over here, we'll pass this over here as a second parameter, and then we'll just show off the result. Let me go ahead and add a comment over here. So this will be a scatter plot. Now to create this scatter plot, I'd have to create the data. So I'd have to store something onto the x-axis. So in X, I'll just have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I'll have Y, and in Y, I'll just have 9 random numbers over here. So let me just store some 9 random numbers, which is done. Now to create this scatter plot, I'll have plt.scatter, and I'll just pass in x, y, and I would have to show out the result, plt.show. And as you guys see, I have created this scatter plot. Let's start off with this particular point over here. This particular point indicates these two. So I have x, y, which is basically 1 and 5. So this intersection between 1 and 5 is where we'll be getting this point. So I have x, I have y, and this is the point I have. Then I have 2, 2. So the intersection of 2, 2, I'll get this particular point. Then we have this point over here, which is the intersection between 9 and 7. So as you guys see, I have 9 and 7 over here. Now we can also go ahead and add some aesthetics or change the aesthetics of the existing points. So we had same X and A. These are the same lists which we have. It's just that we are adding new attributes over here. The first attribute is marker. initially we just had solid circles. So instead of having solid circles, if I wanted a star, then with the help of this marker attribute, I'll add star over here. Similarly, to change the color, I'll just have C and I'll assign green to this attribute C. And also I can change the size of this, and to change the size of this, I'll be using S. Let me copy this entire thing. I'll be pasting it over here. So these two will be the same. I'll add this new attribute called as marker, and I'll set the marker to be equal to star, and I'll change the color. Color will be, let's say, I'll have orange again, and I'll have size to be equal to 200. Let me print it out. And as you guys see, this is the result. Just to show you guys what happens if we increase the size. Instead of 200, if I keep it to be 500, you guys see that the size has increased again. Now, instead of 500, what happens if I keep it to be 50? You would see that the size of the stars has decreased. Now, as we did with the line plot where we had two lines in the same graph, we can perform a similar sort of thing over here where we'll have two different sets of points in the same plot. So for this, we would need a new list. We already have X and A. Then we'll create a new list called as B. Again, we'd have to keep in mind that the elements which are present in this list, or the number of elements which are present in this list, should be equal to the number of elements which are present in A as well as X. Then we'll go ahead and create our first scatter plot by using plt.scatter, and the first scatter plot will be between X and A. And the first scatter plot here, these dots will be represented with stars. Then we'll go ahead and create the second scatter plot, which will be between X and B, and these will be represented with circles. And also we have different colors for both of these scatter plots, and also the size of the different data points will be different. I'll copy this entire thing over here and I'll paste it down. I'll change this to be equal to y1. Then I'll have a y2 as well. And then y2, I would need some bunch of elements over here, random 9 elements. So let me just have some random 9 elements. Let me just check how many elements do we have. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these 3 lists are ready. After this, I'd have to go ahead and create the first scatter plot, which will be between X and Y1. Then I'll go ahead and create the second scatter plot, which will be between X and Y2. And I'm not adding the marker because we have already added the marker for the first one. I just change the color for this. So the color for second one, let's just keep it to be blue, so I don't have to add the color as well. And I'll change the size of this. So for this, I'll set the size to be equal to 500. So as you guys see, I have two sets of points over here. The first set of point is being denoted by the small stars. The second set of points is being determined by these solid circles. Now, instead of having those set of points on a same plot, we can go ahead and create two subplots as well. So we'll be using the subplot method as we had used during the case of line plots. So here we have these 3 lists, then I'll have plt.subplot, then we'll have the same 3 parameters. And since I want these plots to be present column wise and not row wise, I'll have 1, 2, which means that I'll have 1 row, 2 columns, and then I'll give the index. So at index number 1, we'll have this scatter plot, which will be between X and A. So this is the scatter plot between X and A. Then I'll go ahead and create the next subplot, and the next subplot will be between X and B. I'll copy this entire thing. I'll paste it over here. It's just that I'd have to create a subplot now. So I'll have plt.subplot, and I want these plots column wise. So I'll have 1, 2, 1, and the first subplot will be this. Then I'll go ahead and create the second subplot. So I'll have plt dot subplot, and here I'll be writing 1, 2, 2. And this is our first subplot and this is our second subplot. So that was all about the scatter plot. A categorical column, but when it comes to histogram, we'll be using that to understand the distribution of a continuous numerical column. And we'll be creating this continuous numerical column or continuous numerical data with just a list over here. So this is a very basic example. I'm just creating a random list which comprises of all of these numbers, and I'm storing it in this object called as data. And to create a histogram, all I have to do is use this hist method. So inside plt.hist, I'll pass in this list, and when I show out, this is the result which I get. So here, let's actually have a look at this particular bin. So in a histogram, these are known as bins. So here, for this bin, for the value 3, we have this value 4, or for the value 3 on the x-axis, we have this value 4 on the y-axis, which would mean that this number 3 is occurring 4 times. Similarly, if I look at this 1 over here, so for this 1 on the x-axis, we also have the value 1 on y, which would mean that 1 is occurring only once. Similarly, we have 4. So this number 4 is occurring 2 times. Then we have 8, which is occurring 3 times. So let's go ahead and create a histogram in Jupyter Notebook. I'll just add a comment over here. Histogram. And let me go ahead and create a list. So I'll store this list in L1, and I'll have some random numbers over here. So I have created my list. Now that this is ready, I can just go ahead and build out the histogram by using this method called as plt.hist, and inside this I'll be passing in L1. Then since I just have to show this out, I'll just have plt.show. And this is the result. So as you guys see, this number 3 is occurring 4 times. Then we have this number 6, which is occurring 3 times. And the rest of the numbers are occurring only once. Now we can also go ahead and change the number of bins which are present or the color of the histogram as well. So to change the color, we'll just use this over here. So for the color attribute, we are mapping in G, which will give us this green color. And initially we had 1, 2, 3, 4, 5, 6, 7 bins over here. But instead of 7 bins, let's say if I want to reduce the number of bins, I'll just use this attribute and set the number of bins to be equal to 4, and this is the result which I get. I'll copy this entire thing, I'll paste it over here. Now that I have created this histogram, I would want to change the color of this. So I'll set the color to be equal to green. And instead of, so how many bars do I have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So instead of having 9 bars, let's say I would want only 3 bars over here or 3 bins over here. I'll set the bins value to be equal to 3. And as you guys see, I have only 3 bins. Now let me set it to be 5. And I have 1, 2, 3, 4, and 5 bins. This was all about histogram. Now, the earlier histogram which we had created was with respect to a single list. But if you want to create a histogram on top of a data frame, then let's see how can we do it. So here we'll be building this histogram on top of the iris dataset. So if we have to load any data frame, we'll have to use read_csv, since this is a CSV file. So inside read_csv, I am passing in the name of the file, and I'll store it in this object called as iris. And when I use iris.head, this will give me the first 5 rows which are present in this data frame. Now after that, to create the histogram, we'll just use plt.hist, and inside this, so here we were passing in the list of numbers, but here instead of passing in the list of numbers, I'll pass in the column. So we have this sepal length column which is present in the iris data frame. So I'll just pass in the sepal length column, and I'll set the number of bins, and I'll also set the color to be equal to something. And when I show it out, this will be the result which I'll be getting. So here I'd have to load the iris data frame first. So in the iris object, I'll just have pd.read_csv, and inside this, I'll give in the name of the file, which will be equal to iris.csv. I'll click on run. So I'd have to import the pandas data frame as well to use read_csv methods. So I'll have import pandas as pd, and we have, let's just wait till this is loaded, both the library and also the data frame. Now in the while it is loaded, I'll go ahead and write in the head method as well. Now if I click on run, we'll have a glance at the first 5 records which are present in this data frame, and as we see, we have sepal length, sepal width, petal width, and the species column. And now I'd want to create a histogram for, let's see, this petal length column over here. Then I'll just have to type in plt.hist, and inside this I'd have to pass in this petal length column. So here, so I'd given the name of the data frame first, and using this parenthesis, I'll give in the name of the column. So the name of the column, let me keep this to be small, it'll be petal length, and I'll set the number of bins to be equal to, let's say 50. And after that, I'll set the color of the bins to be equal to green again. And we can just go ahead and show out the result. So this should be color and not C. I'll keep it as COLOR. Alright, so as you see, we have successfully created this histogram for this petal length column. Now we'll head on to the next geometry, which is a box plot. So this box plot basically gives us a 5-number summary. So here in this result, what you see, this is the minimum value, this is the 25% value, this is the 50% value, this is the 75% value, and this is the maximum value. So we'll be understanding more about this as we progress through the session. So first, what we'll do is we'll just go ahead and create 3 lists. In the first list, we just have numbers from 1 to 9. In the second and the third list, we have randomly given some numbers over here. And then we'll create a list out of all of these 3 lists. So inside this list method, I am passing in 1, 2, and 3 as a list, and I'll store the resultant list in this object called as data. Then if I have to create a box plot, I'll just use plt.boxplot, and inside this I'm passing in this data object which I just created, and when I show it out, this is the result which I get. Now when I compare these 3 boxes, let's actually understand the inferences over here. So for this plot or this box basically refers to this particular list. This box tells us that the median value of the numbers which are present in this list is 5. The maximum value is 9. The minimum value is 1. Similarly, if we look at this particular box, so this box refers to this particular list. And this box tells us that the median value will be 3, the maximum value will be 5, and the minimum value will be 1. Then if we have a look at this particular box, this would tell us that the median value will be 7 for this list. The minimum value will be 4. The maximum value will be 9. So it's time to create a box plot. I'll add this comment over here, box plot. And after this, I'd have to create 3 lists. So I'll have L1, and inside L1, I'll just have all the numbers starting from 1 going on till 9. Then I'll have L2. Inside L2, I'll just randomly give in 9 numbers. And again, I'll have L3, and also in L3, I'll just randomly give in some numbers over here. Now, once we have L1, L2, and L3, I'd have to create a list of lists. So inside this, I'll just be passing in L1, L2, and L3, and I will store this in a new object called as data. So now that we have created data, I can just go ahead and build out the box plot. So I'll have plt.boxplot, and inside this, I'll just pass in data. Then I can just show it out to you guys. So we have these three box plots over here. So the first box plot represents this particular list. We see that the median value is 5, minimum value is 1, and the maximum value is 9. Then we have this second list over here. So for this, the median value is 5, the minimum value is also 1, and the maximum value is 8. So, and for this particular list, it seems that the median value and the 75% value is same. So for this, the median value is 8, the minimum value is 5, and the maximum value is 9. So one another geometry which is analogous to the box plot is the violin plot. So the only difference is to create a violin plot, we'll be using violin plot method instead of box plot method. And this is the difference between how these boxes and violins look. And we can, so normally if we don't set the show medians to be equal to true, we'll not have these lines or these indicators over here. So we'd also have to set this to be equal to true. So now here, I'll just copy this entire thing. I'll paste it over here. And instead of having plt.boxplot, I'll just have plt.violinplot, and I'm printing out the same data. And as you guys see, I have created this violin plot. And now if I want the median, so I'll have show medians, and I'll set this show medians to be equal to true. And as you guys see, I have added the medians as well. And after the violin plot, we'll have the pie chart. And pie chart again helps us to understand the frequency or percentage of different categorical values. So here we have two lists. The first list comprises of all of the names of different fruits. So we've got apple, orange, mango, and guava. Then in the second list, we've got the quantity of these fruits. So we've got 67 apples, 34 oranges, 100 mangoes, and 29 guavas. And if I want to represent this relationship of the quantity of these fruits in a pie chart, this is how I can do it. So I'll be using plt.pie, and here first I'll be passing in the numerical entity. So the numerical entity is this quantity, and I'll be passing that over here. Then I'll have the categorical entity over here, which is fruit. So I'm assigning fruit to labels. Then I can just go ahead and show out the results. And as we see in the result, we see that the maximum percentage is of mango and the minimum percentage is of guava. So I'll have to create two lists over here. I'll create the first list. I'll have fruit. And the first fruit will be apple, the second fruit will be mango, the third fruit will be orange, and the fourth fruit will be lychee. Now that we have created all of these fruits, I'll also assign the quantity. So let's say I have 53 apples, I've got 43 mangoes, I've got only 12 oranges, and I've got 97 lychees. So I've got these two ready. Now after this, I'd have to create the pie chart. So I'll have plt.pie. First, I'd have to give in the numerical object, which will be quantity. Then I'd have to give in the categorical object. So I'm mapping fruit onto the labels. Then I would just have to show out this pie chart. So plt.show. As you guys see, this is the resultant pie chart. So the maximum portion belongs to lychee and the minimum portion belongs to orange, because we have 97 lychees and we have only 12 oranges. Now we can also go ahead and change the colors of these different sectors and also add the actual percentage in these different sectors. To add the percentage, we'll be using auto PCT. So here, for this auto PCT attribute, I am using 0.1f. Now, what this basically means is the 0.1 basically means that I'll have the decimal values to one place. So if I have 0.1, this will mean I have decimal values to one place. If I'll keep it as 0.2, then I'll have decimal values to two places. And after this, I'm just adding this new attribute called as colors. And the coloring, it starts from the first label, which is apple over here. Orange, then I've got blue, which is for mango. Then I've got black, which is for guava. I'll copy this entire thing over here. I'll paste it over here. Now, to add the percentage, I'll be using auto PCT. And here I'll have to use %0.1 F. Let me add %%. And after this, I'll also have to set the color over here. So the colors, I'd have to give in a list of colors. So let's say for apple, I'd want to give in green. Then for mango, I'd want to give in yellow. Then for orange, I'd obviously want orange. And for lychee, I'd want pink. Now when I hit on run, let's see what would be the result. Let me change this to colors instead of color. So as you guys see, I have the percentage over here because I had used auto PCT attribute, and it seems that we have, out of all of the fruits, 47.3 of them are lychees, and this is the color indicated. Similarly, out of all of the fruits, only 5.9% of them are oranges. So we have created the pie chart. Then something which is very similar to pie chart is the donut chart. And to create this donut chart, we'll be using two pie charts over here. So the data is same. We have fruit and quantity. It's just that first we'll go ahead and create our first pie chart, which comprises of quantity and labels. And I am adding a new attribute inside this, which is the radius. So I am setting the radius of this to be equal to 2. Then I'll go ahead and create another pie chart. Here inside this, I'll just pass in. So first we'd have to pass in numerical entities. So I'll just have a list which comprises of only one element or one value, which is 1. And this entire value or this entire list comprises of only one color, which is white. And I'll set the radius to be exactly half of the original pie. So I'm setting the radius to be equal to 1. And as you guys see, this is the outer pie chart. This is the inner pie chart. So the outer pie chart has a radius of 2. The inner pie chart has a radius of 1. And since I've given a color of white, this is what I have over here. So you can give in any random number over here. That doesn't really matter. So you can give 1, 10, 5. It is all the same. It's just that keep the color as W, because since a donut, it just basically looks like a donut, we'll have to give in the white color. I'll copy this entire thing. I'll paste it over here. I'll set the radius for this to be equal to, let's say, 4. Then I'll have a new pie chart over here. I'll just give in a random value. Let's say I'll give in 5 over here. And after this, I'd have to set in a color. And since there is only one value, I'll just give in white color over here. And after this, the only thing which I have to set is radius, and I'll set the radius for this to be equal to 2. Let's hit on run. And this is the donut chart which we get. So as you guys see, the radius for the outer pie chart is 4. The radius for the inner pie chart is 2. Let me reduce this. Let me keep this to be 2 actually. And let me keep this as 1. And this is the resultant donut chart. So SeaBorn is another visualization library which is built on top of Matplotlib. So if you want to work with SeaBorn, then we'd have to import Matplotlib as well. So to import SeaBorn, we'd have to type in import SeaBorn as SNS. And since this is built on top of Matplotlib, we'd also have to import Matplotlib. So we'll have from Matplotlib import pyplot as PLT. And inside SeaBorn, we have this method called as load dataset, and we have some built-in datasets inside the SeaBorn library. And one such built-in dataset is the fMRI dataset. And I'm storing this in this new object called as fMRI. And then I'll have a glance at this first 5 columns of this dataset. So we have these columns. We've got subject, time point, event, region, and signal. Now, out of all of these columns, I'd want to make a line plot between the time point column and the signal column. So to make a line plot with the help of this SeaBorn library, since I've given the alias for this SeaBorn library as SNS, I'll type in sns.lineplot, and onto the x-axis I am mapping the time point column, and onto the y-axis I am mapping the signal column. And then I'll have a new attribute called as data. So basically I am building this line plot on top of this fMRI dataset that I just go ahead and show out this line plot. So let's understand this properly. So if you look at this line plot closely, you would see that till the time point of 5 seconds. So let's say if this time point is in seconds, so till the time point of 5 seconds, the signal value is increasing. But from time point of 5 seconds to 10 seconds, you have the signal value to be increasing. And after 10 seconds, this sort of stabilizes and only increases to, so here if the value is minus 0.05, so from minus 0.05, it goes up to close to 0. So now that we are done with Matplotlib, let me go ahead and create a new notebook over here. And I'll name this new notebook to be equal to SeaBorn. Let me rename it. I'll delete this. I'll name this as SeaBorn demo. And we'd have to load the required libraries. The first library is obviously SeaBorn. So I'll have import SeaBorn as SNS. Then I'd also need pipeline. So I'll have from Matplotlib import pyplot as PLT. Let's just wait for these two libraries to load. And once we have SeaBorn with us, we'll be working with the fMRI dataset. So to load the fMRI dataset, we have the load dataset method, which is part of the SNS library. So I'll have sns.load dataset, and inside this, I'll be passing in the name of the dataset, which is fMRI, and I will store it in this object called as fMRI. And let me have a glance at the first 5 records of it. So I'll just type in fMRI.head, and these are the different columns which are present. And I'd want to make a line plot between the time point column and the signal column. And for this purpose, I'd have to map the time point column onto the x-axis and the signal column onto the y-axis. sns.lineplot, and onto the x-axis I am mapping time point, and onto the y-axis I am mapping signal, and the data is obviously fMRI. Then I would just have to show out the result. So I'll have SNS. I'd actually have to give in plt.show over here. Let's hit run. So we have successfully created this line plot, and as we had already seen, so till 5 seconds there's an increase in the signal value, from 5 to 10 seconds there's a drop, and then it sort of stabilizes. Now we can also add a new attribute or new aesthetic called as hue. So here we had only one line, and this one line, arbitrarily the color of this was blue. But if I want the color of the lines to be actually determined by a column, what I can do is I can map a column onto the hue aesthetic. So we have the event column, and we are mapping the event column onto the hue aesthetic. So now the color of the lines would be dependent on this event column. And since we have two events over here, we have the stem event and we have the queue event. This blue color line represents the stem event, and this orange color line represents the queue event. And if we look at this blue color line over here, you would see that till time point of 5 seconds, the signal value, it goes up till maybe 20, and then it drops down to a minus 0.1. And similarly, if we look at this queue event, you see that the peak is not so high. So for the stem event, it was almost 0.2, and when it came to queue, it is only 0.05. But you'd also notice that the drop is not so steep. So for the drop of the stem event, it came from 0.2 and it will drop down to minus 0.10. But for this particular signal queue, the drop is very small. It dropped from 0.05 to only minus 0.05. and also if you see the increase of it. So once it dropped, the increase of queue event is much higher when compared to the increase of this stem event. So this is the same set of commands. It's just that I am adding a new attribute called as hue, and I'm determining the color of the lines on the basis of this attribute, and I'll be mapping the event column on top of this. So as you guys see, I have this event column, and this is the same column which I'm mapping onto this hue aesthetic. Event, we see that we don't have the event column. So what I'll do over here is I will cut this out. I'll paste it over here. I'll put in a comma, and since this is a column, I'd have to put this in double quotes. Now when I hit run, so seems like we have an error again over here. I have two commas. Let me go ahead and delete this comma. And we have successfully produced these two line plots over here. Now we can also go ahead and change the style of how these lines look. So now if I want these lines again, or the style of these lines again, to be dependent on a column, I can just go ahead and add a column onto the style aesthetic. So the color is also being determined by the event column, and also the style is being determined by the event column. So it will be the same command, and I'll be adding a new attribute to this. I'll have style, and to this I am mapping the event column, and you see that the queue event is being represented with this dotted line, and the stem event is being represented with this solid line. So now that we have created that, we can also add markers on top of it. So all we have to do is set the markers to be equal to true. Here in this command, I'll have this new attribute called as markers, and when I set this to be equal to true, you will see that, so I have markers now. When it comes to the stem event, the markers are solid circles, and when it comes to the queue event, the markers are crosses. So that was all about line plot with the help of the SeaBorn library. Now we'll go ahead and create a bar plot with the SeaBorn library. So to create this bar plot, we'll be actually needing the Pokemon dataset. So we'd have to start off by loading the Pokemon dataset. So we'll have pd.read_csv, and we'll store this Pokemon.csv file in this Pokemon object. And once we store it in this object, we can go ahead and create a bar plot for this isLegendary column. So this isLegendary column is a categorical column, and that is why we are creating a bar plot. And in this isLegendary column, we have two categories, 0 and 1. So 0 indicates that the Pokemon is not legendary, and 1 indicates that the Pokemon is legendary. And onto the y-axis, I am mapping the speed column. And from this bar plot, it is very evident that legendary Pokemons, or the speed of the legendary Pokemons, is higher when compared to the speed of non-legendary Pokemons. So now I'd have to go ahead and load up the required data set. So to load the data set, I would need Pandas. So I'll just type in import Pandas as PD. Now once I have this, I need to load the CSV file. So I'll type in pd.read_csv, and inside this I'll give in the name of the CSV file, which will be pokemon.csv, and I will store it in this new object called as Pokemon. And once I've stored this, let me have a glance at this. So I'll just type in Pokemon.head, and I'll show you all of these columns. So these are the different columns which are present over here. So against bug, against dark, against dragon, all of these columns basically tell us how does a Pokemon perform against these types of Pokemons. Then let me scroll it to the last. So here we have this isLegendary column, which would tell us if the Pokemon is legendary or not. Then we have this generation column, which would tell us to which generation does this Pokemon actually belong to. Then this column tells us what is the weight of this Pokemon in kg. Then this type 1 tells us what is the primary type of the Pokemon. Type 2 tells us what is the secondary type of the Pokemon. And then we've got other columns as well. So now for this bar plot, we'll be only working with this isLegendary column and then the speed column. So I'll be using SNS dot bar plot, and onto the x-axis I would have to map isLegendary, and then onto the y-axis I'll be mapping the speed column, and the data onto which I'd want to build this bar plot is the Pokemon data set. Then I can just go ahead and show this out. And when I hit on run, you would see that I have successfully created this bar plot. And again, it is very evident that the legendary Pokemons, the speed of the legendary Pokemons is higher when compared to the speed of non-legendary Pokemons. So now we'll create a bar plot between isLegendary column and weight in kg column. So isLegendary column is again mapped onto the x-axis. It's just that here for the y-axis we are mapping weight kg column. And this time it is very obvious that legendary Pokemons, their weight is much higher when compared to non-legendary Pokemons. I'll cut this out, I'll paste it over here. And instead of mapping speed, I have the weight kg column. And when I hit on run, you would see that the weight in kg of a legendary Pokemon is much higher when compared to the weight in kg of a non-legendary Pokemon. Now, we can also go ahead and determine the color of these bars on the basis of a column. And we already know to do that, we'll be using the hue aesthetic or the hue attribute. And I want the color to be determined by the generation column. So this time I'll be mapping the generation column onto the hue aesthetic. And as you guys see, we have 7 generations over here, starting from generation 1 going on till generation 1. And since we have 2 different legendary status, so 0 indicates that the Pokemon is not legendary, 1 indicates that the Pokemon is legendary. For these 2 categories, I'll have 7 bars each. So for those Pokemons which are not legendary, I'll have these bars, these 7 bars indicating to which generation does the Pokemon belong to. Similarly, for all of the Pokemons which are legendary, I'll have these bars indicating to which generation does the Pokemon again belong to. And again on the y-axis, since we have mapped speed, we have the speed values corresponding to whether the Pokemon is legendary or not legendary. So the same set of command, I would have to use the hue aesthetic, and onto this I'll be mapping the generation column. And as you guys see, so this denotes all of those Pokemons which are not legendary. This denotes all of those Pokemons which are legendary. And it is very clear that legendary Pokemons, they have much higher weight when compared to non-legendary Pokemons. And we have the distribution of Pokemons which belong to the different generations with respect to both legendary Pokemons and non-legendary Pokemons. Now going ahead, we can also change how the different palettes look for these bars. So we will use the palette attribute. So we've got these 3 different palettes over here. So again, the bar plot is between isLegendary column and weight column. And it's just that instead of using a column to map it onto the hue aesthetic, we are using a new aesthetic called as palette. And we can directly use different predefined palettes. So first we have the blues D palette with a capital B. This is how it looks like. Then we have the rocket palette, and this is the resultant. And then we have the VLAG palette. Let me delete this hue attribute over here. And instead of that, I'll have palette attribute. And the first palette which I'll be using is blues D. And as you guys see, this is the blues D palette. Similarly, if I want maybe a more of red color, then I'll be using the rocket palette. Then if I want maybe a light shade of bluish gray, I'll be using VLAG. And this is what I'll be getting. Now, instead of maybe using a palette or maybe mapping a color onto the hue aesthetic, I can just go ahead and use the color attribute and assign one single color for all of the bars which are present. So I'm using the color attribute and I'm mapping the orange color to both these bars. I'll remove palette, and instead of palette I'll have the color attribute, and I will set the color of these two bars to be equal to orange, and this is the result. So we are done with bar plot as well. Now we'll go ahead with the next type of plot, which is scatter plot, and we have already learned that a scatter plot is used to understand the relationship between two numerical entities. And over here we are building the scatter plot on top of the iris dataset. So we'll load this dataset up, then we'll be using sns.scatterplot, and onto the x-axis I am mapping the sepal length column, and onto the y-axis I am mapping the petal length column, and the data onto which I'm building this scatter plot is the iris dataset. And again, it's very clear that as the sepal length of the iris flower increases, the petal length of the iris flower also increases linearly. So here I'd have to load up the iris dataset first. So I'll have pd.read_csv. I'll give in the name of the file, which will be iris.csv. Now that I have loaded this, let me show you guys the first 5 rows of all of the columns, and this is the resultant. And to create the scatter plot, all I have to do is use plt.scatterplot, and since I want the scatter plot between sepal length and petal length, and I want sepal length to be onto the x-axis, so to x I'll be using sepal.length, and on the y-axis I would need petal length. So let me give in the name of the column over here, which will be petal length, and the data which I'm using is obviously iris. Then I can go ahead and show out the result. So let me just keep it as scatter over here. And again, this has to be equal to small d and not capital D. Let me hit on run over here, and this is the resultant value. Now, as you see over here, we can go ahead and add in color and also change the style of this. So initially we just had a simple plot between sepal length and petal length, but now I want these dots to be determined, or the color of these dots to be determined by the species column. So that is why I am mapping the species column onto the hue aesthetic. And after that, similarly, I am mapping the species column onto the style aesthetic as well. So here, as you see, we've got 3 different colors: blue, orange, and green. The blue color is being determined with the Setosa species. Then we've got this orange color, which is for the versicolor species. Then we've got this green color, which is for the Virginica species. Similarly, we've got 3 different styles over here. For Setosa, we have solid circles. For versicolor, we have crosses. And for Virginica, we have solid squares. The same command which I've copied, I've pasted it over here. I'll add 2 more attributes. The first attribute will be hue, and onto hue I'll be mapping the species column. Similarly, onto style as well, I'll be mapping species column, and when I hit on run, so I'll have it as hues. Now when I hit on run, seems like we have an error over here. Let me check it properly. And this over here has to be just hue. Now when I hit on run, this is the resultant scatter plot which I get. So we have an interesting case study now. We have a IPL dataset, and we'll be thoroughly analyzing this IPL dataset with the help of the Pandas library and the visualization library, which is Matplotlib. So our first task would be to import all of the required libraries. So what we'll do is we'll go ahead and type in import pandas as PD. PD is the alias for pandas. Then we'll also go ahead and import the pyplot submodule from the Matplotlib module. So here we'll have from Matplotlib import pyplot as PLT, and PLT is the alias which we are giving for pyplot. And finally, we'll also include one more visualization library, which is SeaBorn, and that is why we will have import SeaBorn as SNS. Let me just go ahead and click on run, and let's wait for all of these libraries to be loaded. So it'll take a bit of time. So these are the three important libraries which we'll be needing to thoroughly analyze this data set. So now that we have loaded all of the required libraries, we would have to load the CSV file. And we have the CSV file called as matches.csv, which has all of the details of the different IPL matches. And we already know that to load a CSV file, we would need to use pd.read_csv. And inside this, we will give in the name of the file, which is matches.csv. And that we will store in this object called as IPL. So now that we have loaded this matches.csv file and we have stored it into the IPL object, let me go ahead and have a glance at the head of this data frame. So I'll have IPL.head, and we also know that the head method gives us the first 5 records of any data frame. So if you see over here, I have 1, 2, 3, 4, and 5. So these are the 5 records, or the first 5 records from this IPL data frame. So let's just look at the different columns which are present in this data frame. We have the ID column, which would tell about the unique match ID. So here each record represents one unique match, or one match which was played between different teams. So here, as you see, the match ID is 1, and this match ID 1 represents that particular match in 2017 between Sunrisers Hyderabad and Royal Challengers Bangalore. Then we have match ID 2, which would represent the match between Rising Pune Super Giants and Mumbai Indians. So this is how, or this is what the ID column tells you. Then we have the season column, which would tell you in which season or in which year this match had been organized or this match was played. So as you see over here, the first 5 records, these represent the matches which were played in the year 2017. Then you have the city over here, in which city was the match played in. So this match between Sunrisers Hyderabad and Royal Challengers Bangalore was played in Hyderabad. Then you have the date column over here, and the date tells you the exact date on which this particular match was played. So this match was played on, so you have 2017-04-05. So this would be 5th of April 2017. So team 1, team 2, this just indicates who were the, or what were the 2 teams playing against each other. Then you have the toss winner, which team had won the toss. So between these 2 teams, Royal Challengers had won the toss, and after winning the toss, what did the team decide to do? So here you have the toss decision column, and this column tells you that after winning the toss, Royal Challengers Bangalore had decided to field. Then you have the result column. So in result column, we have 3 categories, and those 3 categories we'll look at them later on. Then you have DL_applied. This DL_applied tells you if the Duckworth-Lewis method was applied or not. And Duckworth-Lewis method would obviously only be applied if there was rainfall. After that, we have the winner column, which tells us which team has won the match. So this match between Royal Challengers Bangalore and Sunrisers Hyderabad, this match was won by Sunrisers Hyderabad. Then you have win by runs and win by wickets. So this column over here tells us that since Sunrisers Hyderabad had batted first, they have won by 35 runs. Over here you have the win by wickets column. Now you'd have to understand this interesting thing over here. So if a team bats first and wins the match, then it will be winning by a certain number of runs. But on the other hand, if the team batting second wins the match, then it will be winning by a certain number of wickets. So here, since the team batting first has won the match, that is why you have a value in this column and you don't have a value in this particular column over here. Let me give another example to make you understand it better. So let's say the team batting first has scored 100 runs and the team batting second was all out on a score of 75. then we would say that team batting first has won by a margin of 25 runs. On the other hand, let's say if team batting first has made 100 runs and team batting second has achieved that score by losing 2 wickets, then we'll say that the team batting second has won by 8 wickets. So that is what is meant by win by runs and win by wickets. So if team batting first wins, then we'll have a value in this particular column. And similarly, if a team batting second wins, then we'll have a value in this particular column. Then you have the player of the match column over here, which absolutely tells you who was the man of the match or player of the match for that particular game. And in this game between Sunrisers Hyderabad and Royal Challengers Bangalore, Yuvraj Singh, the sixer man who hit sixes on a well, was the man of the match. Then you have the venue over here. And this match was played at Rajiv Gandhi International Stadium, Tuple. Well, I've actually seen an IPL match over there, so it's a pretty stadium. Then you have 3 columns which would tell you who is the first umpire, the second umpire, and the third umpire. So this is all about this particular data set. So now that we have comprehensively looked at this data set, let me see how many rows and how many columns are present in this data frame. And for that purpose, I will have the shape method. So I'll write down IPL.shape, and this will tell me the number of rows and number of columns present in this data frame. And as you see over here, I have 636, 18, which would mean that there are 636 records and 18 columns. And the 636 records also tell you that there were 636 unique matches played. Then I would want to know the frequency of most man of the match awards. So here, this column which you see, player of match, I would want to know which player has won how many man of the match awards. And since this is a categorical column, we have seen that if you would want to find out the frequency of a categorical column, we would have to use the value counts method. And that is what we'll be doing over here. So what I'll do is I will give in the name of the data frame, which is IPL, and inside parenthesis, I will give in the name of the column, which is player of match. After that, I will give in the dot operator, and then finally I will use value counts method, and this will give me the frequency. So here, as you see, Chris Gayle, the universe boss, has the most number of man of the match awards, which is 18. Then you have Yusuf Pathan, who has got 16 man of the match awards. After that, you've got AB de Villiers, who's got 15 man of the match awards. And you have David Warner, who's got 15 man of the match awards, and so on. Now, from this list, I would want to get only the top 10 players with most man of the match awards. So here, the entire command will be the same. It's just that I will give in another parenthesis over here, and inside the parenthesis, I will give in 0:10, which will give me the 10 players with most man of the match awards. So this, what we are doing is just a subset of this particular result. So here, as you see, we have Chris Gayle, Yusuf Pathan, AB de Villiers, David Warner, Rohit Sharma, Suresh Raina, Gautam Gambhir, MS Dhoni, Michael Hussey, and Ajinkya Rahane. So these are the top 10 players with most man of the match awards. And similarly, instead of the top 10, if I would want only the top 5 players with most man of the match awards, in parenthesis, I will give in 0:5. And here, as you see, these are the top 5 players with most man of the match awards. Going ahead, what I'd want to do is I would want to make a bar plot for the top 5 players with most man of the match awards. And if I would want to make a bar plot, obviously I would have to use the Matplotlib library. So I have already imported the pyplot submodule from the Matplotlib library and have given it an alias of PLT. Now what I'll do is I will write plt.figure, which would help me to set a figure size. So plt.figure, inside this, I will use this parameter called as figure size, and I will set the figure size to be equal to 8,5, which is just the dimension of the plot which I'll be displaying right now. Then we have also seen that to make a bar plot, we would have to use plt.bar. So I'll write down plt.bar, and inside this we have seen that the first parameter needs to be a categorical value and the second parameter needs to be a numerical value. So here the categorical value will be the name of the player or all of the names of the players. So here, as you see, we've got the names of the players and also we've got the values of, or the result or the number of man of the match awards of these players. So to get the categories or the names, we would have to use the keys method. So here, as you see, this is the command which will give me this entire result, which is what I have over here. So this is the same thing. It's just that after this, I'll use dot operator, then I will use the keys method and only get the names out of this. And that is what I'm showing you out above here. So as you see, when I use the keys method, this will only give me the names of the players. And similarly, if I would want only the values, I will just use this. That's it. So this command will give me only the values. So I have taken the categories, I have taken the values as well. Now after that, I would want to set a color to these bars. So here I have given color as equal to G, which will give a green color to all of these bars. And to finally show out the image or to plot the image, I would have to use plt.show over here. So as you see, we have successfully made a bar plot which would tell us or give an interpretation of the top 5 players who have received the most number of man of the match awards. And you see there's not much of a difference over here. So you have Chris Gayle leading, then you have Yusuf Pathan, AB de Villiers, David Warner and Rohit Sharma. Now we had the result column over here. So I would want to know the frequency or the different categories of this result column. And if I would want to know the frequency, again, what we have to do is use the value counts method. So as you see over here, IPL is the name of the data frame, and inside parenthesis, I will give in the name of the column. So here the name of the column is result, and I will use the value counts method when I click on run. As you see over here, I have 3 categories: normal, tie and no result. Normal here would mean that the match has progressed normally, which would mean that one team has won the match and another team has lost the match. Then you have tie. Tie would mean that both the teams have scored the same number of runs. Then you have no result. No result would mean that either the match was called off or it was washed off because rain or some other disturbance. So these are the 3 different categories which we have. And out of all of these matches, most of the matches have been done normally. And there were 7 instances where there was a tie. So out of all of these seasons, so I guess there would be 8 or 9 seasons. So out of the 636 matches, there were only 7 instances where there was a tie. So this is a very interesting insight over here which we have found out. Going ahead, I would want to find out which team has won the most number of tosses. So here, let me just show you this particular column, toss winner. So this toss winner column would tell us which team has won the toss. Now what I'm doing is I would want to know the value counts or the frequency of different categories of this toss winner column. And here, as you see, Mumbai Indians seem to be very lucky. So they have won the most number of tosses. So Mumbai Indians has won 85 tosses. Then we have Kolkata Knight Riders close behind with 78. Then you have Delhi Daredevils with 72. After that, you have RCB with 70 and so on. Now, I would want to know what team or how many teams have won the match batting first. So what is the percentage distribution of a team batting first and winning the match? And I've already told you guys that if a team wins the match by batting first, then we will have a value in this particular column. So it cannot be a 0. So if you have a 0 in this column over here, it would mean that the team batting first has lost the match. But I don't want that. What I want is, I would want all of those records where the team batting first has won the match, which means I would want all of the records where the value is not equal to 0. And that is what I'll be extracting from this entire data frame. So here, as you see, from this IPL data frame, from the win by runs column, I am extracting only those records where win by runs is not equal to 0. And I will store all of those records in this new object called as batting first. Now that this is done, I will have a glance at the top 5 records of this. So I'll have batting first dot head. And here, as you see, I have the list of all of those records where the teams have won batting first. And also, if you look at this particular column over here, I don't have a 0. We have some values. So here, between this match of Sunrisers Hyderabad and Royal Challengers Bangalore, we have already looked at it. So Sunrisers Hyderabad has won the match with 13 runs. Then between the match of Royal Challengers Bangalore and Delhi Daredevils, RCB has won the match by 15 runs. And this seems to be a huge margin over here. So this is the match between Delhi Daredevils and Rising Pune Supergiants. And Delhi Daredevils has won the match by 97 runs. So going ahead, I'd want to do more of visualization, and I'd want to see the distribution of this particular column, win by runs column, for all the teams who have won the match by batting first. And since this is a numerical column over here, I will obviously be making a histogram. So first, to make this histogram, I'll have to use plt.figure. I'm setting a figure size over here, and the dimension I'm setting it to be 7x7. Then to make a histogram, we already know that we will have to use plt.hist. And inside this, I will just directly pass in the column for which I'd want to make the histogram. So here it will be batting first, which is the name of the object, and I'll give in parenthesis and given the name of the column, which is win by runs. And I'll have plt.show. So here this is interesting, as you see over here. So on the x-axis, we have the number of runs by which the team has won. On the y-axis, we have the number of instances this has happened. So let's say if I take this over here, so this bin tells us that there have been around 100 matches where teams batting first have won in the range of 0 to 20 runs. Similarly, if I look at this particular bin, so this particular bin would tell me that there have been around 80 matches where teams batting first have won in the range of maybe 15 to around 30. Similarly, if I look at this particular bin over here, this would tell me that there would be around 18 matches where teams batting first have won in the range of maybe 75 to 85. And similarly, there would be very few matches. There would be only 3 or 4 matches where teams batting first have won by more than 120 runs. So all of this is some sort of insights which we were only able to find out after building this beautiful histogram. And also, if you would want to add a title, that is something which we can absolutely do. So here I'll just write down plt.title, and I will give this the title of distribution of runs. So here, as you see, I have given this title, and if I would want to give an x-axis label, I'll write down plt.xlabel, and I'll just write down runs over here. And as you see, the X label is runs and the title is distribution of runs. So after this, I'd want to find out the number of wins with respect to each team after batting first. So when I say this, what I basically mean is I have the winner column over here. So I just want to get the frequency of this winner column. So I want to know which team has won how many times after batting first. Let me just scroll down over here. So batting first, and in batting first, I am selecting the winner column and I'd want the frequency of this. So here, as you see, Mumbai Indians has won the most number of times after deciding to bat first. So Mumbai Indians has won 47 times after deciding to bat first. Then closely following behind, you have Chennai Super Kings with 46 wins. Then as you see, you have a huge difference over here between Kings 11 Punjab and Chennai Super Kings. So the top two teams, it seems that they win a lot after batting first. But then you see this disparity over here. Kings 11 Punjab, the third team to win the most number of times, there's a difference of 14 times over here, or 14 wins over here, and that's a huge disparity. Now what I want to do is I'd want to make a bar plot for the top 3 teams with most wins after batting first. And again, we'll do the same steps. First, I'd have to set the figure size. So I'll have plt.figure. Inside this, I will use this parameter fig size, and I'll set the dimensions to be equal to 7,7. Then I'll have plt.bar, and we already know that this takes in 2 parameters. So the first parameter is basically all of the categories, and the second parameter is the values for all of these categories. So to get the categories, which are Mumbai Indians, Chennai Super Kings and Kings 11 Punjab, so this command will be the same over here. This entire thing will be the same. It's just that after that I will give in the keys method, and this entire thing I will pass in a list. So I've got the categories. After getting the categories, I would need the values. So it'll be batting first, winner value counts 0 to 3. And I'm setting colors for, or I'm basically setting 3 different colors for all of these different bars. So I am setting blue color for Mumbai Indians, yellow color for Chennai Super Kings, and orange color for Kings 11 Punjab. And as you see over here, this is what I have. I have a beautiful representation of the top 3 teams winning most number of times after batting first. So here, as you see, there's not much of a difference, but here this is a huge gap over here between Kings 11 Punjab and Chennai Super Kings. Going ahead, I'd want to make a pie chart for the distribution of wins. So to make a pie chart, I'd have to use plt.pie. And also before that, again, I just have to set a random figure size. So by default, I'm setting the figure size to be equal to 7,7. And since I would want to make a pie chart, I will have plt.pie, and over here. So the difference between, as you see over here, between making a bar plot and a pie chart is the first parameter we will give in the numerical entities, and the second parameter we will give in the categorical values. So the first parameter will have batting first winner dot value counts. The second parameter is batting first winner value counts dot keys. Now that we have given this, I will have auto PCT is equal to %0.1f%, which would help me to show the percentages on top of the pie chart which I have created. So as you see over here, with 16.4% wins, when compared to other teams, you have Mumbai Indians leading. So you have the biggest slice over here. Then you have Chennai Super Kings with 16% wins. After that, you have Kings 11 Punjab with 11.1%. Then you have Kolkata Knight Riders with 10.8%, and so on. Now over here, let's say if I don't want these percentages, what I can do is I will just go ahead and remove out this parameter over here. Now, as you see, if I have removed the auto PCT parameter, I will not have anything on top of this pie chart. So till now we have analyzed how teams have performed after batting first. Now similarly, I would want to look at those teams who have performed well after batting second. Now for this, we have already seen this. So if a team has won the match after batting second, you will have a value in this particular column. Or in other words, we will extract all of those records from this entire data frame where the value in this column is not equal to 0. Let me scroll down. And here, as you see, from the IPL data frame, I am extracting only those records where the value in win by wickets column is not equal to 0. And I will store all of those records in a new object called as batting second. Now, I will have a glance at the first 5 records of this new object which we have created. So, as you see over here, if I show you this particular column, you would see that we definitely have a value over here. And if you look at win by runs, you have only zeros present. And that is because if a team batting second has won the match, you will have a value over here and not over here. Now, as we had done with teams batting first, similarly, I would want to understand the distribution of this particular column. That is the distribution of how teams have won with respect to number of wickets. And since this is a numerical column, I'll be making a histogram. First, I will go ahead and set out the figure size. I will have plt.figure. Inside this, I am using the parameter fig size and I am using a default size of 7,7. Going ahead, I will use plt.hist and inside this I will just pass in the win by wickets column and I am setting the number of wins to be equal to 30. Then I just go ahead and show you guys the plot. So we have an interesting histogram over here. So what this tells you is there have been around 70 instances or 70 matches where the team batting second has won with 7 wickets in hand. And if I look at this, so this bin over here tells me that there have been around 15 matches where team batting second has won the match with 3 wickets in hand. If you look at these two, 1 and 2, so there have been maybe let's say only 3 or 4 matches where teams batting second have won with 1 wicket or 2 wickets in hand. So it seems that if a team batting second has won the match, then most probably it would not have lost a lot of wickets, right? So here, as you see, you have this peak over here. So this is in the shape of a bell curve and the peak is over here at 6 and 7. So you have this peak over here. So 4, 5, 6, 7, 8. So this is the normal distribution, or this is how normally the teams lose wickets. So normally it seems that the team batting second, if it has won the match, then it would lose around 4 to 8 wickets. Let's say if it loses more than 8 wickets, then there are very, very few chances for the team to win the match after that. And also if you look at this, there have been very, very few instances where the team has won with all of the 10 wickets remaining. So here maybe you have only exactly 10 matches. So that would have been exactly 10 matches where the team batting second has not even lost a single wicket and has gone on to decimate their opponent. So this again is an interesting analysis over here. Now after this, again I would want to make a bar plot for all of the teams who have won their matches batting second. So for this, let me just find out which of the teams have performed well batting second. So here from the batting second object, I am choosing the winner column and I'm using value counts method. So it seems that Kolkata Knight Riders have performed really well batting second. So Kolkata Knight Riders have won 46 times batting second. Then close behind you have Mumbai Indians who have won 44 matches batting second. Then you have Royal Challengers Bangalore also close behind who have won 42 matches. Then you have Delhi Daredevils who have won 41 matches after batting second. Now, similarly, since I would want to make a bar plot for this, first I'll have plt.figure, fig size is 7,7, then I'll have plt.bar over here. Over here, the first parameter, I would have to set or I would have to choose the top 3 categories, which are Kolkata Knight Riders, Mumbai Indians and Royal Challengers Bangalore. So here what I'll do is I'll have 0 to 3 dot keys since I would want only the categories. Then since I would want the values, this is what I'll give over here. Then going ahead, I will give in colors. So to Kolkata Knight Riders, I am assigning blue color. For Mumbai Indians, I am setting green. And for Royal Challengers Bangalore, I am setting orange. Let me actually change these colors. So let me give in a purple color for Kolkata Knight Riders. Then I have, who do I have next? I have Mumbai Indians. For Mumbai Indians, I will give in a blue color. Then I have Royal Challengers Bangalore. And for RCB, I will give in a red color over here, so that this represents their jersey color. And as you see, I have changed the color. So Kolkata Knight Riders, since their jersey color is purple, I've given it a purple color. And Mumbai Indians, since they have a blue color, I've given them a blue color. Then we have RCB who have a red color, and that is what I've given them. Now, as we had done for teams batting second, I had made a pie chart to look at the distribution of the percentage of wins across different teams. And that is what I'd want to know with respect to teams batting second as well. So again, plt.figure, fig size will be equal to 7,7. Then I will have plt.py. Over here, the first parameter will be batting second winner dot value counts. So again, first I'm giving in a numerical value, then I'm giving in the categories. Again, auto PCT is equal to %0.1 F %%, which will give me the percentage values on top of the pie chart. Here, as you see, Kolkata Knight Riders with the maximum percentage of wins batting second, which is 13.6. Then you have Mumbai Indians close behind with 13%. Then you have RCB with 12.4% and so on. So these were some different visualizations which we had performed. Going ahead, I would want to look at the number of matches played in each season. So in the IPL data frame, we had the season column, and since I would want the frequency count of that, I'll just use value counts after that. IPL season dot value counts. And here, as you see, in 2013, we had the most number of matches played, which were 76. Then in 2012, we had 74 matches. In 2011, we had 73 matches. And over here in 2010, 14 and 16, we had exactly 60 matches played. So this is something which again is interesting. So most number of matches were played in 2013 and the least number of matches were played in 2009. Then I'd want to know which city has hosted the most number of matches. So IPL city dot value counts will give me the frequency count of this, and Mumbai hands down has won this. So Mumbai has hosted the most number of IPL matches, which are 85. Then close behind you have Bangalore, which has hosted 66 IPL matches. After that you have Kolkata with 61. And now I would want to do something interesting again. I want to know what is the percentage of a team winning if a team has already won the toss. So what I'm going to do over here is I have two columns over here, toss winner and winner. So if the value in this column is equal to the value in this column, it would mean that the team which has won the toss also has won the match. So if I compare this and this, the result would be no, because Royal Challengers has won the toss but has lost the match. Then if I compare this and this, here you would see that Rising Pune Super Giants has won the toss and also has won the match. So this again is interesting over here. So I'll be importing the NumPy library. Import NumPy as NP. Then I will use np.sum, and inside this I will set toss winner is equal to winner. And this will give me 325. So it means that out of the 636 matches, 325 times, the team which has won the toss has also won the match. So what I'll do is, I'll have 325 divided by 636, which tells me that 51% of the times a team winning the toss also wins the match. So this actually means that, there's not much of an effect of the toss. 50% is actually, well, it's 50-50, isn't it? It's either heads or it's tails. So toss maybe doesn't really affect the match that much. Now after this, we have another data frame called as deliveries, or another CSV file called as deliveries, which gives us ball by ball information of all of the matches in the above CSV file. So let me go ahead and read this file. I'll have pd.read_csv. Here I am giving in the name of the file, and this I will store in this object called as deliveries. So now that I have stored this, let me go ahead and have a glance at some of the records of this data frame. So here, as you see, I have ball by ball information. So here match ID. So in the previous data frame, we had looked at the match ID for Sunrisers Hyderabad and Royal Challengers Bangalore was 1. And this represents the same match. So for this particular match, Sunrisers Hyderabad and Royal Challengers Bangalore, for which the match ID is equal to 1, here these 5 records represent the first innings, which is Sunrisers Hyderabad's innings. And here, as you see, the first 5 balls, David Warner is on strike. So you have a ball by ball information of what is actually happening over here. And I'd want to know how many unique match IDs are there. So unique match IDs will tell me the unique number of matches. So deliveries match ID dot unique. So this, as you see over here, the values are from 1 to 636, which tells me that there are 636 unique matches. Now, out of all of these unique matches, I would want to extract only those records where the match ID is equal to 1, which means that I just want to analyze this particular match between Sunrisers Hyderabad and Royal Challengers Bangalore. So deliveries of match ID is double equal to 1, and this I will store in an object called as match1. And let me have a glance at the first 5 records of this data frame, and this we have already seen. And I'd want to have a glance at the shape of this data frame. So the shape of this data frame tells me that it has 248 records and 21 columns. Now let's understand this 248 records. What does this 248 mean? Well, a T20 match has 20 overs per side. And 20 overs per side would mean 120 balls. So 120 balls plus 120 balls would be 240 in total. So in the entire match, 8 extras were bowled. So counting both of the teams. So because you have 240 legal deliveries, so those 8 extra deliveries were either wides, no balls, byes, or something else. So this is also something which you were able to understand by using the shape method. And now, From this first match, I just want to analyze the first innings. So I'll set the inning to be equal to 1. And since the first inning is by SRH, that I would want to store in this object called as SRH. And I'd want to know the frequency of the different types of runs scored by SRH batsman. So SRH batsman runs dot value counts. So this would tell me that 57 singles were taken. Then this tells us that there were 32 dot balls. We have 17 fours. We have 9 sixes. There were 9 couples as well. And there was 1 triple taken. Now I do want to know what were the different kinds of dismissals. So SRH dismissal kind dot value counts. So here it seems that only 4 wickets were fallen of the SRH team and 3 of those were caught and 1 was bowled. And now we'll do the similar sort of analysis for RCB as well. So for RCB, what I'm going to do over here is, since the inning is equal to 2, match 1 inning is equal to 2, and this I will store in this object called as RCB. Now once that is done, I would want to know the different number of runs scored by the RCB batsman. So here, as you see, there are a lot of dot balls for RCB. When you compare the number of dot balls of RCB and SRH, this tells you the story of the match. So in SRH innings, there were only 32 dot balls. But in RCB's innings, there were 49 dot balls. And you have 44 singles, you have 15 fours, you have 8 sixes, and you have 7 twos. And I'd want to know the different kinds of dismissals. So RCB dismissal kind dot value counts. So 6-2-2, which would mean that all of the 10 wickets of RCB have been fallen. And out of those 10 wickets, 6 of them have been caught, 2 of them have been bowled, and there were 2 runouts.
What is SQL? So whenever you are going for using your data, you're retrieving data, storing data, that time you need to have a proper way to do that, right? A proper language for that. So in that case, SQL comes into the picture. So SQL stands for Structured Query Language that helps to access and manipulate your database. SQL became a standard of American National Standards Institute, that is ANSI, and also it's known as ANSI SQL in 1986, and of the International Organization for Standardization ISO in 1987. So what's the difference between SQL and ANSI SQL? So when it comes to ANSI SQL, there are some parts where you can use this SQL for any software, right? You don't need to change your SQL format for any particular software. All types of software we use for database management system that will support ANSI SQL, right? So this is what got registered in 1986. Now let's have a look at MySQL, because in this tutorial we are going to use MySQL software. Now let's have a look at how can you install MySQL. So installing MySQL, you need to go to their official website, that is www.mysql.com. And from the downloads, you can download your MySQL. But before downloading the MySQL, be sure you are not going for Enterprise Edition, because if you want to go for Enterprise Edition, you need to pay for that. But there is an option where you can use MySQL for free for the student if you want to do their own databases and if they want to practice their databases. So that time there is a free version is also available for MySQL. Right, and you also take care of your system configuration. So in MySQL, there are lots of version is available according to your system configuration, right? So you have to choose your MySQL carefully for that. Now we have already seen that how can you install MySQL. Now we will move towards how can you start coding or how can you start writing your own query using MySQL. So there are some data types concepts we have in MySQL. But what are those data types concepts, right? And what is that data type stands for? A data type is an attribute that specifies the type of data that the object can hold. The data types can be integer data, a character data, monetary data, date and time data, or binary strings, and so on. So basically, in our case, maybe we are going to use character strings, numeric values, date and time, and binary. Now we will have a look at what are the string data types we have in MySQL. So we have character data type that stores in number of characters in bytes, where in is in the range of 1 to 8,000. So basically this is the range or the length of those data types. Now comes the nchar. So what is that nchar stands for? So it stores n Unicode characters to n bytes, where n is in the range of 1 to 4,000. Now we will have a look at what is varchar, right? So it stores up to 231 to 1 characters. But wait, what is that varchar stands for? And why this is named as varchar, right? As the name suggests, varchar means character data that is varying. And it's also known as variable character. It is an intermediate length string data type. So basically it can hold number, letters, and special characters. So, and SQL varchar usually holds 1 byte per character and 2 more bytes for the length information, right? Now we also have varchar max. So what is that varchar max? So it stores up to 231 to 1 characters, actual string length plus 2 bytes, right? Now we have in varchar. So now we have in varchar. So it stores approximately n characters and to an actual string length plus 2 bytes, where n is in the range of 1 to 4,000. Now we have in varchar max that stores up to 231 minus 1 divided by 2, then minus 2 characters. Basically 2n actual string length plus 2 bytes. So these are the data types we have particularly for string types in MySQL.
Next up, we are diving into some hands-on practice, so get ready. And if you are looking to learn more about SQL, we have a full tutorial of SQL and the link is given to the top right corner. Be sure to check it out.
Azure Database Management System, right? That human resource database management system. So let's go to MySQL workbench and let's have a look at how we can do that. So here we came here and we are going to make our database. Right, so here is our tables, here is our all the datas and all those things, right? So here maybe we are going to make one database, right? So making our database, we need to write create database human resource. Use human resource, right? Let me just execute this. So yeah, so it's, you can see it's your human resource database is created. Now I am going to use that particular one. Yes, that is also done. Now we are going to create a table. What table we are going to create? We are going to create a table called countries. So there you can see I have written create table if not exists, but the thing is like if as it's a new database, you don't need to write this. Right? So what we are going to do, you can see create table countries. The name of the table is country. Then your attribute will be country ID, country name, region ID. Now country ID will be varchar, the combination of character and the numbers. Then the country ID length will be 2. As we know that country ID length is like normally we have, that is 2. Now that after that I have written one condition. What condition I have written? That will be not null. So what is that mean? We all know about what is not null. It cannot be empty. If you give it empty, it will give you throw your error. Right. I said my country ID cannot be null. It's not null. Okay. Now what we need to do, we have second attribute called country name. That is also varchar. The length of the varchar is 40. Right? And default is null. Default is null basically. If you don't put anything, then it will be null. Right? Region ID. If you put the region ID, right, there will be a region ID for the basis of region. That will be decimal. And yes, that can be decimal. And that will also be default null if you don't give region ID. Then we have primary key. So we all know the concepts of primary key, how primary key works, what is the use of primary key. For a recap, primary key is basically just to reduce the redundancy of the data and helps in relational database management systems as well. So our primary key is country ID. And if you see that key counter region FK is equals to region ID, right? And this engine part, if you want to just say, no, I don't want it, you can do that. Now, if you go and check if your table is created or no, like write show tables, right? So I just want to check this countries table is created or not. The country table is created. Now, I just want to add all the country details. Our country ID is AR, country name is Argentina, region ID is 2, right? So let me just add the value to the country table. Okay, this much we have. Okay, for that, let me just execute this. Yes, it got executed. Now, if you see, select star. So we have used select star from countries, right? Can you see all the data are stored in the table called countries, right? Now we are going to make the next table. The table name is departments. How this gonna work? I think if you want to recheck it that the same name table is there or not, that time if not exist, right? So create table department. Let's have a look at the attributes we have. We have department ID. That will be decimal again, not null. Default is 0, right? You can add both of them. It cannot be null if you don't give it. So default will be 0. Department name, that will be varchar. The length will be 30 and that will be also not null. Manager ID. Your manager ID cannot be null. Yes, no. Your manager ID can be null. That is decimal 1. The type of manager ID will be decimal and the default is null. If you don't give anything, the default will be null. Then the location ID. For location ID will be default will be null. So if you look at closely, so we are using 2. One is not null and default 0 for department ID. So you can use twice, these two together, right? Now primary key is like department ID, okay? And the other key we have that department ID and department manager ID and location key, right? These are the other keys we have. If we can execute this, let me just execute this. Yes, it's got executed, right? Now, what we are going to do, it's giving me error. Why? Because of this. Okay. Now I want to again do show tables. Execute that. Yeah. Can you see the departments is also there? Now I will put all the data to department. So we have department ID, department name, manager ID, and location ID. So if you look at it, we are not going to use insert into so many times. What we have done, we have written insert into departments, the table name, then all the columns you want to fill, right? Then if you write values and if you give 10, 20 sets of values, you can directly execute them, right? So this is the easy way to insert value in MySQL again, right? Let me just execute this. Okay, it's executed. Now if I write select star from table name was departments. Can you see your all the data got dumped, or you can say all the data got saved in your table, right? So department ID 10, department name administration, manager ID 200, location ID 1700, right? Now we are going to make one more table that is called employee table. So in the employee table, we are going to write create table employee, then employee ID will be your attribute. That will be decimal 6,0, not null, default 0. First name is varchar and that is also default null. Then we have last name, that is also varchar, that cannot be null. So this is not null. Then comes email. Email cannot be not null. So that is why it is not null. And again, it's a varchar. Then we have phone number. Okay, lots of lists, like a big list we have. We have phone number, that will be varchar, that can be null, right? Hire date, that type of the hire date, the type of the attribute hire date will be date, that can be not null. Job ID, that will be varchar 10, that will again not null. Then salary is default, it's null. This will be decimal, obviously, and the default will be null. Now commission PCT, then this will be decimal and default is null. Then we have manager ID, that will be also default is null. Then we have department ID, the decimal, default null. Now, if you can see, primary key will be employee ID as normal. Unique key. So we have 2, 3, 4 unique keys in one table, but primary key cannot be more than one. So unique key, that employee email ID will be unique key, right? And the other key will be this. These are the other keys, right? Let me just execute this part. Right. We have executed. Now, if we want to check the table, the show table part. Show table. So we will see how many tables we have created so far. It is created or not, right? So this show tables, you can see employee is there. Now we will add the data. This will be the most big data, if I'm not wrong. Right. Can you see? We have inserted all the data. Now, if you want to check, you can write select star from where? From employee. Right? Select star from employees. Can you see all the data got saved in the table? The employee ID 100, first name is Steven, last name is King. Then again, email is King. Okay, email is just the one word. Okay, job ID at praise, salary 24,000, commission PCT 0.00. Right? So this is how we are going to use this table. And these are the attributes we are going to have in employee table. As we have made 3 tables, let's have a look at the next table we have. The table will be job history. So create table, job history. Then there we will have few attributes like employee ID, start date, end date. So employee ID will be decimal type. Start date will be date type, end date will be date type, that the both will be not null, then job ID will be not null, then you will have department ID, right? Then you will have primary key employee ID and start date. This two will be your primary key, right? Now key will be this, and this is how we are going to make the table. That job history will have two attributes, and that two attribute will be primary key, right? Yes. Now we will gonna insert all of them. Insert the value of all of them, right? For job history table. Right. Let me just execute this. Now, if you want to check it is already there or not, again we are doing the same procedure. Select star from job history. Can you see you got employee ID, start date, end date, job ID, and department ID. Now we are going to talk about the next table we have, the table called jobs. In the jobs table, we will have the attribute called job ID. That will be varchar, not null. Default is in the quotation. Then job title, that will be varchar, not null. Minimum salary and max salary, right? So default will be null. Okay, that will be type of decimal. And the primary key will be job ID. So you can find the job using job ID. Let me just execute this. Yeah, it got executed. Now, if we want to insert the data to jobs, lots of types of jobs are there. Let me just execute this as well. And now we are going to write select star from jobs. Yes, so your job ID is at place, job title is president, minimum salary is 20,000, maximum salary is 40,000. Then ADVP, then ADSSST, FIMGR, finance manager, then FI account, accountant, right? Then accounting manager, that the minimum salary is 8,200, 16,000 will be your max salary, right? Now we are going to talk about the table called location. So we have written create table, then if not exist, then the table name will be location, and the attributes we have location ID, street address, postal code, right? Okay, we have city, all of them are like location ID will be decimal, street address will be varchar, postal code will be varchar, the default is null, right? All of them default is null. For location ID, default is 0 because otherwise it will be not null. So what is the use of using not null and default 0 together? So the reason is basically if you are not giving the data for this particular attribute, that time it will automatically take 0, as otherwise it will not give you any error. Right. So you have postal code, city, state, province, country ID, right? Some of them are default null, some of them are just default 0. Then primary key, location ID, then we have few keys, and yes, this is what we have for this table, the location. Let me execute the location table. Yes, it got executed. Now we will add the data. Yes, inserted into, this is all done. Now we will do the same thing just to recheck that all the data is inserted or not. We are going to write select star from locations. Let me execute that. Yes, this you can see these are the data we have. We have Via Coladia Rai, right? Lots of street address we have. We have postal code 989, city, Roma, Venice, Tokyo, like South Lake and all. Okay. Now we are going to make a table called region. That time we will have region ID, region name, and the primary key will be region ID. Unique key will be region name. Let me just do that. And let me just insert that as well, region 1. So do that. What we need to do, we need to write select star from what? Regions. Right? And we will make the ER diagram for this as well, for the reverse engineering. Then we will solve the exercise for this particular database. Okay. So to the reverse engineering, what you need to do? Go to database, click on reverse engineer. Then what you need to do? You just need to click on next. Right? Now you have to give your password. For my case, 1, 2, 3, 4, 5, 6, 7, 8. Right? Now if you click on next, you need to select the database. For my case, it is human resource. Then next. Then next. Then execute. Then next. And then finish. Right? These are the tables we have made. And what are the, can you change the, they see the difference, this symbols as we have given, right? Primary key, if you got primary key, you will get the primary key, right? Okay. So this is the ER diagram we got for this particular database, right? So this is how we are going to do that. Now we are going to do few queries to solve the problems. And if you use show tables, these are the tables you will have. Right, so these are the tables we have created according to, and based on that, we are going to use, or we are going to solve a database like SQL, assignment based on this database. Now we are doing the demo for this database, right? So now we are going to talk about how we can use or manipulate or face the data using this HR database, right? So first, what we will do? We will first start with use HR. Okay. So as we know, we have already do the show, like as we know already we have created the table. We have already inserted the data. Now we will see what are the tables we have in our database. So if you can look at here, you can see we have country table, we have department table, we have employee table, job history, jobs, and location. All right. So now what we will do, the first, let's have a look at what the first question is gonna say you to do that. They are going to say, write a query to display the names, the first name and the last name using alias name. You need to give an alias for them. That is the first name and the last name. So what you need to write, you will get this information in the employee table. Can you see we have the employee table over here? Now we will say, hey, select first name. That first name as the alias will be first name. Then last name as the last name alias will be last name, right? From employees. If we can execute this, can you see we got Elian, Abel, Sundar, and Day, right? The first name and the last name. So let's have a look at if we don't give the alias, what we will get then. Suppose we are going to write select, then we are going to write first name, comma, last name, from where? From employees. Right? Let me execute this. Yes, can you see we got first name and the last name, only the attribute name we have, it's gonna give you that. But if we add this alias, what we will get? We will get this column name as first name, the alias you gave, and the last name. So already we have talked so many times about this alias, and yes, this is something you need to remind that why do we need alias. Now we are going to see the second part, right? The second question we have. They are going to ask you, write a query to get unique department ID from employee table, right? So you need to get all the department ID that should be in a distinct one, right? All the unique department ID, not the repeated one. So as we know, if we need to use a unique part or unique data from a particular column, that time we need to use a keyword that's known as distinct, right? So now we are going to write select distinct department ID from employees. Right? So first we will do this without distinct, and then I will show you if we put distinct, what we will get. Right? So if we write this and if we just execute this part, so let's have a look at what we will get. We get 10, 20, 20, 30, 30. Can you see there is a repetition of the department ID over here? Now, as the question asks you to give a distinct one, the unique one, for that we are going to put this keyword. Let me execute that. Can you see over here? Now we don't have any repeated value. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 and 110, right? So this is how this distinct keyword works, right? Now what we are going to do, we are going to talk about the third query we have. So here what we are going to do, they are asking you to write a query to get all employee details from employee table order by first name in descending, right? So what you need to do, as we know the concepts of order by, right? So here we are going to use order by concepts in a descending order. So as we know, order by basically used to, making your data in ascending order, descending order. So we are going to write select star from employees. We are using star to fetch all the data from the table. So select star from employees order by, but you have to put order by with according to the first name. So you said first name and DESC because of descending order. In default, order by give you ascending order results, right? Let me just execute this part. Yes, if you can look over here, can you see Winston, William, Vance, Valley, Taylor, Susan is there, and lastly we will have Adam, Alana. So let me just show you, if we don't do DESC, what you will get your result, what it will do, the order by. Can you see in the in default, the default, what the order by is gonna give you? Adam, Alana, Alberto, Alexander, right? So if you put DESC, it's basically you are saying to your order by clause, hey, I want my data, I want my data in a descending order, right? Now we are going to talk about the fourth question. They are asking you, write a query to get the names, the first name, last name, salary, PF of all the employees, but PF is not there. You have to calculate the PF. So PF is calculated as 15% of salary, right? How to do that? To make a new column, what you need to write? You need to write select first name, last name, the salary. Now you know as the salary is of 0.15%. Sorry, not 0.15%, the 15%, right? So you need to write 0.15 as you convert it to percentage, right? So 0.15 as PF from employees. So you can do the calculation directly in your query as well. Can you see you got your PF as well? The first name is Steven. Last name is King, salary is 24,000, the PF is 3600, right? So this is how your PF will be calculated, the 15% of PF. Now we are going to talk about the write a query to get the employee ID, name, first name, last name, salary in ascending order of salary, right? Let's have a look at how to do that. So as they said, ascending order of salary, what it will give you? It will first give you in ascending order. So you need to use order by. So what are the columns they have asked for? They said employee ID. So you need to write select employee ID, first name, last name, salary from employees, order by what? Order by your salary column, right? So as they have already said, you have to have the result in ascending order. You don't need to write DESC because you need to have that order like the salary or your data in ascending order, right? Let me just execute this part. Can you see over here, your salary is in the descending order, first 2100, then 2200, then 2200, 2400, and keep on write this, right? 24,000, 17,000, 14,000, 13,000, 500. So you have said, I want my salary in an ascending order, Now we will jump into the sixth question. What they have asked for? Write a query to get the total salary payable to employees, right? So you will get this to employee table, but they have said total salary. As you want to have the total salary, you need to sum all the salaries. So what you need to write? Select sum of salary as employee. From employee, right? I want to give a alias for that. Total salary maybe. Right? Let me just execute this. Okay, you need to write this. Okay, you cannot give two different words as alias. For that, you have to link them with this. Okay, so as I say, total salary, your total salary for the company for all the employees, it's 691400, right? Yes. Now, if we jump into the seven number question, what they are asking you basically, write a query to get the maximum and minimum salary from employees table, right? So you have to put the maximum salary and the minimum salary. So getting the maximum and the minimum salary, what do we need to do? We need to use two functions. One is max function, one is min function. As we know, this function are already predefined in SQL. So if we execute that, you will get the max salary, you will get the minimum salary. So if I want to put alias over there, then as max salary, and this will be as min salary, right? Okay. Now, if you execute that, you will get a column name of max salary and minimum salary. So you can see max salary is 24,000, minimum salary is 2,100, right? Now, if we jump into the eighth question, that write a query to get the average salary and the number of employees in the employee table, right? So you need to have the average salary and count of total employee, right? So what you need to do, write average, the function, predefined function AVG, that is for calculating average, and then you have to put the column name, that is salary. After that, you have put down the count star. Why count star? Star will fetch all the data and it will count all the data as well. So average and count star. So average will be your as average salary of all employee, and this will be as count, total count of employee, total count, right? Yeah. Now if we can execute this part, can you see? We got the average for salary is 6461 and total count is 107. Okay, so this is how our average, mean, max, these functions works. These are the predefined functions as we know, and it actually makes our lives easy to do all this process, right? For count also we have this predefined function. There are lots of predefined functions as we discussed earlier. There are lots of predefined functions we do have. And please, we also want to know how you feel about the tutorial. Please do let us know in the comment section. And Great Learning has come up with the brilliant idea, that is Great Learning Academy. There you will get almost 80 plus free courses, and after complete your course you can claim your certificate as well. So please guys, try to make use of this opportunity as much as you can. Try to skill up yourself and get certified from Great Learning. That is also for free of cost. And yes, please do let us know in the comment section what you feel about this particular tutorial and what else you also want to learn from us, right? So now let's jump into the next query we have. Write a query to get the number of employees working with the company, right? So again, if you want to see how many employees working with the company, you need to just use the count function, as we already did that over here, that is 107. So if we just execute this part, we will get again 107. So total number of employee, right? The number of employee working with the company. So if you want to make this as the alias, can you do that? Let me just try to do this. Yes, I think you can. Yes, you got this, that the total number of employee working with the company, right? Now we are going to talk about the 10th query. Write a query to get the number of jobs available in the employee table. Okay, if you want to see how many types of jobs you have, you need to do something. Again, if you need to do that, and again, if you just look at this question quietly, I mean, if you look at the question is in a very close way, can you see they have given you two conditions. To get a number of jobs, right? You need to give the number of jobs is available, and that should be distinct, right? That should be not in a repeated manner. Okay, how to do that? So in order to do that, you need to write select. You have to use two functions. One is count, that will give you the count, and the distinct function is basically for giving you the unique ID, right? Unique job ID. So in that case, I'm from employee table. If we execute that, can you see we have 19? So if we don't use this count, let's have a look at, don't use this distinct, let's have a look at how many total job ID we have. So here I am just removing this distinct part. So you will understand the work of distinct, right? Okay. I got an error because I have, okay. Can you see the total job ID we have, that is 107. That is obvious that we have 107 employees. They will have different job ID and there will be a repetitions. But here I want all the unique type of job ID, and that's why I have used distinct function, right? Okay. Now we will move into the 11th number query. What we have now, we will have a look at that. Now here we are going to look at the 11th query. Write a query, get all first name from employee tables in uppercase. Okay, that's interesting. We need to get all the first name in the uppercase. How to do that? If you need to write select, then we are again going to use a function called upper function that will make your all the first name in uppercase from employees. Right? Let me just execute this. Can you see? You got all the name Alien, Sundar, David, Herman, Shelly, everyone in the uppercase. Now we are going to talk about the 12th one. Write a query to get the first three characters of first name from employee table. Okay, so first name, first three characters of the first name. So you don't want the all first name for all the employees. You just want three characters. As we used before, we are going to use substring function. Here we need to give three parameters for this function. One, from which column you want to use the substring. Second, from which one, like from which index you want to cut down your string, and the ending, like the starting and the ending one. So I want from first to till third one, right? So select substring first name, then one from 1 to 3 from employees. If we just execute that, can you see ELL, Sun, Moz, Dav, her, she, we got. If you say I want till 4, so it will give you first four character of the first name, right? So Ali, Sand, Devi, Harm, Shell. Can you see? Yes. So this is how it works, right? So if you use substring, be careful what are the letter you want in your data when it's gonna return. Now if we look at the 13th query, they have asked you to write a query to calculate 171 into 214 plus 625. It's very easy to do that. So if you can do that, select 171 into 214 plus 625 as result. Let me just do that. Can you see 37219? It's there. It's your result. Now we are going to talk about the 14th query. What they have asked you. Write a query to get the names, for example, Ellen, Abel, Sundar, Ande, etc. of all employees from employee table. Okay. So what you have to do, you need to, they give a format, that in that format you have to have your data. So in that case, you need to use some functions. What function should we use? We can use concat. How? So this first name and last name, both are not, two different column, right? So we need to merge them. Not even merging them, we need to format them in a proper format they have given. How to do that? That time we need to use a function called concat function. So here we have written select concat. Under that we have given the column name first name, then as they want a space between them, the space, then the last name. That will be the alias will be employee name from employees. So this is how we use concat function, and this concat function help us to format our text the way we want, right? Can you see Ellen, Abel, Sundar, Ande, Mosey, Atkinson, right? David, Austin. We got this name in a proper format. Now we will talk about the 15th question. What we have? Write a query to get first name from employee table after removing white spaces from both sides. okay, we need to remove the like if we have any white spaces, we need to remove that. So again, we have a function for that. It's always give us using MySQL is so cool, and it's actually reduce your work, because we have they have lots of like predefined function that will help you to solve your work, right? So select stream first name from employees. So we are going to use stream function. The stream function helps to cut down all the white spaces. So if we do that, can you see? You get Alan, Sundar, Mozi, David, Herman, Sally. Okay, so I don't think you can see this white spaces we had in our database, but if you have any white space in your database, or if in your data, in your database, that time it will help you to cut down those white spaces. Now we will jump into the 16th query. Write a query to get the length of the employee names, the first name and the last name from employee table. Okay, it's really a good one. So if you can look at it, how can you do that? So first you need to select first name, last name. Then we are going to use one function, the function called length function, and we are going to give you put the column we want to go for, the first name column plus the length of last name. You will get the length of full name. So length of names, as length of names, this will be the alias from employees. If we do that and let me execute this, can you see the first name is Ellen Abel. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you got the length of the name is 9. Then Sundar Ande 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the length of the name is 10. Yes, this is how this length function works. Now we will jump into the 17th question. Let's have a look at what we have. Write a query to check if the first name fields of the employee table contains number. Okay, so how to check that? So checking that, what we need to do that? We need to write what? They have asked you write a query to check if the first name fields of employee contains number. So containing number, what you need to check, you need to use regex. So regex we have used for checking the numbers if you have or not. So we have written select star from employees, where you are giving a condition where the first name regexp, regexp, that will contain from where? From the range you are giving 0 to 9. Okay, so this is where it's gonna check, okay, is there any number is there in your first name or not? If we click, if we just execute this, yes, we don't have any employee name that is, where the first name is basically with the consistency of any regex or any number. Now, if we go further, if we look at the 18th question, then we have write a query to select first 10 records from the table. Okay, now it's really a good one. How to do that? First 10 records, right? That time we are going to use one more keyword, that is limit, right? We are going to use limit. So here we have written select employee ID and the first name from employees as I want this, and the limit 10. When you have written this limit 10, that time your query is understanding, okay, this person wants what? This person wants the select first 10 records from a table, that will be 10, right? So if you look at here, you can see, can you see this? You have Steven, Nina, Lex, Alexander, Bruce, David, right? And you are using limit over here. Okay, so this is why we use limit to give the limit. At what limit you want your data, you just want to fetch the data from where? From the table. Now we are going to jump into the 19th question, as it's a little big question and there is a notice as well there. So they're asking write a query to get monthly salary round 2 decimal places of each and every employee. Okay, right? Assume the salary field provides the annual salary information. Okay, so as we have the salary column, there you can assume that column is providing you the annual salary. So now you need to break them into the monthly one. How to do that? You need to write select as they want the first name, last name, then you have to use a round function, because you don't want like after decimal, like getting a number in decimal, after decimal you want only two value will be there, not more than that. That time what you need to do, you need to say salary divided by 12. The second parameter you are providing at what point of the decimal number you want, that after decimal I want two numbers. That's why I have written 2 as monthly salary, okay, from employees. If we execute this one, let's see what we will get. Yes, we get 201416. Can you see the monthly salary? And after decimal, always you get two numbers, right? Not more than that. This is why we use round function. Now, if we jump into the one more query, that is write a query to display the name, that is first name and last name and salary for all employees whose salary is not in the range of $10,000, though $15,000, right? So basically what you need to do, as they say this dollar, so in that case, as it's not mentioned it's in INR or in dollar, we can assume this is in dollar. What you need to write, select first name, last name, salary, department ID from employees, where you are giving the condition where salary not between 10,000 and 15,000, right? They have asked you the salary in not between 10,000 to 15,000. Okay, you have to give that. I have given one more condition that's not required, as they don't specify that. If we just execute this part, can you see the department ID? The salary is 24,000, 17,000, 9,000, right? But not between, they have written 10,000 and 15,000. Right? Yes. So it's not between 10,000 and 15,000. It's above that or under that. Okay. So you got 24,000, 17,000, 17,000, right? 9,000, but it's not from 10,000 to 15,000. Okay. Now, if you jump into the next query, what they have asked you, write a query to display the name, the first name, last name, and the department ID of all employees in a department 30 or 100 in ascending order. Okay. Right, so what they have asked you, the department ID will be in the in 30 to 100, and that will be in a order by ascending order. So if you want to add AC, you can. Otherwise, if you can leave it over like this, it will automatically take it as a ascending order. So what your query will be, select first name, last name, department ID from where? From employee table, where department ID in, can you see? It's in 30 to 100, as they said. The department ID will be between in 30 and 100. So you have written department ID in 30 and 100, and then order by what? Department ID. So if we execute the whole thing, what we will get? Can you see? We get the department ID 30, 30, 30, and 100, 100, 100, 100. Right? So in 30 and 100, only you have the department ID 30 and 100, and that too will be in ascending order. Right? Can you see 30 first and then 100? Okay. Now, if we jump into the third one, then they have asked you write a query to display the name, the first name, last name, and the salary for all employee whose salary is not in range 10,000 and 15,000 are in department 30 and or 100. Okay. So yes, here you will get two query, right? One query, not query, we will get two conditions. One condition, salary between 10,000 to 15,000, not between 10,000 and 15,000. And the department ID will be only 30 and 100. So we have written a query called select first name, last name, salary, department ID from employees where salary not between 10,000 and 15,000 and department ID in 13 and 100. We have done this separately. Now we are merging them. To merge them, we are going to use a keyword, that is and. Can you see? They have to have they have to qualify both the condition you have given, then only you will get the data. This is your condition, the whole condition. Each and every row needs to maintain. Can you see? You got it. The salary is 3100, department ID is 30. And they are not in between 10,000 and 15,000, and the department ID in 30 or 100. Right? Now we will jump into the fourth one. Okay, what they have asked, write a query to display the name, first name, last name, and hire date for all employees who were hired in 1987. Okay, So in this case, I did not write the code. Okay, so in that case, if I want to see, select star from employees, the hiring date will be there. Okay, so what we have job ID, salary, a commission, PCT, department ID, and a hire date, right? So you need to get this, 1987. Can you see the hired who were hired in 1987? So first, let me just try to do that. Select star from employees where hire date is equals to, you need to do what? Year of hire date. If we use the function called year of hire date is equals to 1987. Let's see what we will get. Can you see the year we got for 1987 only? Yes. So if you want to get only the year, right? How to do that? Okay. So basically it's under comment. Okay. It cannot be executed. So if we execute this part, right? Can you see? You got it, the hiring date. Okay. So yes. So if you give that the year of hire date equals to 1987, you get all the hire date, that is 1987. So what it will do, it will only extract the year from hire date and it will match. Okay, is the hire date equals to 1987? If it's there, then it will fetch that, right? Now let me put this again in comment. So if you need to do comment, you can see this is how you need to use the comment one. Right? So the fifth question is asking about write a query to display the first name of all employees who have both B and C in their first name. Okay, now I need to check who have B and C in their first name. How to do that? Select first name from employee, where first name like we use the pattern matching. So what you need to have, you need to check is B there in their name. So in that case, percentage, anything can be before B, and after percentage anything can be after B, and one more later, that is and first name again like before percentage C, like the percentage before C, it's basically any word or any character can be there before C, and after C also there will be, after C also there will be lots of or any alphabets will be there, right? So if the B and C is there in the first name, then only it will return all the record. So only Bruce, can you see? Only Bruce has B and C. So this is how this like or pattern matching works. So like is basically used for pattern matching. If you try to find it out one particular letter is there or not. If it's there, then you can use like function. As we talked about the like function, now we will have a look at the sixth question we have. Most probably this, okay, right. We almost came to the last part of this query solving part, right? And please do let me know and do let us know basically in the comment, do you like this project or not? Because we are trying to give you a proper intuitive idea that how this SQL works, how you can to solve the query, and yeah, how can you start your career in SQL as well. Right. So now we will look at the sixth query, that write a query to display the last name, job, and salary for all employees whose job is that of a programmer or a shipping clerk and whose salary is not equals to, okay, $4500 or 10,000 or 15,000. Okay, there are lots of conditions we have, but okay, we know how to deal with this, right? So break it first. First, write select last name, job ID, and salary. These three fields you need. Then from where? From the table employee. Then you need to write job ID. They have said job ID can be IT programmer or SH clerk. Right? You have written that. Now the salary not in. You don't want the salary will be in this. So salary not in 4500 or 10,000 or 15,000. Right? If you execute that, let's have a look at the the results we have. That Hanold IT programmer salary 9,000, Austin IT programmer salary 4800. Then Bull SH Clark 4100. Then Carbios SH Clark 3000. Right? Yes, your conditions are working. And whenever you put AND, don't forget this AND is basically you have to, the query have to, or the data have to maintain both the conditions. Right? Now, if we look at the 7th query, what we have? Write a query to display the last name of employees whose name have exactly 6 characters. Right? Okay. So now we need to check if the name has exactly 6 characters or not. Okay. How to do that? Okay, let's have a look at how we are going to do this. Okay, so select class name from employees. We have written 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Can you look at this? Okay, so I will show you how we are going to do that. We have written select last name. I am just removing this. Why? Select last name from employees where last name like. Again, we are using like for the pattern matching. Then they have said exactly 6 character. You have to use this for exactly for 6 times. 1, 2, 3, 4, 5, 6. Can you see? I have printed this a particular sign for 6 times, right? Yes, this is how we are going to use, right? Now, if we execute that, the same result we will get. Can you see? Austin, Bissot, Carbio. Maybe if I can put one more. Okay, so in that, let's see what we will get. Can you see this D, Han, then Higgins, then Kocher, we have this parts, right? So exactly if you want 6-1, you have to use this particular sign for 6 times. This is how this like or pattern matching works. Now we will talk about write a query to display the last name of employees having E as the 3rd character, right? So if you want to get this at the 3rd character, can you see? I will put this underscore for 2 times, or if you say exactly as the 3rd character, right? So 2 and then E will be 3rd character. After that, anything can be there. Okay, so if you want to say, I want this particularly at this particular point, that time you have to use this particular sign. Okay, so we have written select last name from employee where last name like the underscore E percentage, 2 underscore and then E percentage. Can you see Abel, Bayer, Chain, Everett, Finney, Fleor, right? They have the exactly E in the 3rd position in their name, in their last name basically, right? Now we will talk about the 9th one. Okay, we have 5 to 6 query left. Let's do it as like quickly and just complete this project. Right, so they have asked you write a query to display job or designation available in the employee table. Again, we have done this. So distinct job ID from employees. Right, now we have one more query. This is done. We have done this PF calculation before as well. Now we have a new one. Write a query to select all records from employees where last name in Blake, Scott, King, Fraud. Right. And how can you do that? You need to use in basically select star all the data from employees where last name in Jones, Blake, Scott, Keen or Ford, right? So you want all the last name should be in between this. Otherwise, no, you don't want the data. Can you see Jones, King, you don't have Scott or Fraud, right? Okay, this is how this works. Now, if you want to use an aggregate function and a group by, how to do that? Write a query to list the number of jobs available in the employee table. So yes, we have done this count and distance again. If we look at this, already we have done this total salary payable for the employees. And the last one, we have the minimum salary. Obviously, we have done this select mean salary from employees. It will give you the minimum salary from your employee table, right? 2100.
The definition of big data, if you Google, you will get. First thing, you can just go to Google and say, what is big data? You will get tons of articles, PDFs and presentations. That is not what I'm going to teach you. Let's take a practical use case, right? Let's take a practical use case and try to understand how big data actually makes sense, right? First of all, big data is related to IT. So you need some level of IT knowledge to be fair, right? This has something to do with IT. I will share my personal experience. Okay, so when I started working in 2007, 2008 and all, okay, I was working with a company in Bangalore, and we had created an application, a sales application. So basically what we'll do, if you install this application, there was a retail company, the customers will input all their sales data in that, so they will say that today this much quantity item sold, sold and sold and sold, and this application will capture all the data, okay, and store it. Now that was a very simple world. We did not had mobile phones, we did not had Facebook, WhatsApp, nothing was there, 2005, right? And we were using an RDBMS system to store this. You know what is an RDBMS? So RDBMS is what we were using to traditionally store the data, right? And what is an RDBMS system? It has a row column format. You have a table. You insert the data. Now, if somebody is teaching you RDBMS, they will say that, well, RDBMS is great. It can store everything, that's all fine. But unless your data starts increasing, right? So originally, RDBMS can store everything. I don't have any, I'm not against RDBMS or something. Even for transactional management, we use RDBMS. There is no doubt about it. MySQL, Oracle, we were using MySQL actually. So whatever the customer is inserting, this MySQL will capture it. End of the year, you do some processing. You will understand how many items were sold. Everybody is happy. This is what was happening in 2005. Fast forward to 2011. I am working with ICICI Bank. ICICI Bank want to migrate to big data platform. So what is the problem with ICICI Bank? Right? So that is the question. Why ICICI Bank want to go to big data, right? Now, this example will also help you to understand the IT world, right? So for people who are not coming from the IT background, they might need to understand how things are working, right? So we went to ICICI Bank, we spoke with them, we said, hey, what do you want? They said, you know what, we are facing a lot of problems. We want to go to big data. We want to go to Hadoop. We'll see what is Hadoop later. So we asked, what is a big deal? What is your problem? So there were a lot of problems which they were facing. One of the problem is that if you look at this RDBMS system, right? Your typical RDBMS system. What is RDBMS systems doing? They will store the data in the form of a table, right? Now, if your table size is very, very small, it's not a big deal. Even if you look at MySQL or if you go to enterprise scale Oracle and all, they can store gigabytes and sometimes up to terabytes of data. But as the size becomes big, so let's say I ask you, okay, you have to store the data in Oracle. The data is keep on increasing every week. You are not ready to migrate anywhere. Oracle, if you talk only about Oracle, they have storage separate and DBMS engine separate. In Oracle, what I can do, I can purchase Oracle and I can add storage boxes, as many as I want. So these boxes will be in the network. So my database engine will be connecting to them and storing the data, whatever data I'm giving. So you can argue saying that I can increase the storage capacity and then Oracle can store as much data as you want. There is no doubt about it, right? But there is also a limitation for this storage, one problem. Second problem is that as this box increases, the storage in Oracle increases, you have to divide your data. So you are selling iPhone, let's say you're working with Apple, right? So one of the example is that if you are creating tables to store iPhone data, typically if you look at the schema and all, what we will do is that there will be one table, okay? There will be one table wherein you will be having properties like, how many items were purchased, at what rate they were purchased, how many people bought, so on and so forth. So this will be your items table. So in the items table, you will have all the data related to the iPhones you were selling, right? You will also have another table where there will be the user data. You will also have the user data. You know what is normalization? In RDBMS systems, in order to avoid duplication of data, what we do is that we normalize the data. We always keep the data in different tables. So if I want to get both the data from this, I have to do something called a join query. I fire a join query and all the data from here will come and join and produce me the output. This is good if you're having small amount of data. What if you have terabytes of data here and here? My join query will fail, right? Or the join query has to wait. Now another point that people say is that if your RDBMS is becoming bigger and bigger, why don't you partition your data? That is possible. I can have like 4 boxes. My one table, okay, if this is my table, right, it can be logically partitioned and kept on 4 machines if it is becoming bigger and bigger. Okay, this is possible. There is something called logical partitioning. Look at the iPhone data. I can say all the data where people from India are buying the iPhone, go to this machine. That's called logical partitioning based on the country column. So here I have all the India data where people are buying iPhone. Here I have the US data where people are buying the iPhone. But the problem is here I'll have the Burma data also. India data will be, let's say, 2 terabyte. China data will be 3 terabyte. This will be KBs actually. Because in Burma, I don't think a lot of people are actually buying iPhone, probably, right? Exactly. So the problem is that if a table is becoming so big, okay, I can cluster it. I can take 4 machines in my RDBMS or data warehousing architecture, and I can say partition the data. Because if a table is so big, if I fire a query, the query will take a lot of time. So what I do, I say that, okay, don't store the full table, divide the table or partition the table. To partition, I will say that you have to use some logic for partitioning. I cannot physically divide the data. That's not possible in RDBMS. I cannot say that take a table and cut it into 4. Doesn't work. So I have to logically partition. So I have to say that there is a country column. How many countries are there in the world? Maximum 155, right? I'm not much of a geography person, but I think somewhere around 155, right? Or at least people who buy iPhone, 155 countries are there. So I will say take the country column. So everybody who is buying an iPhone will have a country column. So based on the country column, it will partition your data, right? Now I have 4 boxes. This box has India data, US data, Burma data, and something data. Again, same story. If you're running the join query, this box has to process all the India data for join query. This box will complete very fast. This guy has to wait. So again, so the problem is that traditionally people were using RDBMS systems and data warehouses to store the data. Now, what is the drawback? One of the drawback is that as the size of the data increases, your processing will become very, very slow. Why don't you denormalize the data? Why don't you denormalize the data? For example, all the transaction data, user data, everything I'll keep in one table. Is that possible? I can't do. So that is the reason they don't provide the denormalized solutions. If you look at RDBMS systems, they will always say normalize your data so that it will be represented in different tables, and whenever you need the answer, you do a join and you get the result. Second drawback, this is only structured data, meaning anything which you can represent in row column, I can dump here, like an Excel sheet data, right? Can I dump images and audio files in this table? Yes or no? Can we store unstructured data in RDBMS? Yes, you can. There is CLOB, blob, and all objects, right? But can it process unstructured data? Not possible. So, size of the data increases. It cannot cope up with processing. One of the problem, right? Second problem is the schema. Meaning, anything which you can represent in a row column format, I can dump in an RDBMS. Anything apart from that, I have to figure out a solution. So what is the actual solution if I have to store images and retrieve them in real time? How does Flipkart stores the data? I was working with Flipkart for some time. Flipkart has around 10 million products. Each product has 10 images. That is 1 billion images. So when you click on a iPhone X picture on Flipkart, Flipkart will say that come after 10 minutes or immediately display. Have you ever thought how it is happening? How it is happening, right? So do you think they're dumping in an RDBMS and picking it from there? 1 billion images. There is a whole arena of databases called NoSQL. If you have heard about MongoDB, Cassandra, HBase, Neo4j, Voldemort, these are all popular vendors of NoSQL database. So NoSQL databases will help you to store and retrieve unstructured data at any speed you want. So what Amazon.com actually does, Amazon has something called DynamoDB. DynamoDB is a NoSQL database. So in DynamoDB, I don't have a row column. I have key value pairs. So what they do, the key will be the product name. Say you're clicking on iPhone X. iPhone X is the key. The value will be all the data you have. So the moment you click, boom, your page is there. So NoSQL databases are really faster. Also, it helps you to store unstructured data. How are you booking a cab using Ola? If I try to get a cab using Ola, right, I open up Ola. How many customers Ola has? Millions in India. And all of them are booking at the same time, right? Do you think all your requests are taken by an RDBMS and searched in the table and give you a cab? Does it work? Can an RDBMS system handle 30 million, 40 million concurrent sessions on this amount of data, calculating route? MongoDB, NoSQL database. Ola runs on MongoDB. I was working with Ola for one of their design problems actually. So I didn't design anything, but they told me that they are using MongoDB. So the second drawback of your RDBMS is scalability is there. Okay. Third is price. Price is a problem, right? I mean, obviously, if you calculate the cost, if you look at Oracle and all, they are very, very costly solutions. Traditionally, storing the data on an RDBMS and retrieving is not good for the modern day. In the modern day, what is happening is that every company wants to collect and analyze the data. Be it banking industry, e-commerce industry, or any industry that you want, they want to collect and analyze the data. So to give you an example, if you visit Amazon.com or Flipkart.com, what is happening? They start tracking from which IP address you are visiting the website, how long you are clicking on a page, which items you are adding to cart, which images you are clicking, which offers you are clicking. All this data is analyzed to understand how a customer will behave. That is how they do marketing, right? So the more you start visiting the e-commerce companies, you start seeing recommendations and all the more. The more you visit Amazon, they will start recommending products to you, asking you to buy. So they have to collect all this data. So when I was working with Flipkart said that they collect data from the apps that you're using, from the website that you're having, even from social media. Flipkart is very active in social media, like Facebook, Twitter, all these places they are active. So if anybody tweets about Flipkart or visit their Facebook page, all this data is being collected. Now this is actually called a big data. So the technical definition of big data is this huge amount of data which you cannot process using your traditional methods. That is called big data, right? So why that is of interest to us, we are going to figure out how to store this data, huge amount of data, right? And how to process this data. When I say NoSQL databases are there, it does not mean your RDBMS is gone. So many people ask this question. Okay, RDBMS is the only solution for transaction management. So even if you're buying something from Flipkart, who will complete your transaction? Oracle probably, or any transactional system. For transactional management, and why is that? Because RDBMS systems are the only ones which can ensure the ACID properties, right? If a transaction goes or not goes. You bought something from Flipkart, tomorrow Flipkart cannot come back to you and say that, I don't know whether the transaction happened or not. Probably you got the money. It's not possible, right? Then you will start complaining against Flipkart, right? So Flipkart comes to you and say that, you know what, we are using Cassandra. As per Cassandra, your transaction is, we don't know, we'll come back to you in another 1 week. Is that possible? No. So transaction management, very good question, is still handled by RDBM. Polyglot persistence. In the world of big data, there is a separate category of systems called NoSQL databases. And they are databases. So what is a database does? Real-time queries, right? And in that area, we have MongoDB, Cassandra, HBase, and these guys. Now, these guys are used in real time if you want to fetch the data. Say, for example, you are opening an e-commerce website. Probably it is given by a NoSQL database, right? Or millions of people are booking flights through cleartrip.com, and Cleartrip has to identify how many people are booking in a particular route so that you can give a better offer. This is probably done by reading real-time data from a NoSQL system. Our area is not NoSQL. NoSQL is a DB actually, it's a database. Our area is not NoSQL. We will come to Hadoop, right? Now, so this is that technical term for coexistence of DBs and NoSQL and all. Now there is a very important term, even though it is not directly related to your syllabus, but I think it makes a lot of sense. How many of you are aware of this term? So ETL stands for extract, transform, and load. So what is the idea here is that, see, if I'm working with a company, right? The company will have RDBMS systems, right? So these are all RDBMS systems. So probably this guy is using MySQL and he's also using Oracle, right? A lot of RDBMS systems are being used by a company, right? Now these are all serving the customers. So if you take the example of ICICI Bank, all their core banking data is in Oracle. All their core banking data is in Oracle. So if you are making an online transaction, the data hits Oracle. All their CRM data is in MySQL. What do you mean by CRM? Customer relationship, right? Your name, address, blah, blah, blah. So they have these two type of data. Now, is this the only type of data that they have? No. ICICI Bank had also acquired a lot of other companies when we were working with them. So their subsidiary companies were giving them data in the form of XML files. XML, right? Now ICICI Bank also had a Facebook page, okay, from where they were getting around 10,000 people visiting every day that Facebook page, and they used to click on some item. So they have to do this cross-selling, upselling. If a user goes to Facebook page and say that I really like your lawn, take more lawn, right? So that is your cross-selling and upselling, right? So what they do, they collect all this data from social media. That comes in the format of what? JSON. JavaScript object notation, JSON, key value pairs basically. So this is where their core banking data, this is where their CRM data, this is from their partner companies, this is from the social media data they are getting, okay? This one, the social media data, they want to do analytics. So every day 10,000 people are visiting their web page. They want to know a person clicked on, let's say, a loan offer and how much time he stayed on the page and what age group he belongs to, so that they can recommend products. Recommendations actually. A lot of recommendations. So social media data was being used. They did not reveal all the things that they are doing because that were internal to, but basically using the social media data, they were doing recommendations. So they will download all this data. So if a customer is clicking on the Facebook page, they will get the access of this guy. If you are clicking on ICICI Bank's Facebook page, they will know your age, your occupation, everything you shared in Facebook. That is by default given to them. In most of the cases, you can restrict the information, but most of the public customers, they will share this. So by downloading this data, today they will understand 10,000 people clicked and out of them 5,000 were youngsters and they clicked on this loan. That means the trend is towards a particular bike loan. If we give an offer on bike loan, youngsters may actually buy it. So this is analytics, right? So all the social media data they can use in multiple ways actually. So this was getting in the JSON format actually. And this type of data was there. They also were collecting their customer care log files. So that is again flat file. It was coming in a format of flat file. Flat file means text file. So customer care log actually means the chat logs that they were having, also the call logs. They don't record, they don't get the actual call, but how long the call happened and what you pressed. So when you call customer care, you press, right? This. That is actually captured. And then they want to figure out how many people are called on what category, how much time they spent, right? So if you are clicked on a complaint button and you talk for 1 hour, chances are very high you are a bad customer, right? I mean, 1 hour you're scolding probably, right? So they want to figure it out, right? So that is the call record that was coming in flat file, this format, right? And at that point in time, ICICI Bank also wanted to offer a solution. So previously what they used to do, their agents were there, people who go to your house and make you buy loan and all. So they used to go to every place. So this agent will get a list and he will go to that place and he will go to your house and say that, sir, please take a car loan. You will say no, he will say buy. He will get money. He is getting salary, right? So this technique was not working because if I get a list, okay, one customer will be in, one guy will be in OMR, another guy will be in some other remote place in Chennai. So by the time he travels from here to that place, day will be over. So he is able to cover only 2 customers. So what ICICI Bank had in mind, they will track his location. He has a device, okay, and give him customers in real time. So if he's in Kannanjavadi, he'll get all the customers nearby him. So this guy has to go, right? He cannot say I can't go. So he will, the customer application, it was a tablet, will track this guy. And wherever this guy goes, the nearby customers will be provided to him. So he can cover more customers, right? And this has a lot of impact, because why it was practical? Because sometimes the customers will call and say that, please come, I'll give you a loan. So what you do from here, you might travel to Paris, right? And because the customer called, right? So you go to Paris and meet the customer. Now you don't know how many customers are around Paris. That this application will track and send it to you. So these guys were collecting that data also from all the tabs. And that was quite some big amount of data they were collecting. So how many customers they met and whether they closed it or not closed. Okay, that was coming in, I think, some other format. So some format I forgot actually how it was coming. So this is the whole data they have, right? And some more data was there. And this data is lying on different systems. It's not in one place. The core banking data is in Oracle. Some other data is in some other place, right? And if you want to analyze this data, one thing is that I cannot go to Oracle and say that I want to analyze your data. Why? Because this Oracle DB is already busy serving customers. Correct. This Oracle DB is the core banking database. So if you are making a transaction, Oracle is handling that, right? So I cannot go to Oracle and say that let me run some analytics on your data. Doesn't work that way, because then Oracle will slow down. I can't do that. So I have to take all this data from all these places and dump it into a central place. So that is what is you call as your data warehouse, right? That is called a, how many of you know what is a data warehouse? So a data warehouse is nothing but a database only in one way. It understands the language of SQL, but the major difference is that it is not facing the customer. So you will do something called ETL. Okay, so there are ETL tools which can get the data from all these places, right? And this guy will dump it into a data warehouse, right? So data warehouse is also called as your OLAP, online analytical platform, so on and so forth. And what is the purpose of this guy? So this guy will have all the data from here, okay? And you can transform the data as well. So that is why it is called ETL, extract, transform and load. You don't just take the data and dump it here, then it is useless, right? I can read the data from a flat file and give some structure and then dump it here, like a proper table format. So now all my data is here from this, right? And I can run business intelligence here, BI tools, Tableau, right? If you have heard about MicroStrategy, Tableau, what I can do, I can connect a visualization tool here and it will show me in charts and diagrams what is happening. I mean, this is traditional enterprise architecture. This is how people used to work forever. I mean, every company you go, this will be there by default. They will have these disparate, discrete data sources and ETL tools. So if you have heard about Informatica, Informatica is one of the biggest ETL tool. Informatica, Talent, Pentaho BI, SSIS. So these are all ETL tools. So these tools, what they do, they will connect with here and take all the data and apply some schema and push it to a data warehouse. Now the data will be here. So now all the data is in one place. So Chandra Kochar may not know SQL, right? You can't expect that, right? If you're a CEO of the company, I can't ask you, do you know Java? I'll be fired next moment, right? So, but the CEO want to know what's happening, right? By getting all this data only, you will understand what's happening in the company. But you don't have time to sit and learn all this language or anything. So if I'm Chandra Kochar, I'll go here, I'll connect my Tableau, and I'll ask my Tableau, show me the last month's transaction, this quarter, this product, this area, show me, it'll show a nice bar chart. Now, why this is very, very important? If you make any mistake in any of this entire stuff will be changed, right? And what she sees will be different, right? She has no idea how this is happening, right? Only you know how this is happening. So your ETL tool should run proper, the data should be captured and dumped here and then analyzed. So for CEOs and CTOs, they use visualization tools to connect with a data warehouse, then analyze the data. So all the data is inside this data warehouse, right? And this is not accessible by public. Public has no access to this. Only internal company has access, like maybe CEOs of ICICI Bank, they can go here and visualize the data from here. Others, public does not have any access to here, right? And then they visualize the data, they make a decision, they may not make a decision, that is up to them. In the whole setup, there is no Hadoop so far. And this is how ICICI Bank was running so far. Now, what were the challenges they faced? One of the challenge was that this ETL tool, okay, I don't know how many of you have run on ETL tools, okay, they typically run on a single machine. So there is a limit as to how much this guy can pull to a data warehouse. How much amount of data this guy can pull from here to a data warehouse, there is a limitation. You can't have terabytes of data being pulled. Point number one. Point number two, none of this is real time. I go to Tanishq's store. Tanishq is a jewelry stuff. I go to a Tanishq store. I buy something from there for 20,000 rupees. I use ICICI credit card. I should immediately get a message saying that again you shop 20% discount. That is real time, because all this is separate data and these ETL jobs run at the night. So today morning if I'm shopping, tomorrow I'll get the message 20% off. By the time I'm out of Tanishq shop, right, I may not use it at all. So ICICI Bank's first problem was that since the data was increasing, they were not able to run ETL properly. Second problem, none of this is real time. They wanted to push customized offers. Their requirement was that whenever any transaction is made, they want to capture it, analyze it, right? And based on that, they have to recommend something to the user using credit card or debit card, or even you're clicking on some link, immediately something should happen. Now that is not so easy, right? Because your data might be somewhere in here, Oracle, and I cannot track each and every transaction here because this is my transactional DB. I can't say that track each and everything from here, right? That's not possible. Third problem, this data warehouse. This data warehouse is a very costly affair. I have worked with a company called Teradata. They are the leader in data warehousing market. I had a US client, they were using a product called Teradata for data warehouse. They were paying around $5 million every year only for this setup. Now it is good. You can analyze the data and all, that's okay. But you're paying a lot of money actually. So data warehousing is actually a very costly affair. It's not so cheap if you want to implement. But companies like ICICI Bank, they must use it, right? So they can't say that we will not use it. So they wanted a cheaper solution. They don't want all their data in this data warehouse. They want an alternate solution. It should be real time, cheaper, scalable, right? And anything they want to integrate, any type of data that comes, they wanted to integrate. And that is how they came to us and asked us, like, can we migrate to some big data solution? And we recommended Hadoop, and then the migration took a lot of time. That is a different case altogether. There is something called MPP. MPP means massive parallel processing. So a lot of people came saying that, so these systems are actually, Teradata and all are really faster actually. I mean, not like RDBMS, but they are faster, okay? So a lot of people came up and said that, okay, if your data warehouse is very slow, why don't you do parallel processing, okay? You install it on 4 or 5 machines and you can do parallel processing. That is possible, but still the same problem exists. You cannot physically divide your tables. Only logical division is possible. Like I said, country-based you can divide or month-based you can divide. End of the day, if you want to do a join operation or something, same questions will happen. So I can never propose this as a real-time solution. So that is my crux of what I'm trying to tell you. And this is how even ICICI Bank was running. And cost was another problem. They had a lot of cost involved. So, and obviously since they wanted to collect a lot of unstructured data, they wanted to go to a better solution, okay? And that is how Hadoop came into the picture. So now the point is that, now let's discuss a little bit about Hadoop. So what I thought is, like, today probably we can cover the architecture and a little bit of theory, and then you have MapReduce. Now, there is a catch here. MapReduce is the default programming framework on top of Hadoop. So if anybody want to analyze the data on top of Hadoop, they use something called MapReduce. Point number one. Now, MapReduce came long back, okay? And today there are a lot of ways to analyze the data, not only MapReduce. Now, as per your syllabus, the curriculum says teach MapReduce and then some concepts in MapReduce, and I will be doing that. But one other thing is that if you want to learn MapReduce, ideally you should be an expert in Java, because MapReduce programs are written in Java. or any other programming language. So you can write in Python and other things, but natively people write MapReduce programs in Java. Now I know that not all of you are familiar with Java and comfortable with Java. So if I talk a lot about Java, it may not make much sense out of you. But then why you are learning MapReduce is to help you in Spark. So next you will be learning something called Spark, right? 16 hours of Spark content will be there. Spark also uses similar concepts as MapReduce. So even though you are not able to understand each and every line of code that I am writing, that's okay. But you need to understand the logic, how it is working. Because Java programs, not everybody will be able to follow and understand and debug. So that is not expected also from you. But if we discuss MapReduce, I write a MapReduce program and we run a MapReduce program, you should be able to understand what is happening inside that, right? Logically, not like syntax wise, line by line wise, right? So once we complete Hadoop architecture, like tomorrow, I will be discussing MapReduce theory and MapReduce programs will be running. And then in the next 8-hour syllabus, we will be completing bit of MapReduce and going to something called Hive, Apache Hive. So Hive is your data warehouse in Hadoop. So that is more of SQL side. So you can understand that point. So now speaking of Hadoop, our architecture is here still. I just changed a little bit. Okay. I'll just write it here. The question is when all this happened, right? So a lot of people, so I handle a lot of trainings in Hadoop and Spark. So a lot of people ask me that, okay, so we are learning a completely new technology called Hadoop. And I will say that you are wrong because Hadoop came in 2005. So almost 13 years now. So it's almost like very old, but for people it is still very new for those who do not understand Hadoop. So in 2005, this framework called Hadoop was created, okay, long back, right? And there were two guys called Doug Cutting and Mike Cafrilla who created this framework. They took the original idea from Google. So Google was already doing a lot of distributed computing and Google was dealing with a lot of big data, right? So they published a couple of white papers and this Doug Cutting and Mike Cafrilla, they took the idea from Google and then created a framework called Hadoop. And later they gave it to Apache as an open source project. So Hadoop is a open source project actually, which means it is with Apache right now. You can download it for free, install it for free. You don't have to pay any money. But if something is really free, you have drawbacks also, right? Correct? For example, you have Android phones. I have an iPhone. I used to use Android phones, but you know the difference, right? The difference is not show off. That is not the difference. The real difference is that Android phone might get a lot of bugs, which may not come in an Apple phone. If you have used both, you will understand. The problem is Android is open source, right? And open source means every company will modify according to the requirement. As Samsung phone will have their own Android, right? So accordingly, a lot of bugs may come. The platform may not be so stable as it is. If it is an Apple phone, only Apple produces it, right? And if there is a bug also, if I call Apple or somebody call Apple, they will fix it because there's only one version of it available and they know what bugs may come, may not come. So the same story here, originally it was Apache Hadoop and even still you can go to the Apache website and download Hadoop. But soon people realize that if they are using Apache Hadoop, it is open source, but if something does not work, something crashes, nobody is there to fix it because it is open source. And accordingly, a company called Cloudera came. There is a company called Cloudera. You might have probably heard. Cloudera is the first company which created a commercial distribution for Hadoop and related tools. So today you can go to Cloudera and ask them to give you Hadoop. What is the advantage? You will be getting the same Hadoop, almost similar what you find in Apache website. But if you install it and if something is not working, they will fix it. You have a support. Since you are paying money, you get support, just like a vendor, right? So one of the companies which is very popular in the world of big data is Cloudera. So they sell Hadoop, Spark, everything as a bundle, okay? Even your lab actually has Cloudera distribution. The lab we are going to use actually runs a Cloudera distribution. Only thing, they should also provide a free version, and they do it. So if you go to Cloudera, you can download the Cloudera's product for free. You don't have to pay any money, but you will not get support. So what people do, they will buy only with support, right? So if I want to sell Hadoop, I can start a company, I can download from Apache, modify the source code, I can sell it to you guys. But two things, one, I should give a free offer also, no support. Second thing, that is the story with every open source, right? You have Ubuntu Linux, you have Red Hat Linux. What is the difference? Hadoop, and you can download from their product. Cloudera's is not 100% open source, it's a custom product. But you can download it for free from their website and install it on as many machines as you want, but you will not get technical support. So ideally people will not do it, right? Because you need technical support, so you will pay money and get it actually, right? But these are the companies, the Hortonworks and Cloudera as the leading vendors in the big data world. They also provide certification. So if you want to write a certification exam, probably after the Spark class, you can try that. Cloudera provides certification exams in the big data world. You can write it and get. There is also one more company called Mapr. To be very fair with you, why still people are trusting all these companies, Microsoft or Apple or Oracle? They get support, right? Something doesn't work, you cannot be able to fix, right? You have to call them and make them fix. So Mapr is the third company, which is sort of like popular. This company, if my information is correct, was created by a couple of people who quit Cloudera and Hortonworks, Indians only, right? And they found this company called Mapr. Mapr is very popular these days, actually. No? A very, very popular vendor. The highest paid edition is also Mapr. Mapr's architecture is also very different, not like traditional Hadoop architecture, right? So for that reason, like I went to GE, I went to Flipkart, they are all using either Hortonworks or Cloudera. They don't use Mapr much. Apart from this, IBM has their own flavor. It's called Big Insights. Microsoft has their own flavor. That's called HD Insight. HD Insight is there. Amazon has. Every company has an edition of their own Hadoop and big data platform. But most popular ones are Cloudera, Hortonworks, and Mapr. These guys are the most popular ones actually. For a developer, there is not much difference. For example, if you are writing a MapReduce program, it will run the same way on all three platforms. There is not much of a difference. The difference actually is that Hortonworks is totally open source. They sell the same what Apache gives. Cloudera modifies it a bit, and they say that with the modification, Hadoop is more stable. That is their claim. We don't know. It's all marketing gimmick. It is same like buying an Android, Samsung mobile phone and HTC mobile phone. What is the difference? End of the day, internally it is Android. But Samsung will say that our Android is better, more bug-free or something. HTC will say that this phone will never hang. So only HTC or Samsung know what they have done inside the phone. But end of the day, if I download, let's say WhatsApp, it will run on both the phones, right? Because it is Android. So same thing only, it's just a commercial distribution. Same story with Linux. You can buy from Red Hat. There is also one more provider, right? SUSE. Red Hat Linux, SUSE Linux, internally everything is same. If I type an ls command, it will work both ways. Kernel might be slightly different, but end of the day, they are paying open source original Linux only. So same story here, but considering the platforms, Cloudera seems to be more popular, okay, because they got a head start. 2008 they started, right? Long back they started. Hortonworks is also gaining a lot of popularity these days. I have been seeing that. And why you are learning MapReduce? Two reasons. One is migration. A lot of companies will already have a lot of MapReduce programs and they want to go to Spark. So if you want to go, you should know what is MapReduce. Second reason, even for learning Spark, the concepts of MapReduce are important. Spark also was built on the basic idea of MapReduce. So how MapReduce works, how the program runs, these basic concepts, if you can understand, that will help you to learn Spark in a better way. That is the reason we are learning Spark, MapReduce actually. In the enterprise, totally gone. There is nothing called MapReduce. And so always you cannot say that Hadoop is 100% replacement of data warehouse. Okay, it can work as a data warehouse, but performance considerations are there. So sometimes you might need some reports within milliseconds, second, 2 seconds, which probably Hadoop may not be able to do. Hadoop is a batch processing system. It's not real time. So if I have Teradata or what is that, Exadata, Netezza, these guys are really fast. So what companies do, they keep the hot data there. Probably my company has 100 terabyte data. In that, 2 terabyte data I need every day very fast. I'll keep it in Teradata. 98 terabyte, I'll dump it in Hadoop. I need it once in a while, and even if it takes some time, it is fine. Okay. Same story with the cloud. So most of the organizations are now deploying everything over Amazon Web Services. So Amazon offers fully managed Hadoop solutions on the cloud. Like you can go to Amazon, ask it, give me a Hadoop cluster. In 10 minutes, you will have fully functional Hadoop solution. Everything installed, up and running, servers, everything. Automation, right? So there they also give you data warehouses. They have something called, there is a solution called Redshift. Redshift is an online cloud-based data warehouse. So Amazon offers Redshift to you if you want hot data to be stored. So like I said, everything cannot be given in one solution. You need cheaper, you need the same speed, everything you have to package in one solution. It may not be possible, right? So like someone was suggesting, right? You can compromise speed either, right? Or real-time access, right? So same like that. So Hadoop is a solution most of the people adopt, but not everything can be guaranteed at the same time. That takes us to the question, what is Hadoop and why this is so popular, or what is the architecture of Hadoop? It's fairly easy to understand actually, because the idea is very simple. I have a single machine. How much amount of data can I store in a single machine? Motherboard, right? Motherboard is who decides. So the motherboard will say, I'll support 10 hard disks, you can have 10 hard disks. So the idea is very simple. So people initially thought, I can use one machine. And when that machine was not sufficient, what they did? External storage, NAS and all, right? Network storage. Probably you guys are not much from storage background. There was something called network attached storage, very, very popular. Have you heard about EMC and all? Company called EMC Square? They survived only because of these things. So you have something called network attached storage, NAS box. You can buy a box, install the box anywhere, and you can dump the data there. So the system can dump and process from there. That is called NAS. So that will support more storage actually, but it is not within the machine. When NAS was not enough, came SAN, storage area network. SANs are even popular these days, okay? So a full room full of hard disk, you get a fiber channel connection. So if I can dump all the hard disk there, I can store as much as I want. But the problem is, even if I'm using a SAN, this gives me unlimited storage, okay? Problem is, it gives me only storage, no processing. If I want to process the data, can one server process all the data in a SAN? No, not possible, right? Distributed computing is not a new idea. It was already there, okay? So in Hadoop, what we are doing is very, very simple. Rather than one machine, you take a bunch of machines, okay? So I will say the bunch is, just for sake of argument, 4, okay? So I take 4 machines. 1, 2, 3, 4. So I take a bunch of boxes, say 4 boxes, 4 servers, right? And I can download and install this Cloudera or Hortonworks, any of their Hadoop on this. While installing, it will ask me which machine is master, which machine is slave. The idea is one machine has to be master, the rest of them can be slaves. So in this architecture, I come up with an idea, one guy is master and 3 guys are slaves. Fine. So we have not discussed what is the master doing, what is the slave doing, that's later, okay? But you install Hadoop in a setup that when there is one master and let's say 3 slaves, right? Now the idea here is that if I want to store anything, okay, Hadoop will help me to store among these 3 boxes, right? So I can use the storage space of all 3 boxes. So if each of them are having a 2 terabyte hard disk, I will get a total capacity of 6 terabyte. Yeah, so Hadoop is a framework actually. It is not a software. So one confusion people have is that is Hadoop a software? No, it is a platform. Okay, and I will show you the different components we have in the Hadoop platform. So if you install Hadoop, let's say we don't know anything about Hadoop, but let's say we install it in a 4 system setup. While installing, it will ask you to select one as master, the remaining as slave. So I have 1 master and 3 slaves, right? And what Hadoop can do, it can take the storage space of all these 3 machines and project it as a single 6 terabyte storage box, right? So the beauty of this architecture is that let's say you start dumping the data and the data gets stored here. And let's say your 6 terabyte is over. I can add machines on the fly. From 3, I can expand to 30,000 without shutting down the cluster. Meaning your storage problem is solved. You don't have to ever worry about storage in a Hadoop cluster. Hadoop allows you resizing without any downtime. So I can add more machines or I can remove machines, up to me to decide, right? But if you're removing, it'll have a problem. For example, if the program is running here, if I remove it, the program might crash because this machine is needed. That is not the idea. If you have one more machine here where nothing is running, I can remove it gracefully. Nothing will happen. So you are getting something called scaling out. This architecture is called scaling out, meaning you keep on adding more machines so that you can get unlimited scalability. Now I will tell you how storage happens. So far I did not discuss how storage happens. And if one machine is taking that, it will have more data, another will have less data. I don't have any way to manage it. Here, that will be handled. I'll show you how that is happening. So this is called a Hadoop cluster. So the technical term for this is a cluster. Cluster is nothing but a group of machines, right? So that is available in a Hadoop cluster. Now, typically, if you go to companies and check with them, like I was with this 24/7, a company called 24/7. They are a call center company. And they run Hadoop clusters for analytics and all. They had a 50 machine cluster, 50 node cluster. Each node has around 256 GB RAM and 10 terabyte storage. So 50 into 10 is what? Sorry, not 10. What am I saying? 100 terabyte storage. So 50 into 100 is what? 5 petabyte of storage they had. And 256 times 50, that is the RAM capacity of the cluster. That is a very minimal Hadoop cluster, cheap Hadoop cluster. So typically you'll have 500 nodes, 1000 nodes Hadoop clusters. Because the amount of data you're storing is in petabytes. 1000 terabyte is 1 petabyte actually. So most of the companies, they'll have huge amount of data to dump in this. So the size of the cluster will be in that level actually. And Hadoop is distributed, meaning if you install it, it is not getting installed in one machine, it is installed in all the machines, and the components will talk, so it runs in a cluster, not in a single machine or 2 machines actually, right? So the basic idea in storage is that you can add more machines and get more storage, right? Now, my point is, if let's say you're buying 500 servers, each server will cost you some money, right? So if I say 500 times that money, right, it is really a huge amount of investment for me. That is the reason we call these machines commodity hardware. What do you mean by commodity hardware? Commodity hardware means any machine without any label. You will never buy a Dell server to build a Hadoop cluster. You will build it with cheap throwaway servers. If you look at most of the buses that are here, what is your idea? Citizens need to travel from one point to another point, and the bus should be there. That's all. You are not investing crores in buying Volvo buses everywhere, right? You buy just some bus. Same idea here. In a Hadoop cluster, typical Hadoop cluster, the machines that we use are called commodity hardware. Commodity hardware means assembled servers. So you can get it actually. So you're not actually buying an IBM server, because I was also working as a design architect for one of the Hadoop solution. There we got servers for around 35,000 rupees, 40,000 rupees. 40,000 rupees you cannot buy a server. If it is an IBM server, you'll pay 2 lakh, 3 lakh. So this was like somebody will assemble and give you. The only thing it will work, it will crash also. It will definitely crash, 100%. So then you will be thinking, if I'm having a 500 node Hadoop cluster, if my slaves are crashing, what is the reliability there? I will answer that question. Just park the question for the time being. Server is what? A server is, so this is your desktop, normal desktops, right? So normally you have something called desktop at home and all. Server is something which can serve multiple clients in one way. It is a bigger box with bigger storage and processing. So if I want to buy a server, I have multiple options. One is that I go and tell IBM or Dell, buy me a server. So they will give me a branded server. So they will charge a lot of money. They will also give me support and all, but I have to pay 2 lakh, 3 lakh for a server. So normally when I say server, this is what people buy. But in a Hadoop cluster, you never do that. You buy cheapest servers possible, because you can afford to have failures in a Hadoop cluster. I'll show you how failures will be handled in Hadoop cluster, but you are not investing a lot of money on the hardware. That is the idea. Because otherwise the solution is not feasible. If I'm buying 500 IBM servers, I can take the same money and give it to Teradata. So as good as same thing, right? So I don't need support or anything. I just need some normal machines. And Hadoop also does not say what kind of a machine you need. You can even build a Hadoop cluster using desktops if you want. Performance will be less, but it will beautifully work. Or laptops or anything that you want. It doesn't say that. So new businesses might take Hadoop more, because after 5 years, I may not buy Teradata, right? If this is a situation, I might buy a Hadoop solution probably. Data warehousing is not a new concept. If I go to the market, I can get n number of people who know what is data warehousing, and they can easily install a Teradata for me. I just have to pay money. Building a team of Hadoop expertise is not easy. That is why you're sitting here, right? I go to a company also, if all of them have to understand how Hadoop is working, and Hadoop is not like click, install. There are a lot of things you have to configure and tune. So people don't want to spend that much of a risk. So one reason is that the knowledge curve, we call, right? The learning curve is a bit high. You can't learn it in a day and say that, okay, I'll implement Hadoop. It's not possible, right? So most of the companies are stuck in this position. Now what you need to understand, so since we were looking at the high level definitions only, Hadoop has 3 major components. There is something called HDFS, there is something called yarn, third is called MapReduce. So when you download and install Hadoop, only Hadoop, these 3 things will come by default. HDFS, yarn and MapReduce. These 3 components will be installed by default, and you don't have to do anything. They will get installed, right? In this guy is the storage. This guy is handling storage, okay? This guy is resource management. This is the resource manager. This is processing. HDFS stands for Hadoop Distributed File System. It's a file system actually. It is called Hadoop Distributed File System. I'll write it here probably. Hadoop Distributed File System. That is HDFS. First, let's look at this guy called HDFS. So let's take a hypothetical situation where you have installed Hadoop in one master, okay? And in my example, we have 6 slave machines. Now this picture will pose a lot of questions usually, okay? And that's okay. So there is one master and 6 slave machines. And we are talking only about storage, no processing. The master will have a process called name node. The master machine will be running a process called a name node. When you install, it will start running this process called name node, okay? The slaves will be running a process called data node. Data node. So I'll call it as data node 1, 2, 3, 4, 5 and 6. So technically we will say that there is 1 name node and 6 data nodes. I mean, that is how you say in a Hadoop cluster, right? So name node is the storage master and data node is the storage slave. The next thing is that let's say you want to store a file in a Hadoop cluster. Hadoop does not care what you're storing. Meaning you can store any format. Can be XML, JSON, images, video. Hadoop doesn't really care what format of data you are storing. While processing, you have to make sense of the data. So that is in MapReduce. If I stored a text file, I have to write it in MapReduce that read this text file and do whatever I want to do. The HDFS file system does not really bother about what type of data you are storing. Second point, and probably the most important point, is that once you store any file, you cannot edit it. Modifications are not possible. You store it, delete it, that's it. In HDFS, modification is impossible. So why, you may be asking why it is not possible? Because HDFS is designed as a file system for handling huge amount of data, terabytes and petabytes amount of data, right? And if I want to modify or edit, row by row, like in a transaction that is happening, it is not possible, because if you look at a hard disk, right, there is something called seek time. If a hard disk want to fetch a record, there is something called seek time, right? And if I'm having 1 terabyte file, I want to edit the 100th line, it's not possible for my hard disk to seek and get the data in that. Because you're using all commodity machines here. They are not even faster. I'm not using solid state drives or anything. Very commodity level hardware I'm using here. So Hadoop's idea is that you want to read files sequentially. There is no random access. There is only sequential access. So if I store a file, I can read the entire file and process it. I cannot say needle in a haystack problem. Needle in a haystack problem, meaning if you have a 1 million row table, you cannot say take the 100th line and edit. Not possible in Hadoop, at least in Hadoop. It is impossible. So either you can read the whole data and process it, that's all you can do. And the result can be stored, obviously. If you process the data, you get some result that can be stored. But on the file system, editing is not possible. That is, appending is possible. Appending is always possible. I have a file, I want to append the data, that's okay, because you are just adding in the end. But I'm just reading the 100th row and edit, that is not possible. Now you may be wondering, what if I want to do it? There is a solution. You can do it. You have MPP engines on top of Hadoop which can do it. I'll show you how to do it. I mean, it is possible, but considering only HDFS, ideally if you're storing a file and you got some modifications in the file, you delete it and restore the file, meaning you don't edit it actually, right? You can delete the whole file. Delete is possible. I'm saying that minute edits are not possible because Hadoop is considered to be a system where you are doing analysis of the data. It is not transactional system. Where will your minute edits and all come? OLTP systems. If I'm having an RDBMS, I want to do insert, update. It's not an RDBMS, right? If you're an RDBMS world, it is possible. I don't have any objection. But here it is not possible by default. And also, we are not doing any transactional, it's not a real-time transactional DB, right? So I don't want to minutely edit also. But worst case, if I want to do it, it is possible. So we have MPP engines on Hadoop which can do it actually. So if I'm storing a 1 TB file, if I want to process the file, probably I want to process only the 100th line. I have to load the 1 TB into RAM. If I'm writing a group by query or an aggregate query, right? Probably I need the whole data. I have a very big table. I'm writing an aggregate query, right? Which will say group by and order and something like that. It makes sense I load the full file because I don't know where is the data. Whole data need to be scanned probably. But if I'm doing a select something where name equal to something, name equal to Raghuraman, only one line need to be processed. For processing only one line, why should I load the whole data? So this is where customers are placing their order. And this data you don't want to change. This data was created by customer. I just want to get the data, right? Probably I want to modify and get it. So once it is here, I don't want to make any changes. I just want to analyze the data. No, I'll tell you what is the role. What is going to happen? Let's say that you want to store. So the file size is 192 megabytes. You want to store it in a Hadoop cluster. Now, there are a lot of things which actually matters to your real-time experience. Here we are just learning the basics because in a real company, if you want to connect with a Hadoop cluster, the Hadoop cluster will be somewhere else. So if you're sitting here, the Hadoop cluster will be separate, you will be separate, right? So you will get something called a Hadoop client package. Okay, so one way is that you get something called a Hadoop client. Using that, you can access from your laptop. Second is that you can log into a node. There is something called a gateway machine. This is called gateway machine. So if I am sitting here, this is me, very nice, right? So I can just connect to this machine. From this machine, I can connect to the Hadoop cluster. You don't directly get inside the Hadoop cluster. That's my point. For security reasons and many other reasons. So companies do two things. Either they will install something called a Hadoop client. Even that is very rare. What we used to do, there will be a Linux machine called gateway node. You will get a username and password. You type it, you connect to this machine. This machine will already know how to reach here. You don't have to worry. You issue the commands here, it will run here. But whatever way. So let's say you want to push this 192 MB file from your machine. You connect it to the gateway machine. You said, okay, upload the data. What is going to happen is that, first thing which is going to happen is that your name node machine, this is a master. This guy will tell you something called block size. There is something called block size. This block size can be configured for every Hadoop cluster. when you are installing Hadoop. So I am assuming that the block size for this cluster is 64 megabytes. So what is block size? Block size will tell you what is the maximum size of data that you can store. Meaning, if you are storing a 192 MB file, what will happen? It will divide that into 3 blocks. Same thing happens on your laptop. If you're storing a song on your laptop, what happens? Okay, you store a song, MP3 song, right, on your laptop. What do you think? The hard disk will actually take the song as it is? Or it will divide it? It will divide it. It will not store as it is. I think Linux uses 4 kilobyte of 4 KB block size. Linux. Windows also uses similar. Any file system will chop your data and store. Same thing happens in Hadoop also. So I am assuming that this Hadoop cluster has a block size of 64 MB. So this name node will get back to your client package and say that divide your file into 3 or whatever you want, because the block size is 64 MB. So what is going to happen? This file will get divided into 3 blocks. You don't have to do this. This will happen behind the scenes. Like, you don't have to say that what is your block size. It will happen automatically. This gateway has Hadoop client installed. That is what. So this Hadoop client on the gateway will already communicate with name node. Name node will say that, boss, in my cluster, the block size is 64 MB. You manage yourself. So the client will divide your data into blocks of 64, 64, 64. Total is 128. So now you have 3 blocks, B1, B2, and B3. You have 3 blocks now of the data, right? And then again you go back to the name node. You ask the name node, I have 3 blocks, okay, now tell me where to store. And the name node, what it does, it has communication with all the data nodes. It knows how much space is available. It will tell you that, do one thing, store the first block probably here, just an example. Store the second block probably here, B2. Store the third block here, B3. Most of the cases, the name node will give you different machines. It will never allow you to store everything in one machine. So you divide and distribute. That is how you're storing the data. So now your data is divided into 3 blocks and they are stored in 3 different data nodes. So this is like 6. In reality, you have 500 machines. So 3 blocks is easy, right? But sometimes a couple of blocks may end up in one machine also, depends on the storage. But ideally, it gets stored like this. Now you may be wondering why the block sizes. It's not random. It has, name node has an idea like how much storage space is available on each data node. So it will come up with the free machines. Okay, within that, it just picks randomly 3 of them and say that you dump it there. And I will tell you. So if you think logically, now if I want to process this data, okay, 3 machines can process this data, right? If I store all the 3 blocks on one machine has to process 3 blocks, right? That makes a difference, right? So ideally, you divide and distribute the data. Most of the cases. You don't have to do it. Name node will do it for you automatically. This is all inside a LAN. All these machines are communicating with each other. The data nodes all send a heartbeat to the name node saying that they are alive also, so that the name node can detect how many of them are alive or down or anything. I can't get my data. So by default in Hadoop, there is a replication of 3, which means each block gets replicated 3 times to other machines. I'll just draw this, then come to your questions. Give me a moment. B2, again B2, and I'm just drawing randomly. I mean, just taking that these are the machines. B3, probably from here. B3. So if you look at each block is replicated 3 times to different machines. So now let's say this machine crashes. This B2 is still available here and here. I can recover it from here. And now what happens is that the name node will store the metadata. Meaning the name node will write here, there is a file called abc.txt. It is divided into 3 blocks. Block 1 is available on where? 3. Where is it? 3, 2, 6. So B1, 3, 2, 6, B2 where? So the purpose of your name node is to actually store the metadata or the index. And if the name node crashes, you cannot access the cluster. That is for sure. Because if the name node is gone, then everything will be gone. To prevent that, in most of the Hadoop clusters, you will have an active name node and a standby name node. Meaning, there will be two name nodes. These two guys will be in constant communication. So if the active name node crashes, and the disaster recovery, to set up that, there is a company called Van Disco, Dance. Van Disco, very interesting company. So Van Disco is one of the popular companies who set up disaster recovery for Hadoop. But you don't do disaster recovery like in traditional systems. Meaning, if I have a 100 node Hadoop cluster, I won't set up a 100 node backup cluster, right? That is waste of money. Very rare King Jong will fire a missile, right? If he fires, God saves, right? So what I will do, even in the Hadoop cluster, you have to classify the data. You are storing 100 terabyte data. Probably not all 100 terabyte is so important, right? Is it? No, a lot of data is like archival and all. So in the 100 terabyte data, I will identify probably 10 terabyte, which is very critical. And I can periodically back up that data to my DR center. I don't set up a 100 node cluster in Noida to back up a cluster from here. So we use a tool called distributed copy, distcp in Hadoop that can synchronize these two clusters, primary backup. Distcp it's called, distributed copy. 100% Hadoop availability, right? See, this is what I'm talking about. We used Van Disco in one of our projects. That is why I know. Usually people do not be aware of these things. So I was working as a Hadoop administrator also for some time. That is why I know this, because these are all like real-time things. Okay, it is configurable. They use 64 also. There is a parameter I'll show you where you can change block size. Okay, Hadoop, the default block size is 128 MB. You should also know, also understand one more thing. There are three major releases of Hadoop. Hadoop 1, 2, 3. Hadoop 1 is the older release. And nobody is using it these days. So you don't have to worry about Hadoop 1. It is not available in production right now. 2013 was the last year when this was used. So no longer used. Hadoop 2 is what you are using, I am using, we are using. This is the current edition. Hadoop 3 released in 2017, December 15, like 3 months back. Okay. Now let me ask you a question. If you are storing 100 terabyte data in a Hadoop cluster, how much storage you need? So there are multiple approaches. One thing is that some companies, this replication factor can be changed, by the way. It's not hard-coded. Some companies say 2, right? So you get 2 copy of data. Also, while copying the data, you can mention the replication factor. Very interesting thing. I am copying a file, 1 TB file. This file I can afford to lose. I can say copy with replication 1. But it had led into a debate in the Hadoop world. So a lot of people said that this is very bad actually, because 3 times replication means you are losing a lot of space. That is why in Hadoop 3 there is no replication. And there are only limited types. You can read text, XML, sequence file, key value. So some limited number of types of files are there. And how do you, so this is a very good question. How do you handle unstructured data? It is also a very confusing concept. Many people believe that in the world of big data, you are always playing with videos and images. Actually, no. See, many people believe every day you'll go to office and run some facial recognition like you see in the Mission Impossible movie. And yes, I got big data. No, you don't do that actually. You can analyze images and videos. There is no doubt. It's very difficult actually to do. Analyzing video and image data is very difficult because you can't directly analyze it. You have to convert it into binary. Once it becomes binary, in Hadoop you have a format called sequence file. You have to read it as sequence file and write a program to analyze it. It's actually a very difficult job to analyze these kind of files, and not everybody need to analyze it. Let me give you a real-time example. I was working with 24/7, right? The customer care company. What is their primary business? Customer care. In customer care, people call, right? Do you think they will listen to what customer is calling? You are giving support to other companies, and you are running a call center. In a call center, customers will call, right? Do you actually listen to what they are talking? Let's say take IDEA for example. How many calls IDEA will be getting in customer care? Do you really think they analyze your calls? For example, if You were an angry customer. You spoke for 1 hour. That call is recorded. The person who took the call will go to the manager. And the next meeting, manager will analyze that call and say that this was your mistakes. I am saying, do you actually analyze big data analytics on these kind of things? Not really. You will analyze the metadata, not the actual data. How many people called? What was the duration? What they pressed? This is the data, not the actual audio data. Because you can do it. I'm not saying it is impossible. But then you have to, so how do you understand what he is speaking? And it may fail, it may not fail. You are not 100% sure. If it is a US customer or something, we can approximately match. If it's an Indian customer, how do you identify all this? It's not possible, right? He may speak any language, any accent, right? So practically these things are not possible. I'm saying you can analyze unstructured data. There is no doubt about it. And companies like Facebook and all do. Facebook actually analyze video data. They have to, for some reasons that they have to do, right? And there they have written complicated algorithms to read and convert to binary and all. But if you are going to work in a regular project, you will all see structured data, CSV files, JSON data, normal text data. But if you are storing also, so you need a class to read this type of files. That's what the question was, right? We have a tool called Oozie, Apache Oozie. Oozie is a tool, actually, that comes along with Hadoop when you install as a tool. So in Oozie, you will be scheduling your program. You wrote a Spark program, analyze 100 TB data. If you immediately submit the program, probably the program will not work because already somebody is analyzing the data. Where do you have space to fit all these things, right? So what you do, you write it in Oozie and you contact your Hadoop admin, say that I want to analyze 100 TB data. When can I run this? He will say tomorrow 11 o'clock. Most of this analysis is batch, not real time. Real time is a different case. But batch jobs, you schedule it via Oozie. Also, you have something called queue in Hadoop. For example, you are working as a developer. I'm a tester. Can we have same access in the cluster? Of course, testing cluster will be different. But let's say I'm a researcher. You are a developer. He is a data scientist. Can we have the same access on the Hadoop cluster? No. Probably you are a developer. You need more resources. Okay. Probably I need less resources. So what we do, we create something called queue. Okay. There is something called queue. We create. In those queue, we allocate resources. If you're coming from the developer team, you will get 30% of the resources. If you're coming from other team, you get 40%, right? Otherwise, I can utilize all the resource, right? If I write a program, I can make the cluster only for mine. That's not possible in a Hadoop cluster. So management is entirely different. How do you run these jobs are all different. But to just answer the question, why you are dividing is that you can use parallelism. Otherwise, a single machine has to process everything, right? Queue means multiple teams will be there. Each team can get a queue. So when you submit a program, you will submit to a queue. You will not directly submit to the cluster. Queuing in terms of resources. Say, for example, in your Hadoop cluster, have 10 data nodes. Each data node has, let's say, 10 GB RAM. So total, you have 100 GB RAM in the cluster, right? And let's say 10 data nodes, each has 4 core processor. So you get what? 40 core processor, right? Now, if somebody want, they can get all these resources in their program. If he is getting, nobody else can run a program in the cluster. Should not be like that. So what we do, we create 4 queues, let's say, or 2 queues. In this queue, I will say 60% of the resource should be there. Here I'll say 30% should be there. Here I'll say 10% should be there. So this will be the developer queue. They will give 60% of the resources. That means 60 GB RAM, 60%, right? 24 core processor. So they will never get more than 24. So multiple ways of scheduling is there. In the normal scheduling, they will get maximum 60% only. Or if the other queue is empty, they can claim the resources from there. There is something called capacity scheduler, fair scheduler and all. So this scheduler is called a queue. So if I'm creating something called fair scheduler, within fair scheduler, it will allow me to create queues. So I can say create 3 queues. And whenever somebody is submitting a program, they have to mention the queue name also. Otherwise, the program will not run. So when you submit to a queue, inside the queue, you can write a policy. The default policy is FIFO, first in, first out, right? Apart from FIFO, you can also have priorities and other things. You can write your own policy about it. So here it is text file or flat file. Any file you can select. So by default, like I said, if you're storing something on HDFS, HDFS does not care what is your format. You store an image, it will store as image, JPG. You have to make sense of it while reading the data. It is not like RDBMS. So that is one thing. It is not like RDBMS at all because HDFS is a file system. So if you dump Say for example, on my Windows machine, can I store an MP3 file? Can I open in Notepad? I can store an MP3 file in Hadoop. If I want to process, I should write a logic to process it actually. That is for only queries. MapReduce is not query. MapReduce is programming language. Queries, you are talking about Hive. So Hive is your data warehouse on Hadoop. Hive will accept normal SQL queries, whatever SQL. Indexing will really work well if your data can be managed by the RDBMS system or the data warehousing system. If I'm indexing the data in Hive, the data is actually managed by HDFS, right? So I can get some performance improvements, but not like in your RDBMS. Never compare Hadoop with RDBMS. You can, at the most, you can compare with a data warehouse because it is not transactional, right? It's equal to a data warehouse, I can say. See, this is a big data platform. So you dump terabytes of file. You are not creating a record. Very rarely you edit. That's what I'm saying. This needle in a haystack problem, right? So very rarely you say that I want to create a new record. You will be adding files, continuous streams that will be huge in size. You can afford to lose. You can afford to lose the data. I will talk more about that in the ecosystem side. So I will just talk about something called Hadoop Ecosystem, and then we will discuss further. These are all, so the Hadoop is actually written in Java. So client is also in Java. Everything is a Java method actually. So you are just invoking a Java object. There is a fs read object which you call, and this object will get all this metadata and give it to the client. And the client will keep it in memory and then go and read one by one from wherever it wants. So I'll show you a Cloudera cluster. In the cluster we are using for the lab, we have only read-only access from the admin side, which means you cannot change the replication factor or block size or anything. These are all done by admins. We can upload the data and then say that run the program, that will work. But that we will do tomorrow. But let's look at the cluster, right? So far we are talking cluster, and we are not seeing any cluster so far. So I think Cloudera, Hortonworks, and Mapr, these three are getting used actually. All the three companies are sort of famous, I can say. So do you have this in your LMS, like your lab and all? So because some of the things are a bit confusing, so I have to tell you, we have to use Web Console. Web Console will connect with the Linux file system where Hadoop is installed. We will do that later. Cloudera Manager is the admin interface of the cluster. So I will connect with it, but we will not be able to modify, but we can see stuff. So if I go to Cloudera to administer the cluster, like you want to add a service, remove a service, add a machine, remove a machine. So the administrator, if you are a Hadoop administrator, you have to do all these things, add users, remove users, permissions, everything can be done by Cloudera Manager. And why I did not speak about this, because we will not be doing anything using this. It's an admin utility. But to look at the cluster, this guy is good. So let me show you that. Now you have to install it. So if I am running in a company, I have to purchase, let's say 20 machines physically. Yeah. And then I have to, there is a process of installing Hadoop. This cluster already has installed. It is a running cluster. If you're creating from scratch, you have to purchase, let's say 20 machines and download something called Cloudera Manager and run it. And it will help you to set up the cluster. It will tell that which is your master, which is your slave, what is your block size, what is your, you will have access to this, right? I mean, if you want to practice, this setup is already available to you, right? So this is your Cloudera cluster, okay? This is just an admin GUI, okay, to the cluster. And once you log in, this is your dashboard. So you are looking at a Hadoop cluster. First point you have to understand. Second point, what is there in the Hadoop cluster? These are all the services installed. See, HDFS, okay, HDFS, Hive, Hue, I will talk about it, Impala, Kafka, Oozie, Solar, Spark, Yarn, Zookeeper, all these services are running in the cluster. You see a green, right? This is just to get a quick overview of the cluster, like what is running in the cluster. Fine. How many machines are there in the cluster? You click on this host menu. Can you see? Can you see these machines? These are all machines, 111, right? So how many machines are there? I think there are 9 machines. See, good health, 9. 9 machines are there in the cluster. And you can also see their configuration. If I scroll here, can you see their RAM and hard disk? What is the physical memory? That is the RAM. The first 4 machines are 8 GB RAM. Next one is 16 GB RAM. These are their hard disk. Can you see? And you can see how much storage is full and all, everything, right? See here. So this guy is having 32 GB RAM and 18.8 is currently used. Some process will be running. This guy also had a 249 GB hard disk, 600 GB hard disk, 50 GB hard disk. You can all see from a single window. It's very easy. So it is not as complicated as you thought, by the way, right? So this is just the host menu. Now, if you look at HDFS, this is HDFS. Click on HDFS, okay? You will see this HDFS menu. This is all related to HDFS. In HDFS, what we learned, replication, block size. So where do you configure this? There is something called configuration. And do you want to change the, see, it is saying read only. I cannot change it. But do you want to see the replication factor of this cluster? DFS dot, what is the replication factor? 3. Click there, you can change it to 2 or 10 or whatever you want. If you are an admin, you are not an admin. Do you want to see the block size? DFS dot block size. So I can click here and change if I'm a Hadoop admin, and it will be applicable to everybody immediately and all. Somebody was asking about balancer, right? Where is balancer? I can say actions. Okay. The problem is that some of these things I will not be able to run. This is balancer where it is running, but I can run a command. It's not green. It is not running. If it is running, this process will come as green actually. Then chart commands, configuration. So there is a lot of configuration. Okay, so that is one thing we saw, and host menu we saw already, right? So far we discussed only HDFS, and here is Kafka. If I go to Kafka, just go to Kafka, okay? Kafka says Kafka broker 3. That means 3 machines are running Kafka. I told you Kafka will be running in a cluster. Since this is a lab setup, we are running Kafka inside Hadoop only. Ideally, we run it separately because it needs storage spaces to hold your data. But here Kafka brokers are 3. We are running inside here only because this is only a cluster we have. I mean, these machines, if I go to these machines, I will show you. If you go to this host menu, you can expand a host and see what it is doing. For example, if I expand this guy, and also I can go to HDFS and see that. For example, I go to HDFS and instances. What do you see here? Active standby, 2 machines, 2 name nodes. I told you, right? Active and standby, they are running, right? So the same machines are running Kafka here. It's not a separate cluster, by the way. That's what I meant by that. I don't have really admin access. Otherwise, something could have been done. I don't want to mess up the cluster also, by the way. So some of the menus are actually disabled. We can't run them. Ideally, that should not be the case because then it is not utilizing the proper space, right? So ideally, you will set up a separate broker and that will download the data actually. They are all running on AWS. I want to clarify one more thing. If you go to this Big Data Cloud Lab, this Cloudera Manager you don't really need because that's the admin interface. You are not going to do any admin activity. The important thing that you need is Web Console. So if you click on Web Console, I just clicked on that, and there is a product called Hue. This is very important. There is a product called Hue. This Hue is a third-party application, okay? But it is very, very popular. Why do you need Hue? Is that if you are a developer and you want to upload your files to Hadoop, you can use Hue, one of the use cases. For example, I can click this. I'll click Hue, and last the username and password. If I sign in, okay, I'll just sign in. If I click on this HDFS browser, see there, this is my Hadoop. These are all the files in my Hadoop. So Hue is like a web UI to your Hadoop, HDFS file system. So these are all the files and folders. If you connect, you will not see anything here because you are having a fresh account. One more very important point I want to tell you is that in Hadoop, you will have a home directory, user/something. I have GL faculty. You will have your own directory. Can you try this Hue thing on your PC? Just click on this Hue, type username, password, see whether you can see this thing. Another point is that sometimes the cluster will become very slow because it is not designed to accept requests from 36 people, right? If all of us try to log in, it will say timed out and other things. So different users are created in the Hadoop cluster. So if you log in, you will get a home directory, like in Linux. In Linux, what happens if you log on, you will get a home directory. So this is my home directory in HDFS. And since I already created some files, I can see them. You may not be able to see because it is a fresh home directory for you. No, it will be in a non-commodity hardware, like a real server. You know what is a rack? Server rack. Because from the point of view of Hadoop, this might be important. I will explain this one and then pick up your questions. images.google.com. So this is for people who do not know, server rack. Do you know what is a rack now? This is a rack. It's a housing where you push all the servers. In all the hi-fi movies, you will say somebody sitting something, typing something in a very big data center and all, right? So that's a rack. Why racks are important? They are important for one reason, because let's say you have 3 racks. You are having 3 racks, okay? And each rack has a data node. Not one, there are many. So let's say 2 data nodes are there. So in reality, when you are installing Hadoop in a cluster, this is how you do, right? Because in a data center, you will have racks and you will have servers. These servers are called your data nodes, right? So I have 6 data nodes in 3 racks. Now there is something called rack awareness in Hadoop, meaning if let's say you are copying a block, what you can do, this first copy will go here, the second copy will go here, imagine, and the third copy will go here. Meaning, if you enable this feature called rack awareness, Hadoop will ensure that the blocks are spread across multiple racks. Why? A rack is a point of failure, because normally you will supply this power and network, everything through rack. So if a rack fails, if I'm keeping all the 3 blocks in the same rack, if that rack fails, then my blocks are gone. So Hadoop can, if you enable rack awareness, you have to tell Hadoop which data node is in which rack. If you do that, it can place them like this. But why don't it keep like all 3 in 3 different racks? Why the rest of the 2 copies are in the same rack? Yeah, but same location means these are all in the same data center, right? So this inter-rack bandwidth is very important. Rack to rack, the bandwidth is very important. So this is just replication, right? You will be running a lot of programs which will use this bandwidth. So to save that bandwidth, what it does is that the next replication will happen within the rack, server to server. But this is enough. Now, even if one rack and all the 3 racks going down is very remote possibility, right? And my point was, I can show you that here. So when I saw that, if you go to all host, can you see this? So in the rack 1, 4 are there, rack 2, 2 are there, rack 3, 2 are there, and default rack 2 are there. Default means, I don't know, they have kept something here, but 4, 2, 2. So this is actually the distribution. It is actually available in your Cloudera manager. See, if you look at this picture, right? In this machine, some 30 data nodes will be there. Each slot you'll have 1 server. They are all rack server. So server is not like this, it is like this. So the biggest Hadoop cluster on earth is with Yahoo, actually. Yahoo holds a record for that. They have 42,000 machines. And still they went bankrupt, sold it to some useless company. No, that's a good question. So can I have multiple name nodes? Yes. The concept is called federation. Meaning, ideally, if you cross more than 5,000 data nodes, you need 1 more name node. Like 42,000 machines, I cannot have a single name node to handle because the amount of metadata will become slow. That is a problem. So ideally, Yahoo has done some R&D. They said that if you cross more than 5,000 data nodes, you need 1 more data node. That's called name node. That's called federation. Federation means multiple active name nodes. Like you can have 10 name nodes, all will be working. They'll share the load actually, right? So like that, federation is called it. All in 1 rack actually you can put it. Inside the same data center only you need all of them, right? Because all the data nodes are in 1 LAN. So the name node also should be inside that only. But they will handle the load actually. So some data nodes will be not to this name node and all. They can handle the load. File server can store, but it cannot process, right? That's the use case. Hadoop is not only for storing. Whatever data you store, the data can be processed then and there by the machine. So there we are not using Hadoop, right? We discussed it in the beginning of the class, NoSQL databases. If you don't want processing, if your use case is such that I just want to dump a bunch of images, let's say 1 million images, I just want to process and display in an e-commerce website, I don't use Hadoop. Hadoop is not used for that. There you have NoSQL databases like DynamoDB or MongoDB, right? SharePoint. If it is a smaller setup, SharePoint you can use. So it is all business use case. The question is that what do I want to do with the data? There are other companies who generate terabytes of data, they just archive the data. I just generate data, I don't want to analyze, I just archive the data, who cares? So it is up to me to decide what should I do with the data, right? I was working with GE, very interesting use case. GE, right? The company called GE. I have a training next week there. So they have an aviation department. GE is building this aircraft engine, you know that? Flight engine. 80% of the commercial aircraft engines are from GE. And what they do, so most of the planes are flying with GE engine. There is also Rolls-Royce and one more company. So all these aircraft engines are having sensors. So when the flight is flying, they capture the sensor data like pressure and blah, blah, blah. And they analyze it to predict when the flight will crash or turbulence will hit or something like that, whether you're going to die or something. So the idea is that, so I said, okay, good deal, you're doing this. They said, no, it's not a good deal. The problem is if a flight is flying from, let's say, Dubai to Bangalore, there will be 2 engines. It takes 6 hours. Each engine will generate 1 TB data. How many flights are there in total and how many flights fly every day? Can you imagine the amount of data? They don't analyze. How can you analyze? I mean, if I'm giving you, let's say, 1000 terabyte every hour or every minute, you can't analyze it. So they take a subset of it. They have an algorithm which takes a subset of the data and analyze. Rest they delete and dump because it is not humanly possible. Also, you don't need that much amount. Every sensor data need not be analyzed. This is very interesting because they also have locomotive engines, train. All the Europe and US, they run trains. And these trains are having sensors. So they get also that. It's very difficult to work with GE because huge amount of data, they also don't know what to do with the data, right? And they have no clue how to make sense of the data. Locomotive data is huge actually. So the trains will generate a lot of data actually. So they get it and then they take it and clean it and just get only a part of the data and they analyze it. In Hadoop, you also have certain file formats. For example, Avro. You may not have heard about it. Avro is a file format we use only in Hadoop. Parquet, ORC. These are all used to compress and store your data in Hadoop. You can also have compression techniques because sometimes storing the data as it is not good. Why don't you compress it? But what is the drawback of compression? You have to decompress. You need a lot of processing power if you want to decompress it. So Avro is a serialization format. It doesn't compress the data. Parquet and all will compress the data columnly and push the data. So I will show you in Hive when we discuss Hive. When you create a Hive table, you can say that the data has to be compressed. It will compress and store the data. So my point is not everybody want to analyze all the data in the world. That is also humanly not. Think about Facebook, how much data they'll be getting. Probably they are not analyzing the whole data, a subset of interesting data. That is all they will be doing. Yes, Spark is memory intensive. Ideally, Spark requires RAM. So if you give RAM, it will perform better. If you don't give RAM, it will use hard disk. I mean, rest of the space will use hard disk. Performance will be slightly degraded. So for streaming and all, we need a lot of RAM. The problem is, Football World Cup is going to happen, right? So let's say you want to write a program which will download all the tweets and find out the most favorite player for Football World Cup. Possible, right? So I can easily stream the data from Twitter. The problem is, I want to find out, the most popular player every 5 minutes. Imagine. Probably not 5 minutes you want to do. So I want to get 5 minutes worth data, hold it in my memory and process. What if 5 minute data is so huge I cannot hold it in memory? Then it will be slow. Yes, I'm just giving an imaginary situation where if 5 minutes worth data is in terabytes, you can't hold it actually. Not only Twitter, any data that you have. then you might want to persist into disk some of the data. Then processing will become slow. It is not real time then. So when you are running Spark streaming and all, your RAM should be available. Otherwise, it will become very slow. Today's match you will predict tomorrow, right? So things like that can happen. So that's not really good actually. So a lot of considerations are there where you have to use all this. They don't use, if it is a bare metal virtual machine, you can guarantee, there are two types of VMs, right? There's something called bare metal like a Hyper-V and all. There you can get good performance, or VMware. If it is not a bare metal, no, performance will be compromised, because again you have to go through one layer, then talk to the storage and all. So I'm just taking this ICICI use case so you guys will understand better. So traditionally we do something called ETL to bring the data, right? And now what we have this Hadoop. So I'm just writing here HDFS. So this is your HDFS file system. This is HDFS. And in the world of Hadoop, we very rarely do ETL. Why? Because ETL means you are reading the data, transforming the data, and dumping the data. If you are getting big data, transforming it on the fly is very, very difficult actually. So in the world of Hadoop, what we do is something called ELT. Instead of ETL, you will do something called ELT. That is extract, load, and transform. So first thing is extraction. How do you get the data into a Hadoop system? So there are multiple tools. First of all, if you are having structured data, say you have data in Oracle, you have data in MySQL. So this is all structured data which understands SQL. There is a tool called Scoop. There is a tool called Scoop. Scoop can get this data to your HDFS. You can't call it as an ETL tool. Scoop is used to bring the data from any SQL system to Hadoop, transfer the data. So what is going to happen when you say that you want Hadoop from Cloudera? Cloudera will give you Hadoop. On top of that, it will give you all these tools which I'll be explaining now. So Scoop is part of your Hadoop ecosystem. And Scoop is used to bring data from SQL stores. It can take from, let's say, Oracle. It can take from MySQL. But it cannot take from flat file, JSON, nothing. Only SQL, only places where SQL understood. So from ICICI use case, we got all the data from CRM through Scoop to Hadoop. Okay, so Scoop is an Apache tool. It is a very lightweight tool. We faced a problem there. I wanted to discuss that. Let me ask you this question. This is ICICI Bank's core banking Oracle database. Do you really think they will allow you to touch it? Then how do you get the data? CDC, change data capture. So we face the same problem. There is Golden Gate. Oracle has a solution called Golden Gate. So CDC, change data capture, meaning they will not allow you to touch it, right? So they will have some replica solution. So where they will write it into a replica DB, it's actually a log file. From there you have to capture and get it. They won't allow you to directly touch their Oracle DB by any way. It's called CDC, change data capture. No, that will have only the delta. So what they will do, they will give you the original data, backup data they have. The CDC will capture only the changes in the database. Got it? And then you have to, from CDC, you can write a Java code and then get the updates dumped into here. That is how you get it. So Golden Gate is a product that Oracle uses for CDC. Anyway, we use Scoop to get from here and here, right? Now comes the place where we are having a lot of debate, actually. Okay. Now the real question is that, okay, I know how to get the data from here through Scoop, right? What about the other data, right? Now, if you want to get the other type of data, there are multiple ways you can get, okay? One of the most popular used tool is called Flume. Apache Flume. Flume is a point-to-point delivery tool. What Flume does, it takes the data from source, give to the destination. The source can be anywhere. And normally Flume is used for unstructured data. Say for example, in a folder, you're getting all the JSON data or XML data or flat files. I can create something called a Flume agent. And this guy will keep on polling that folder. Whenever there is a new data, this guy will read it and it will send it to HDFS. This is what Flume does. Now, the real interesting thing is that Flume can do two things. One thing is that it can simply read all this data. Let's say this is in a folder. Okay. It can simply read this data and say send it to Hadoop. This is fine. But ICICI Bank also had another requirement. So this is simply you're collecting the data and dumping into Hadoop. They don't want to do that. Okay. So they wanted, they had a requirement in which what used to happen was that this Flume was capturing some data. Okay. Some data was getting generated in the form of JSON here. So in the social media, if somebody is clicking on one of their products, they wanted to send an SMS. Real time. So this JSON data will keep on coming. You will keep on getting it. And Flume can directly dump into HDFS. But that is useless for me because I want to analyze the data whenever the data is getting generated. That is where this guy comes into picture, Kafka. So there is a difference between Flume and Kafka. Okay, you have to understand. Flume is like a point-to-point delivery. You give me the data, I will dump it there. That is all Flume does. It doesn't do anything. And Flume does not store the data anywhere. Meaning it will take the data, temporarily it may store and then immediately push the data. So Kafka is your message queue in the big data world. Meaning what this guy will do, this guy will be running in its own cluster. No Hadoop cluster. This guy will run on its own cluster like 30 machine, 40 machine. This guy, Flume can send the data to this guy, Kafka. And Kafka is a cluster, so it can store the data. By default, it can store for 7 days. By default. Okay. Anybody can go to Kafka and get the data. Publish, subscribe system, we call it. The advantage is it will store the data so that multiple people can ask it. Flume is point to point. If Flume gets the data, it dumps the data here. So here what we used to do, we didn't do this. Okay. We got the data to Kafka. From Kafka, I can push it to HDFS one way. So I'm getting the original copy here. Okay. Now in ICICI Bank, so the next question is that how do you analyze data in real time? So somebody is clicking on Facebook, the data is coming as XML, right? And immediately when the data comes, Flume will read it, push it to Kafka. So now the data has reached till Kafka, but I want to analyze the data in real time. That is where your Spark comes into picture. There is something called Spark streaming. In Spark, you will learn this, I think, I'm not sure. Okay. There is something called Spark streaming. So Spark streaming is a utility which analyzes real-time data. Now, Kafka can also directly get this data. Now, this is a bit confusing, I know, okay, because this is very new to you, first of all. But Kafka can also directly get the XML file. But the advantage is that Flume is pull-based. Pull-based means if I install Flume, without disturbing this setup, I can pull the data. Kafka cannot pull the data. You have to install a tool here and modify the existing setup. Flume is pull-based, meaning if you install Flume here, it can start reading the data automatically. I don't have to modify anything. If I install Kafka directly, Kafka can also get the XML data. It can read the XML data, but I need something called a Kafka producer. That has to be installed here on the ICICI source system. That is not possible, right? So since it is an existing setup, I can't directly get through Kafka. I get through Flume. Flume will give to Kafka. Kafka will send one copy to HDFS because I need to keep the original data. Second copy it will send to something called Spark streaming. Spark streaming is a library available in Spark where it can do real-time processing. The moment you give the data, it will process it real-time. Somebody clicked on that, immediately the data is here. Spark streaming will process it and say send an SMS or you can take an action, whatever you want. Now, what are the other tools which can do real-time? Apart from Spark streaming, you have something called Flink. You have something called Storm. These are all real-time processing tools. You might have to make a note of that. Yeah. So in WhatsApp, it is push, right? Flume is like WhatsApp. Okay. Once Flume gets the data, it will push it to somewhere. It will not store the data. Kafka means it will get the data and store it for you as long as you consume it. So in ICICI Bank, this was the architecture. We got it through Flume, sent it to Kafka. Here, one copy will go to Spark streaming. So this guy will do real-time processing and do something. Okay. One copy will go to HDFS. So the data will remain in Kafka as long as you want. You can configure. By default, it is 7 days. You can also mention the size of the data. I want to keep only 10 GB data, 20 GB data. There is something called topics in Kafka, where you can mention how long the data should stay here. It's a cluster, right? Flume can send here, then this will not happen. It is point-to-point delivery. I need a copy here, I need to send there also at the same time. Also, probably tomorrow, I want to build one more application, okay, which will do something on this data. And that application, I have a new application I build tomorrow, that can also get the data from Kafka. Kafka is like, if you give data to Kafka, anybody can take it from you. I will store it for you. Got it? Flume is like point-to-point. Got it? Kafka will store it so that anybody can come and get the data. 10 applications can read from Kafka. It will be very slow, hardest to read. I can directly push in real time, right? So before you get out of Tanik's shop, I want to send an SMS, right? Now this will be one golden copy will go here. The original Facebook clicks and all golden copy will go here. That tomorrow you can analyze. Now you clicked on a page, insurance page in Facebook. I want to immediately contact you. So it has to be processed and understood, and then some decision has to be taken. So I'm sending one copy here, one copy here. Here the processing will happen. Here simply the original data will be stored. No. Flume and Kafka cannot. Only Scoop can read from SQL-based stores. Now, Kafka is a very interesting thing. I teach a 3-day course only for Kafka. ELK stack, right? No, ELK stack will not come here in this example. We didn't directly use ELK stack. We were using, that's what I was telling in the break to somebody. What we were doing is that we used to store the data in Hadoop. To process, we were using something called Splunk. There is a tool called Splunk. Splunk can actually replace your ELK stack. It does ELK both in one tool. So that is for visualization, right? You have some log files, machine learning. You can just apply and visualize. We were using something called Splunk. So this is the big pipeline I'm talking about. You can also build it using ELK if you want. I'm just saying. ELK is a stack actually. Elasticsearch, Logstash, Kibana. It's a probably he can explain, right? So let's say you're getting a lot of log files. You want to make sense out of it, right? From different places. Let's say I'm collecting all the logs from this network. I want to make sense out of it. So I need a tool which can easily collect it, clean it, and then display in a dashboard. That is ELK, what it is doing. There is a tool which is very similar. That's called Splunk. That is not in the in the Hadoop ecosystem. It is not there. That is a third-party tool actually. Exactly. So that's a good question. So when Scoop is getting the data, right? Scoop will ideally push only to here, HDFS. Okay. But I can say Scoop to push to Kafka also. That is also possible. Once the data is available in Scoop, okay, I can say give it to Kafka. So either it can be read for live processing, or Scoop can push to something called Hive. We have a Hive here, which is a data warehouse. From there, I can analyze in live if I want. But normally, this transactional data is not much used for real-time processing. You are doing it based on this Facebook clicks and all. Based on this transaction, I can get it. Now, just to answer his question, that's a good question actually. Can you give me a suggestion? So a customer is making a transaction. Using ICICI credit card. He made a transaction for 50,000. I have to immediately send him an offer. So if he's making a transaction here, I made a mistake here. I want to show that. If he made a transaction here, 50,000, okay, where will be the data? In Oracle. How do you capture the data from here? You will say Scoop. We were using Flume because your CDC will be producing a log file. The log will be captured by Flume, not Scoop. So here Scoop will not come into picture. Here Scoop will come because I'm directly reading from CRM. My CRM is in MySQL. MySQL is original table and I can read directly. But in the Oracle case, I was not directly reading the table. If I want to read a table, Scoop. But we were reading the CDC, change data capture. That was a log file. That was being collected by Flume actually. So you can actually make it. So this is the answer. If you want to make real time, okay, you need some CDC system which can push the data to Flume. I have worked on a banking use case where, so I'm talking about this side, Spark Streaming, Flink, Storm. So Spark Streaming is what you will be learning. Flink and Storm are other frameworks which can do real-time data processing. So you will be wondering why real-time data processing is so critical. All three are real-time. You may use any of them. Flink is Apache, Storm is also Apache. Storm is almost out of the market. Okay, Spark Streaming and Flink are popular right now. We have worked on a use case with Citibank. You swipe your credit card, right? How do you know it's a fraud or not? You are swiping your credit card. I want to find out whether it is a fraud transaction or a real transaction. You don't have to be a fraud. Let's say I use a credit card regularly. If I, one fine day, if I suddenly pay in US dollars or something, I'll get a call from customer care. Did you really make it? That means, imagine, say HDFC Bank, how many credit cards will be in circulation and how many people will be transacting every day? Do you think somebody is sitting and monitoring every swipe? You are collecting all the data, all the credit card transactions will get dumped, okay? They won't come in a relational form. They will come in some flat file or something. Your Flume will catch it. The moment it comes, it will push it through Kafka or directly to Spark Streaming or Flink or Storm. And there I could have written a logic, okay, match this transaction. If this guy's limit is something or his last transaction made places outside India or something, trigger a mail to customer care. That is how you're getting this EMI calls also. When you make a big transaction, immediately they will call and say, do you want to convert to EMI, right? These guys are responsible for that. What is the difference? This Storm can process one event also. Meaning one credit card transaction Storm can process. Ideally, one credit card transaction it will process, minute. Spark Streaming can process only bunch. It cannot process one. Meaning, it will collect probably 2 seconds worth all the transaction and predict. So that's called micro batching. It is creating a batch and then from that it is processing. 100% real time is only possible with Storm. And Flink also does the same, I think. This securities we were not handling. I'm not 100% sure how it is working. Our use case was only limited to this, right? But now I have a question. Okay, the question is very much valid. You are making a credit card transaction and Spark Streaming catches it. Spark Streaming catches it, but that is the real-time transaction. How does it know that this is a fraud based on the previous transaction? So if I am making a credit card transaction today, all my previous transactions are already here. They could have already built a machine learning model. And if you simply feed this new transaction, it can predict. Otherwise, how do you compare with batch data? I cannot run a batch job. It will take a lot of time, right? All the customer data. So they will run a MLlib. It's called MLlib in Spark. Machine learning model will be running. That will easily compare and say it's a fraud. If you want to compare the batch, see, now I'm just making a transaction, right? It has to compare with my previous transactions to understand whether I'm a fraud for the last 10 years. Today I'm swiping in New York. New York swipe, if you want to understand this an anomaly, you should compare it with previous swipe, right? Now, each time you cannot go and compare for each customer. So they build a machine learning model based on all this data that can, if you feed a data, it can predict, whether he will be a fraud or not. It will not directly compare and get. This I'm talking only about fraud detection. So your use case is your this thing, right? Stock market price variation. So my point is this historical data will be huge. It will be in terabytes, right? So you could have already created a machine learning model by feeding this data, which if you give any new data can predict whether it is fraud or not. That is happening in real time. I cannot say that once if somebody swipes a credit card, I will tell you whether it is fraud tomorrow. Doesn't make any sense, right? I have to do it immediately. Now, the flip side is that all this requires resources. Nothing is going to work if you don't have resources. So you need to give enough resources for all these things to work. Machine learning and all are very resource hungry. CPU power, RAM power, right? So these clusters should be capable of doing this. Anyway, for the time being, let's move on from Kafka, right? So we are just taking a use case, right? Now, I'll go here. Once your data is in HDFS, if you want to do batch processing, the default framework is MapReduce. MR. But I have my data, I want to do batch processing. I don't care how much time it takes, 1 day can take. I just want to process the data, I can use something called MapReduce, right? You also have one more guy called Pig. This is almost gone from the market. Pig, the animal pig. Pig is a scripting tool on Hadoop, but not very popular now because of Spark. So nobody is actually, so even if you are not aware of Pig, it is perfectly fine, I think. Okay, you don't have to worry. And then you have somebody called Hive. This is there in your syllabus. So Hive I will teach in the next month, but basically what Hive allows you to do is to write SQL on top of Hadoop. But the drawback is you say create table and select count star from the table, hit the query. It will convert your query into a MapReduce program. So it's a translator. It is not a native SQL engine. Instead of learning Java, right, we'll stick with SQL, ETL jobs we will run. They created this tool called Hive. So if I'm a Hive developer, I don't have to learn anything. It's SQL. I say create table, join. But once I say join, it'll write a MapReduce for me. Then the MapReduce will run. I may have to wait for, in fact, in Flipkart, there was a Hive query which took around 12 hours to run. Then they fine-tuned it and all, but that's a different story. But these are all batch processing systems built on top of Hadoop, right? And then you have Spark. You will learn Spark later. I don't want to confuse you a lot. So Spark is there. And this guy is inside Spark, okay? Even though I wrote it here, this guy is inside Spark. Spark is an in-memory execution engine. Spark is again classified as a batch processing system, but very, very fast than MapReduce. The only difference is that Spark programs are faster than MapReduce programs. Near real time, not real time. So Spark streaming is actually real time, but I would say near real time, not like 100% real time. MR and Pig are obsolete. Hive is not obsolete because Hive is your data warehouse where you create tables and store the data. So this guy will remain, but now what is going to happen? Spark will connect with Hive. And Spark can write, yeah, so here you can write a SQL, okay? Spark has a Spark SQL library. You can read tables from Hive and run on top of that, right? So Spark will start talking to Hive. So Hive is not really obsolete. Hive, so if I want to run, okay, again there is a confusion. If I want to run a very big group by query, let's say I want to read the full table, scan and run a query, Hive is great. Even Spark SQL with Hive is great because they will read the whole data and process it. But if I have minute queries, let's say select something from the table where name equal to Raghuraman. Only one row it needs to process. For that, why should I load the full data and process? It is useless. But Hadoop says load everything in sequentially and then process. That is only possible. That is where you have this MPP engines. Impala. There is a one guy called Impala. There is another guy called Hawk. Hawk and LLAP. There is something called Presto. Presto. There is also something called, what is that? Drill. Phoenix. These are all MPP engines. What Impala does is very simple. It has its own execution engine. You fire a SQL query, it will run it for you, no MapReduce. Right? So what is going to happen for these queries like where name equal to Raghuraman, you can fire an Impala query. It will scan only that data. Right? So it can connect with HDFS and pick only the data because it remembers the metadata. Where is what data available? It can columnar, it can pick that data and query. But then you will be wondering, why can't we use this instead of Hive? And these guys are very fast. So if these guys are too fast, then why don't I use them instead of Hive? They don't have reliability. They are all in-memory queries. If an Impala query is running in my Hadoop cluster, if any one of the machine crashes, my query will be gone. If a Hive query is running, even 10 machine crash, query will complete. It is MapReduce. Built-in redundancy is there. MapReduce will never fail, or Spark will never fail. But if I'm using Impala, okay, it has its own metadata. It knows where is the data. It loads only that, and queries will be faster. So if I run an Impala query, considering a Hive query, Impala queries are much, much faster, but no fault tolerance. So for these very fast queries, like your queries can take like 2 minutes, 3 minutes time, you can afford to lose a query, use Impala. But if I'm having a ETL job, where I don't want the job to fail, run it using Hive or Spark SQL, because these guys will never fail. So all MPP engines are like this, I think, in the traditional world also. In this, the difference is Impala is on Cloudera. Hawk and LLAP are Hortonworks. So there is a competition. Impala was originally created by Cloudera, so they promote it. If you are in a Cloudera platform, you will see Impala. If you are on a Hortonworks platform, you will never see Impala. They will promote Hawk. They will say Hawk is the best engine. Okay, and LLAP is the new version of Hawk. Presto, Drill and all are similar ones, but not by default available. This guy is very, very interesting. So there is something called HBase. I will add it here. Somebody was asking me what is HBase. HBase is your database of Hadoop. NoSQL database. Real-time database. Real-time. Because HBase will get installed on HDFS. There is your storage, right? But it can do random reads and writes, not like entire block. So normally when you are reading the data from HDFS, you have to read the whole block, right? But HBase has an API. So if you install HBase on top of Hadoop, it can do random reads and writes. Individual records it can read and write and process, because it is a NoSQL database of Hadoop, the default NoSQL database. But the drawback is HBase has its own language. So if somebody has to work with HBase, you have to learn the language. It will not allow SQL queries. Phoenix is SQL on HBase. Phoenix and HBase is like roti and paneer butter masala, deadly combination. I mean, very deadly combination because you are writing SQL on top of NoSQL, right? Very deadly. So they say that in another 2 years, it will not be slow. It's really fast because HBase itself is fast. SQL, there is a conversion, okay, but that's already built in. Any SQL query, there are some limitations, but so Phoenix will get all the metadata and already all the queries are converted. Whatever query SQL you are writing, it knows what is equivalent HBase query. So it has just pushed the query. So you just write a SQL, it will run on HBase and give you the result. And it can do things like secondary indexes and all. It can index your data apart from HBase. It's very fast actually. Now the real news is that in another 2 years, what is predicted is that this combination, the drawback is Phoenix is still in alpha beta. Phoenix is not production ready. Once Phoenix becomes production ready, this is OLTP. So they are trying to make it ACID support so that this entire combination will become an OLTP system like that, right? So then what will happen? You will get transaction management in Hadoop. So far it is not there. Another 2 years down the line, they say that, so Phoenix is getting integrated with HBase. Originally HBase was only there. The drawback is it doesn't understand SQL. So Phoenix started, Phoenix is a layer on top of that. You can write SQL. So in another 2 years, they are developing this as a system for transactional management. So you'll get true transactional management in Hadoop. So if you talk about the Cloudera and all, if I'm going to Cloudera and say that I want your product, they will give you all this in one package. But if you go to Apache and download, you get only HDFS, MapReduce and Yarn, only Hadoop. All this you have to separately install. So commercial distributions will package it and you will not get everything, okay? For example, Hawk will not be there. This Presto, Drill, Phoenix, you will get HBase, Hive, Pig, MapReduce, Spark, Impala. So these things you will get. Look at here, Spark, Hive, Pig, MapReduce, Spark, Impala, Yarn, right? But you have HDFS, HBase, Kafka, Flume, Scoop. This is a real product from Cloudera. You go to Cloudera, this is what you get. Some of them I have not even explained because I don't know. Kite, I don't know what it is, to be very honest. Kudu is a new file system, relational. Even I am not aware of Kudu. I don't know what it is. But these are like new entries. Even if you don't know them, you will work without any problem. And for security, you have something called Sentry. So a lot of people are worried about security on Hadoop, right? So there is a service called Sentry, which will handle like access management, authorization, authentication, or this will be handled by Sentry.
Spark Streaming is an extension of the core Spark API that allows data engineers and data scientists to process real-time data from various sources.
So what do you think is real-time analytics rather than me talking about it, right? I can take some help, by the way. So what do you people think is real-time analytics? What is your idea? Okay, analyzing the data as and when it comes. What else? So real-time analytics is not a new branch. Actually, real-time analysis was there for long back. Okay, so real-time analytics in general is that you are analyzing the data as and when the data comes, and that is a separate branch of analytics. Because so far, whatever you're doing, you do Spark, you do Hadoop, you do machine learning. That can be there, but any branch of analysis you do, you are working on static data. Your data is there, you are not moving it. So that is called data in rest, and then we have data in motion. So data in rest is easy to handle because the data is there, it is not moving anywhere. You just query the data or you do whatever you want. But data in motion is very difficult to handle because you need systems which can handle real-time data, and you need to take care of things like fault tolerance. What will happen if my system breaks? What if I lose real-time data? And the speed of processing, and all these things becomes a challenge when you go to real-time analytics. And there are a number of examples, we will discuss them for real-time analytics. But technically speaking, real-time analytics means you are analyzing the data as in when it comes, right? So we learned the 3 V's of big data. Their velocity stands for real-time analytics, right? So volume, velocity, variety. Streaming data can be generated from thousands of sources which typically send in the data records simultaneously. Ability to collect and process terabytes of data in real time, that is streaming data analytics. And it is a very interesting field. Starting from ad recommendations, like you are browsing some website and you start getting recommendations and ads. Starting from there, okay, to a lot of like fraud detection. Like I said, if you're swiping your credit card and immediately you're getting a call saying that did you actually make it? And customized offers, like I use HDFC Bank. So when I make an online transaction, I'll get an SMS saying that here is an offer for you. You transacted for this much, here is an offer for you. So all this is analyzing the data in real time. And of course, Twitter, like streaming the Twitter data in live and then predicting trends. So it's very popular, right? So like when the World Cup matches and all are happening, like which team is the popular, which player is the popular, all this has to be real time, right? You can't start the prediction now, right? The World Cup matches are over. So now if you start the prediction, it's basically useless. So all these are examples of real-time analytics, and Spark is excellent at doing this. That is what we have to understand. So batch is like queries or processing over all or most of the data in the data set. Stream is queries or processing over data within a rolling window. So when you say batch processing, you will analyze the full data mostly. Like if I have to run a SQL query on a table, let's say I'm running a very complex query, I will load the whole data and query the data. But when I say real time, only that window matters. I want to know the famous player every minute. So every minute only you need to process. I don't have to process the whole data, right? Data size, here it is very large. Here it is individual record or micro batches. Performance in minutes to hours, here it is milliseconds. Analyze complex, here it is simple response functions, aggregates and rolling metrics. So the next thing is that when you are actually doing streaming analytics, your analysis will not be so complicated. You can make it complicated, but then it will take processing more time, right? So, but I think machine learning and all, once you build an algorithm, I don't know, it may not take much time to, then that delay actually will matter. Because it has to recommend, right? Then only you can do something. So either you need to have enough resources to run that. I believe when you're running it in a cluster and all, it will make a difference. So machine learning, when you're actually running in a single laptop or something, compare that with when you're running in a distributed cluster. Probably even if with the features, it might be faster, I believe. Otherwise, these companies may not be able to do all this kind of analytics, right? Okay. So the when you say local traffic, right? Okay, the bus routes and all. Very much, because the amount of data it has to crunch. So many people are there, right? Everybody will be using, let's say, public transport, and the amount of data it has to crunch. Google is responsible, right? I mean, Google is the one who is showing, right? You can expect a delay. So it depends on your use case also. Like you are doing things like we were extensively working on this what you call sentiment analysis. So you have this sentiment analysis, right? It's very popular. Like you get the data and then you predict how a particular product the customer will like or they don't like. So we had an Australian customer, okay? So they were about to sell one particular brand of whiskey, okay? So they want to sell whiskey basically in Australia, and they want to do sentiment analysis. Meaning they want to know what people will think about whiskey, whether they will actually buy whiskey or not whiskey, these things, right? So for that, what we do, we collect the data. So that's not 100% real time, but we collect the data even in real time, and then we will extract the individual words and match them with certain keywords. And then we will be able to predict whether the customer actually might use. So once their product went online, this entire system we migrated to real time. The next challenge is if you are building the same real time system. So previously what people used to do, let's say they have Storm. So what Storm is doing real time data. It will give you real time data. But Storm does not have machine learning. So what people used to do, they used to build their own machine learning model and incorporate it with Storm. That is possible. But the drawback is if something needs to be changed, right, in the model or anywhere, everything has to be rewritten and reconfigured inside it, because they are totally different things. Storm is different and the machine learning libraries are different. But when you're actually using Spark, it doesn't matter, because everything is an RDD end of the day, right? So on the fly, you can modify the code, even machine learning. Unified API, right? You can do anything. So you don't have to make or break any code, existing code itself. So integration is very important. So I think so far Spark is the only framework where you have this capability. Like you can natively integrate machine learning with streaming. Flink also supports, but I am not 100% sure how much it supports machine learning. Not 100%. Spark is the only framework so far. So anyway, that's the comparison. And originally we were using MapReduce. I'm not going to do that. So many environments require processing same data in live streaming as well as batch processing, right? Existing framework cannot do both. Either do stream or do batch, right? So that is only possible. And I will talk about this fault tolerance in a different slide. So one of the important topics in Spark streaming is how it is fault tolerant. Like if something crashes, how will you recover, right? So I have a separate set of slides for fault tolerance. So this is only one slide and this may not serve it. I will talk about it separately. And that is where we got Spark, right? So I don't have to talk much about Spark, right? So Spark streaming is the extension of core Spark API. And it is scalable, high throughput and fault tolerant, low latency processing, simple batch like API. It is for use cases which require a significant amount of data to be quickly processed. Now, one thing that I have to tell you is that if you Spark, the problem is that normally when people teach Spark streaming, they will say, okay, there is something called Spark streaming, which is nice, it can process the data. But if you look at the documentation, it will say Spark streaming is legacy. Like Spark streaming is gone. Now in every my class this happens, right? I will teach something and say that people are not using it. But so if I look at latest Spark documentation, if I scroll down, what is Spark streaming? Old API. This Spark streaming is old API. Now there is a catch. There is something called Spark streaming which came originally, and that is what we are learning. And wherever I have gone, everybody is still using Spark streaming. The original what we are learning. There is something called structured streaming. This is what the new thing. It's not very new. It came with Spark 2. Okay. Structured streaming is nothing but you are integrating Spark streaming with Spark SQL. Spark streaming and Spark SQL. So the problem with the original Spark streaming is you can do real-time processing and all, no problem. But where will you store the output? So once I processed my data, so let's say I'm getting a lot of real-time data, I applied some logic, I processed the data, okay, and then I have to store it somewhere. So I store it in Hive or something like that normally. Then it is fine, but there are many requirements where I have to store the data also, like this, let's say the sensor statistics and all, right? So what structured streaming allows you to do is that when you create a stream in structured streaming, it will create a data frame automatically. And this data frame will keep on getting appended with the data, which means in real time you can write streaming SQL queries. It's a bit confusing. I will not get into that right now. It is like you have an ever-growing table. You have a table. The table grows every 1 second. You got the idea, right? Now you can query that table with a time frame. In streaming. That is structured streaming. Now, I recommend you to read a bit. There are a lot of YouTube videos also. If you go to Spark Conf in YouTube, because Spark recommends to use it now. That is why they are marking it as old. Your syllabus has only this. Now, I don't mind teaching this, but we will not be able to finish it because it is much more complicated also and requires much more time. But I must tell you that this is happening in the industry, right? At least. Otherwise, I can just say, okay, Spark streaming. Then tomorrow you go to the industry and people talk about structured streaming. You don't know. So structured streaming is, and it has much more fault tolerance and all. That's a different story. But the basic idea is that the moment you start your streaming data, it will create an infinite, ever-growing data frame or a table. And so you can run streaming queries every time. And there is something called a result set that will keep on changing, like 3 second, like that. You can run queries as and when the data comes, and then you can do something. So basically the problem was that people were not able to use SQL queries directly on legacy streaming. So legacy streaming will not allow you to query the data in motion. The data will come in motion, and then you analyze it and dump it in a Hive table, then you can query. That's a different thing. But here in structured streaming, the data as it is in motion, you can query from your data frame. And once the data is in the form of a data frame, you can do many things. You know that, whatever you want. You can visualize the data and all. So, but once we complete this, please spend some time on structured streaming. Once you understand normal Spark streaming, structured streaming will not be much of a headache to you. You can read and understand even that. Okay. So that's what I'm saying. So when you look at the documentation also, I should do justice to that also, right? So these are the connectors. So here is where your interesting topics come, right? So Spark streaming supports following input data sources. The first question is that how are you going to get the data? From where will you get the data? I want real-time data. Who is going to give me? One way is Kafka. So if you have Kafka installed, and if the data is coming in a Kafka topic, Spark streaming can get the data from Kafka. Yes, we will discuss Kafka separately, and also in Kafka there are a lot of changes now. Again, with my little experience, there are a lot of changes because I have a separate slide for Kafka and Spark integration, Spark streaming integration. Wherever people are using Spark streaming, majority use cases are with Kafka. Majority of them will be using some Kafka implementation. So I will talk about Kafka in depth, but yes, from Kafka you can create a stream. We will do that. Second is Flume. So Flume, like I said, can be the Flume sync can send the data to Spark. Third, we will not do this, but there is something called text file stream, meaning on HDFS or Amazon S3, if you have a folder, Spark streaming can monitor that folder, and whenever if a file is being placed in that, it can read it. So that way you can create a stream. So that is the third way. This is Kinesis. Kinesis is an Amazon Web Services product, proprietary AWS, but very popular these days. I have worked on Kinesis a little bit. Because if your cluster is in Amazon, the best way to get streaming data is Kinesis. So I'll talk a little bit about Kinesis. Basically, it allows you to give streaming data. That's what it does. Like Kafka, very similar. But this is proprietary. Works only on Amazon Web Services, right? Twitter for sure. TCP sockets. TCP sockets means it can monitor a port and get the data. We will do that. Like in your laptop, you open a port and let's say somebody is sending some data. Spark streaming can monitor that port and get the data. One more thing is that wherever I have worked in Spark streaming, I have used only Scala. Python is not preferred for Spark streaming. Ideally, our examples are in Python. That's fine. We can do examples, but in reality, when you go, the reason why I'm saying this is that this custom connectors, the last option is custom connector. Like you can create your own connector for getting the data. If you want to do that, I don't think in Python you can write it. Only Scala is supported so far for custom connectors. So let's say you have an application which is sending data, and Spark streaming should want to directly get the data from that application. So you should write your own connector for that. And I don't think in Python it is supported. Also, performance wise, Python has a lot of drawbacks when it comes to Spark streaming. So wherever I have seen the production code, it is all in Scala. Our code is in Python. That will also run. For learning purpose, it is good. But when you go to production, Scala code is preferred for streaming especially. Output can be persisted either in HDFS or database or a dashboard or anywhere. So once you have the output, it is as good as an RDD. You can say save to Cassandra or in a UI or anywhere you want. This doesn't matter, right? Yes, there is a Mongo Spark connector which we use. We have used a Mongo Spark connector. So using that, you can push to MongoDB collection. So in MongoDB, you have an idea of what you have a database. Then you have something called a collection. Collection is like a table. Then you have a document. Document is like a row, right? So the only thing is that when you start the Spark shell, you have to mention the URI where MongoDB is running and what is the collection name, DB name. And then there is a Mongo Hadoop and Mongo Spark connector that if you use, it can push directly. So these are the outputs. This is a partial output. It just says Cassandra. Okay. So this is just a pictorial representation of the same thing which I was talking about. No difference at all, right? Spark streaming can use all the core APIs like data frames, RDDs. So another advantage is that from within Spark streaming, you can access other libraries like RDD, for example, right? So if you have, that is where batch and real time can combine together, right? So let's say you're writing the Spark code, you already have some data stored somewhere, okay? You can say write a SQL query and the output of the SQL query, I can join with the Spark streaming data that I have. So you are practically joining batch data with real time data. That is possible. So it can access all the libraries that we have. Scala, Java and Python are supported. R, I don't think you have done R. R language is done complete. So in R, what you learn, I mean, not in the language, like what you do with R, I'm asking. I'm interested. Huh? So all these models you are doing regression, this, that, everything can be done in R. Either you can use Python or you can use R, right? Okay. Because R's. This is the example of what I was telling, right? So you are getting the data, Spark streaming data, right? The MLE will be your trained models with live data. You can also use trained model. It can also do real-time learning. Real-time learning is possible if the data is so huge, right? Because you are getting a huge amount of data. Real-time learning, you're training the model, right? Live data. So that is what this part, train models with live data. You will already have a model which is already trained. It's not like from scratch, but whatever data you are receiving can be used to enrich your model, right? Because you are getting huge amount of data that can be used to enrich your models. Or you can use train the model. Already somebody has trained a model. I just want to call it. That's also possible. Build the two models in your example using PySpark. MLlib basically, because otherwise you are doing only Python. So if you want to integrate your Spark knowledge and machine learning, so he said, okay, tomorrow I'll do that. I will use PySpark rather than simple Python. So then you will also understand how PySpark is or MLlib is actually being used in this scenario. I just spoke about it. And the data can be processed with data frames and you can query with SQL. That is also possible. Now, the real-time queries are supported in structured streaming only. Like as in when the data comes, you want to query, you have to use structured streaming, but it is possible. You can dump it into Elasticsearch or Kafka or Cassandra or any place you want. These are the streaming data sources, right? Kafka, Kinesis, Flume, Akka, and Anna, of course. HBase, Cassandra, Akka, Scala product, Cassandra, and so many other static sources, right? So, n number of sources. Anybody worked on Akka? Akka is a very popular, you have worked. So once this Spark job is done, you will clean up some data on the edge node. So I think we can get started, right? We will start with the hands-on, right? So first, what we will do that Twitter analysis, right? We will get the data from Twitter, and then we will run Spark streaming on it, and then we will analyze the data. A very basic example. And what I prefer to do is like, I will do it first, the example, okay? So that way you can concentrate on what I'm doing and then make sure, and I will also make sure it will work once we run it. And then I will give you some time to do it by yourself. It won't take much time for you to execute because the code is actually in this notebook, IPython notebook. So you don't have to do any modification actually, it will work, right? But it will be better. And the second problem is that if all of us start doing together, if I don't know whether the amount of data that will be consumed will be very high. So I will initially do alone just to make sure things are working and what you are doing, right? And then we will move to again you can practice. I'll give you some time for you to definitely practice, right? So usually after that we give the lab assignment. In normal real-time classes, what we do is that after Twitter streaming, I'll give the lab question and then the class is over. But today what we will do, I will show you that other case study, EMR case study, Amazon EMR case study after this is done, right? So that will take around 1 or 2 hours probably to run the case study. So that you will not be able to do along with me because it is on EMR, but I will show and guide you with everything. And so once class is done, you can set it up and just practice it. No, EMR is not free. It's a paid setup, but it is not like too costly. I mean, it is on Amazon. So when you are running on Amazon, they will charge you, but very less. Let's say like 30 rupees, 20 rupees per 2 hours or 3 hours. And you will not be running it forever. So normally when you run EMR, you will run it for an hour or two and then you terminate. Like, so you will be getting charged only that much. It's very cheaper actually. Now, again, I should say that if you have a concern on cost, you are free not to try that. I mean, I'm just saying in case if people are concerned, okay, I'm paying something, but there is no way you can get a free EMR cluster. Everything is paid in EMR, right? So there will be minimum charges, but very, very minimum. I can show you the pricing also. They charge very minimum actually for EMR, but that will be a good practice, I think, to do that because many organizations are actually using EMR now for processing the data. So if you can at least run it once, then that will give you a good idea, right? And also probably somewhere you can say that, yeah, I have actually created an EMR cluster, probably in your resume or wherever you're saying, you can say, I have at least seen what is EMR, what it is capable of doing. Basic at least, right? So what we are going to do is here in the slide. So what is the objective of this demo? How can you process live tweets for trend analysis using Spark Streaming API? That's what we are going to do, right? And we will show how to use Twitter API and route tweets coming from the Twitter to a TCP server using socket stream. TCP server is hosted in the local machine. In our case, it is CloudX Lab. So I must tell you about the architecture a little bit, otherwise the demo will not be complete. So the point I'm telling is that normally when somebody wants to do reliable Twitter streaming, Twitter will be there, that is for sure. They have an API. So Twitter has an API, it's called Twitter Firehose. Through that it will give you the tweets. Now this part is easy. Like in the Flume example also, if you remember, we downloaded tweets. Same thing, through this also you can get the tweets. The question is who is getting the tweet, right? So like I said, most of my experience is in Scala with the Spark, okay? So there what we do is that there is a, Spark and Twitter jar file, which you can use to Twitter jar file. So if I use that Twitter jar file, if I have a cluster, I have a method, I can say that Twitter utilities dot create stream. There is a method create stream. So if I call this method, what will happen is that I will start a receiver here. I will have a receiver here. Okay. And this guy will directly connect with Twitter API. This is in Scala. In the Scala code, you can use a third-party jar file Okay, that jar file has Twitter methods actually available. So once you import that jar files, there is a method called a Twitter utilities dot create stream. So in that dot create stream, you will pass the arguments. What is your ID, your API credentials? You will pass, and then you say create the stream. So what that will do, it will start a receiver here, and directly this receiver will start getting the tweets from Twitter. So your receiver is normally talking to Twitter API. So this is not what we are doing. In Python, it doesn't work like that. In Python, what we are doing is, so this is if you are running in production, you have to set up a separate machine, and here my Python code will run. This is not PySpark code, normal Python code. And in this Python code, I have a library called TweePy, which I can import in Python, TweePy, which will allow me to communicate with Twitter and get the tweets. So TweePy is a library which you can add your API credentials and normal Python code. So Python code will get you the Twitter data, right? But then what will happen? This will start getting the tweets, okay? And I will open a port number here. I'll start a port here. You can open a socket. So that means these tweets will hit this socket. And in the Spark cluster, I will do socket stream, meaning I will monitor this port, whatever. So through this, I will start getting the tweets. So these two architectures are different because here you are not receiving the data through any port number. You are directly talking to Twitter and saying that give me the data. And Twitter Firehouse will give you to your receiver. You start getting the data. In our Python example, okay, it is not possible that directly you go to Twitter and say that give me the data. So what we do is that we'll first run a Python code by importing the TweePy library that will start receiving the data. Like it will start pulling all the tweets. You can see the real tweets coming in. And then I will open a port number and that tweets will hit this port number. And here on my Spark cluster, I will say that ssc.create socket stream. I want to monitor a port number. And what is the port number? This port number. So naturally all the tweets are here. It will start getting to my cluster and then you will process. Okay. This is not so good, but this is also a way. So usually Python developers does like this. Scala developers does like that. Now in both these architectures, the drawback is if, let's say, in this architecture, the drawback is if the receiver crashes, then you will lose the tweets. In this architecture, if this guy crashes, then your tweets are gone, right? So if you are really doing some serious sentiment analysis or something, you bring the data to Kafka. You make Kafka in the middle, you bring the tweets to Kafka. From Kafka, you consume. So that you can consume to Python code or Scala code or any code, because you're talking to Kafka there. But as of now, we are not integrating Kafka in this example. We are just seeing how we can get the live tweets. And since we are using the cloud lab, this machine will be inside the lab only. This is one of the lab machine. So one of the lab machines, I will open a port, right? And that machine will start getting all the Twitter data. And I will ask Spark Streaming to monitor that port, get the tweets, process it. That's basically what we are doing. Okay. So it is written here. So see the third point, route tweets coming from Twitter API to TCP server. So we will set up a TCP server. We'll open a socket and say that, hey, all the tweets which are coming, come through this port number using socket stream. So this is an alternative method to Kafka, Kinesis, Flume and all. So you remember using Flume, we pull the data, right? And actually from Flume, when you're pulling the tweets, you can say that go to Spark. That is possible. But we will just try the socket file stream this way. So TCP server is hosted in the local machine. In our case, it is CloudX Lab machine. Okay. Right. And I think this part is already something which you already know, how to access the Twitter API, right? You will register with apps.twitter.com, right? And then you will get your consumer key, consumer secret, access token and access token secret, right? These four things you will generate. After creating the app, you will get this. You will also need to generate access token and access token secret. Now we are ready to call Twitter API. So this part is already done as part of your Flume example, right? Even here it is done. Now what we should do, right? Okay. So I will, like I said, I will try this first. I will definitely give it to you, but I think I have to upload the. Okay, so 2 notebooks are there. One is called Get Twitter Streams. The other is called Hash Trends. Now the next question is like, what are you going to do with the tweets? So you will be getting tweets, that's fine. But what are you going to do with the tweets? So what we will do, once we get tweets in real time, we will filter the tweets for hashtags. You know hashtag, right? Starting with hash. We will extract only the hashtag from the tweet related to a topic, and then we will count the most popular hashtags in a window, particular window, say 10 seconds or 20 seconds related to a topic. So this analysis is what we are doing, right? Now to do that, first what we need to do is that you need to have a small idea. So this is how a tweet will look like. On this left hand side, can you see what I pasted? This is how a tweet will look like when it comes from Twitter. Okay, one tweet, how it looks like. So as we can see, it is having JSON format. Okay, JSON means key value pair, right? So lot of keys are there, right? In which there is a key called text. This is the actual tweet that the person is tweeting. So here you can see in preparation of the NFL lockout, blah 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 blah, something. This is the actual tweet he's doing. Then rest all the key values are sort of like metadata of the key. For example, you have in replay, ID, user mentions, then what you have, any URLs mentioned, whether it was retweeted, retweeted count, created it. So all this is metadata. And again, then there is another text. So this is another tweet. Okay, probably repeated. Okay, so the point is, when you are looking at a tweet, you have to extract this text part. Text is where actually if somebody is writing. So this is the text part. So this is what we need to extract. So our logic in PySpark or Spark streaming will be that we will get this part and then we will split it, and then we'll search for any word that is starting with a hash. That will be a hashtag, and then we will just count it and sort it and then print it. That is the logic we are using. Okay, so this is a sample tweet. It will come in proper JSON format. Right? So here you can see a couple of tweets more, and you will also have this screen name. So this is a Twitter user screen name. Whether the Twitter profile is verified, false. Whether he has mentioned any time zone, null. Friends count 21. Language English. Favorite count 0. Right? Profile color, name. All these are metadata. So like some 50 plus keys are there, and we are interested only in the actual tweet, right? So, but when you say that create a socket stream, all of this will come. So the processing is a lot actually. This is one tweet, right? So, and when you say give me all the real-time tweets, a lot of tweets will hit, and they all come in this format, like JSON format. So that processing part Spark will do. We don't have to worry, right? So this is how the tweet will look like. And okay, so there are two notebooks which you have to use. One is called Get Tweets in Real Time using Twitter API. So this will help you to just get the tweets, okay, and then start a TCP server on a particular port number and make sure the tweets are there. The second one is trend analysis. So this is the Spark streaming code where it will monitor that port, and whatever analysis we just discussed, it will do there, right? Okay, so let's get started. I think, but we are running them in what? So it should not be Python, right? Now, like this guy can be in Python, we don't mind, but this guy has to be in, this one we have to run it in PySpark code, okay? And this one can be in your local Python 3 code, does not matter. We will just check how it runs anyway, and then we will see. So first thing that we are doing here is that we will import a library called a TweePy. So TweePy is a Python library which is designed to communicate with Twitter. All your API credentials can be taken, and so we are using TweePy library to route all the live tweets to a TCP server. The server is hosted in cloud, so we have to import the TweePy library first. So first I will say import TweetPy. And within TweetPy, you have this OAuth handler. So when you are communicating with Twitter, you have this consumer key, consumer secret. They are handled by this authentication. So you are importing that package for authentication. So I'll just say import the package. And if you go to the slides, what it says is that first step is creating the Twitter broker. So the broker is a Python client which connects to Twitter using TweetPy library and forward all the tweets to Spark socket stream via TCP listener. So you don't have to do this like installing TweetPy, it's already done. But let's say you are building a new setup, then you have to say pip install TweetPy, right? This is what you need to do, right? And then what you need to do once you import the OAuth handler, you are also importing something called a stream, and within stream you have something called stream listener. Okay, so this is used to listen to all the Twitter streams that are coming in. Okay, and after that you have something called socket and JSON. The socket library is used to start a TCP server on a particular port number that you want. JSON is imported because we want to analyze the data. So the data will be actually coming in JSON format and you want to talk to that. That is why you are importing the JSON package, right? Now what you do to connect to Twitter API, you have these keys. So when you are actually running this example, use your own keys, okay? So this has a different set of keys, but I'm just saying that this is my consumer key, consumer secret, access token, and access secret. So these are my 4 credentials, right? After this, what we are doing here is we will define a class. So this is one way of doing it. Okay, there are other ways to do it also. We will define a class called a tweet listener, and it is using this stream listener. Okay, and why are we defining this class? See, it is listening to the stream via stream listener. So it has a constructor. If you are aware of object-oriented programming and all, it will initialize this socket. Okay, and the Twitter data in the JSON format will come to the stream, and within the data you have within the JSON object you have a key called a text that will have the actual tweet. Okay, and the actual tweet is extracted and sent to the client socket. Error handling is also done. So what this whole class is doing is very simple. It uses the stream listener. Okay, and then what happened? I have a constructor. Okay, I have a socket in the constructor. Okay, so the C socket is my socket. Okay, and once I get the data, what I will do is that I will have a try except. So this is exception handling, right? I will say JSON.loads data. So data whatever is hitting will be read by JSON, parsed by JSON. Within the data, I will say print message text.encode UTF. So I'm doing a print statement here. So this is how you understand whether you're getting the tweets. When I run this code, if this guy gets the data, okay, it will start printing all the tweets one by one on your terminal. Otherwise, you don't know whether it is actually receiving it. Okay. You can also print other lines if you want. That's up to you, but we are not doing that anyway. Like text is one key. If you want to print all the created at the user's names, all these things you can print. We are not doing that. Self is an object we use, right, in Python. So even have you done MapReduce using Python? Self, how do I explain? It is just an object used to handle whatever values you are, defining in your class normally. I will explain about it. Okay. So once you return, what are you returning? You will send the text. Text is the key, and the encoding is UTF-8. Whatever tweets you have, you will send it. You will say return true, and this part is all exception handling. So if there is any exception comes, error on data, or the data is not coming, this part is full exception handling. This class basically what it does is that it will just receive your through stream listener, it will receive your tweets, okay, and whatever tweets are coming as data, it will be passed by JSON, and it will just print the text part, okay, and the socket. So this self has a socket built in, right? So I will say that whatever tweets you are getting. So because another requirement is that when you are getting the tweets, right, you will get the full tweet. But to the socket, I need to pass only the text. I don't need to pass all the keys, right? So that is what this client socket C socket does, right? So I will say return client socket dot send. So to that particular socket, we have to create a socket, okay? To that particular socket, only the text part will be transferred. Okay, so this is what this code is doing. So in here, you have to define another function. Okay, so here is a function called, did we run this? No, right? Then I have a function called send data. So you're defining a function called send data, which will take this C underscore socket as an argument. Okay, so this auth is this authentication handler. So here you are passing your consumer key, consumer secret, access token, and access token secret, right? And then you will say stream author Twitter listener C socket. So what is going to happen? Where is this? Let me just scroll down. So here you have the class called Twitter listener. So when you are creating this stream, you are passing the authentication. You are also passing this Twitter listener, an instance of this Twitter listener, in brackets, the socket that you are having, right? And another thing is that when you actually start running this, it will start getting all the text part of your tweet, but you may not want to send everything. So what you do is that you can do a filter. You can say track something like Trump. So what is going to happen is that in the text part, all the tweets, if there is anywhere mentioning of Trump or anything related to Trump, it will filter only that and that will be sent. Otherwise, what is going to happen? All the tweets that you are downloading will be sent to the particular socket. So I will just run this function. We are just creating the function right now. And then you have to create your socket, right? So there is a function called a socket, which will create a socket object actually. So I'm saying that S equal to socket. This will create a socket. And as of now, what we are doing is that the host is localhost and take a random port. For example, here the port is 9877 and you have to say s.bind and then host comma port. Now, if this works, there is an error. So what the error is saying is that it is saying that address already in use. So 9877 is already in use. What about 9999? So if the socket creation was successful, it will show that listening on port 9999. So right now that means this guy has started listening on 9999, right? And now what I will do is that I will say that s.listen. Yeah. So look at this send data function. Where is the send data function? If I scroll up, this is the send data function, right? So what the send data function is doing is that it will create a stream. It will use your authentication credential and the tweet listener class you defined and pass the C underscore socket. It is going to filter the Trump keyword. And after that, what we did is that we defined the port number. This is the particular port number we have defined. Okay. And I just said s.listen. And now in order to accept what you need to do is that you have to simply say s.accept. So this will establish the connection. And then what I'm doing, I'm just printing received request from, and I'm just printing this ADDR. So whatever tweets ideally I'm getting, it should start printing here in my console. So right now, nothing is been printing because it will take a moment to establish the connection and start printing. But after a moment, we should ideally start seeing the tweets coming in on the screen, right? So this whole process is actually only to get the data. You are just getting the data, only text part of it, filtering using a, say, keyword like Trump, and then just verifying that the tweets are getting printed. Now in the PySpark code, Spark streaming code, I will say create a streaming context, connect with this port, start getting the data, and then analyze and print the data, whatever is coming, right? So let's see whether it is actually giving any data right now. May take a moment for this guy to start getting the data. This star indicates what? This processing, right? So till this part, no, not this part, the above part, everything was working, and now it is actually listening and processing. So this will take a moment for that to start printing it online. Meanwhile, see what we are going to do with the PySpark library, right? So you are importing couple of libraries here. Okay, I will talk about this print function. First, there is Spark context, and then there is streaming context. So these libraries, so I will just import them. Okay, and this is how you are creating a Spark context. Sorry, streaming context. You will say SSC equal to streaming context SC comma 10. So what is this 10 here? That is a batch interval. So you are saying that my batch is 10 seconds. So I need minimum 10 seconds worth data to process. So while creating the context, you are just mentioning your batch interval. That is nothing but 10 in this case. Okay. And then you will say that socket stream equal to SSC dot socket text stream, and what port we are monitoring? 9999, right? So what this line will do, it will establish a connection to localhost and start monitoring port number 9999, right? And window function parameter sets window length. All the analysis will be done on tweet stored for 60 seconds. So you can change this. So this is how you use windowing in Spark streaming. So now what you're saying is that, okay, 10 seconds is my batch interval, right? Which means it will start downloading data over 10 second, 10 second, 10 second. And then I'm saying that socket stream dot window 60. So my window interval is what? 60 seconds. Then what is my slide interval now? So window interval is 60. What will be slide interval? Which one? This one is 60. The batch was 10. So sliding interval is when your computation should happen. That is sliding interval. Sliding interval will be 10 in this case, because you have not mentioned anything explicitly, right? In that case, what will happen? It will use the same batch interval, which means every 10 seconds, the computation will happen. My batch is same, sliding I have not mentioned, but it will calculate 60 seconds worth data for analysis. So initially, it will just pull whatever data it has, but ideally, let's say the streaming keeps on running. Every 10 seconds, it will go back in time, last six batches or 5 batches, it will analyze and show you the result. So that's up to you to decide. I just use 60. We can even use a smaller number. Rather than 60, I can say 20 just to make it work. And then how do you process the team? So what is happening here? So once you get the data, what I do, I will do, so what is this part? I will do a flat map, and I will say that for every line, split it using space. And again, I'm using our functional programming, right? I will filter. I will say that take every word, convert the word to lower, and I want all the words that are starting with hash. Right? That is how you get hashtags. Again, you will say map transformation. Okay, lambda word dot lower, comma 1. So you will convert to key value pair, and then you will say reduced by key a comma b, a plus b. So if you remember the word count we did, right? It's the same code. The only difference here is that I'm converting to lower sometimes, and I'm also filtering using a hashtag starts with hash. Apart from that, this code is exactly same as your word count code, no difference at all. So you will say that I want to count the words basically all starting with a hash. That is this piece of code doing. And let's make sure we run it. And once you get hashtags, what you do, there is a transform function. What the transform function will allow you to do is to operate on RDDs within the D stream. So normally the word count that we did is on the whole D stream. Okay, but if you want to access any RDDs within the D stream, you have to do transform. Because when you say that you are sorting the data, sorting means it has to happen within the D stream. If I say sort a D stream, nothing will happen because D stream itself is one API. right? So I have to say that look at the RDDs we have within the D string and then sort the hashtags. So that is why I'm saying hashtags.transform, and I will say that lambda x.sort by. What am I doing here? I'll just use the sort by function, and I will access the first element, convert to lower, and I will say that ascending false. That means descending. So the hashtags will come in hashtag comma the number. When you do the word count on the hashtag, it will have two parts. One will be the hashtag, let's say hash trump, then the number like 3 or 5. So what am I doing here? I am saying that convert the key to lower, okay, and sort, run the sort function based on the value part, that is a number, in ascending false. Do you remember we did sorting in RDD programming? We used the sort by function and how to use sorting. Same thing you are doing here. So once you do this, which part did we run? Did we run this? I think we ran that, right? Which is pending? I mean, I don't remember. This is pending, right? Okay. So once we get it, the next thing will be that I just want to print it. Okay. And this is most important. So right now, okay, so there's already something coming up. Cell. Yeah. So right now, so far, nothing has happened. You just defined your D streams and you said this is what I need to do and so on and so forth. But in reality, nothing has happened so far, because if you want to start Spark streaming, you have to say ssc.start. And there is a method called ssc.await termination. I will talk about it. Okay. But just make a note that there is a method like this. So now, ideally, my streaming should start. So you can see that the streaming started and we are getting data in 10-second interval. So it is like 10:3:40, 10:3:50. But were you running along with me? I mean, we can use the same keys multiple times, right? No. Then if you have started, then I will not get anything, right? Because the key is same. The Twitter key is different. But you're seeing the, not the port, this thing. Maybe I think that might be the reason, I'm not sure. No, port is changed for sure. I'm assuming if multiple connections are from the same key, will it allow? I don't know. Anyway, so what is this key? I think I'm not using my key. This is someone else's key. So can you guys try this? Anyway, we'll try together. So since it is not working and somebody said it is working, I got interested. Okay. Can we all try this together? I just want to check what is my key. So now I started getting tweets. Can you see tweets coming in? Can you see this? So this is all tweets. See how many are coming in. And then if I go to my Twitter analysis, can you see it is analyzing? So every 10 seconds, what will happen? Every 10 seconds, it will process a batch, right? And start showing me. So yes, so it is picking the last 2 batches and analyzing and showing you the output. The processing will happen every 10 seconds. Because your batch is 10 seconds, you have not mentioned any sliding window. So if you have not mentioned any sliding window, it will take it as batch interval. So it is 10 seconds now. So every 10 seconds, processing will kick in. But to process, it needs 2 batches of data, 20 seconds worth data. So now it is 10:20, right? It will analyze tweets from 10:00 and 10:10, 20 seconds worth data. That we cannot see, but it will just show. I mean, it won't. It will analyze 20 seconds worth data every time. So your sliding window is 10 seconds here. So what is happening? Every 10 seconds you are getting data. And every 10 seconds you are analyzing the data also. But you are not analyzing 10 second worth data. You are analyzing 20 second worth data. No, the analysis will happen every 10. You can see 9:50, then it will be next 10 second. I'll just show you here. Because I'm not able to scroll. If I scroll down, right? If I scroll down, you can see that now it is 11:30, right? What is the time? 11:30. And next analysis will happen at 11:40, right? Again, next analysis will happen at 11:50. So analysis will happen every 10 seconds. But in every 10 second, it is not analyzing 10 second worth data. It is analyzing 20 second worth data. First, it will not process. Like let's say it kicked off at 10 o'clock. It won't analyze anything, because when it look behind, it will not have any data. Then 10 will come. Still, it will not process because it has only 10 second worth data. Next, it will process because 20 second worth data it got. It starts processing that. So 20 seconds worth data every time it will process, but the processing will kick in every 10 seconds. 10 is your batch interval. Are you able to run this code and get something? There is one more problem. In the morning, Narayana also told me PySpark is having some problem. I don't know what it is. Did he try to run code in PySpark and it didn't work? Correct. Then we ran it again. But again, PySpark was not able to access the file was there. But when the processing was happening, it was throwing error, some error. Even here, I'm facing the same problem, because if you see, this is Python 3 code. It's not PySpark code. My Twitter analysis, right? This is running on what? Python 3. It should actually run on PySpark, right? In reality, this should run on PySpark code, right? We are importing, but normally the kernel has to be PySpark, ideally. That is a better way to run, because you are directly accessing the libraries. But I don't know, I tried with PySpark, it was throwing some weird error. So I checked with Narayana, even he said he is also facing some issue, I don't know. Maybe they're doing something on the cluster. I'm not 100% sure. So make sure you can run this, you can execute the code. I was running in PySpark. I just switched to Python 3, it started working.
Okay, but this anyway I'm running on Python 3 only.
You're in Python 3 only?
Yeah. The other one is only on PySpark.
Okay, do one thing. You have to do send data also. And what you need to do, just start them. So stop it. I think it is running, right?
Yeah.
This is running, right?
Yeah.
How do you stop? There is a place to stop the server.
Yeah, you can just select this and then shut down.
Shut down. So now start it, but use Python only, Python 3 only. Don't use the PySpark kernel. That is having some problem. Even I'm not sure. Like, what is it? No, my question is, no, this is some old data. It is not working actually. This data is old in the sense like already it could have had some data. So what you need to do, and start them again, but this time run both in Python. Don't use PySpark. You were using PySpark for this thing, right? Now run it again, but make sure your port is correct, like which port you are using. But here you have given a different port, okay? Here it was 9876. There also the port number has to be same. You can run that first, then this. So you need to change the port number in two places, okay? So some of the folks were doing, like in getting the tweets, you will define a socket, right? And that should be same in the Spark streaming code also. Otherwise it will not catch, right? So make sure your kernel is Python 3, just for the safer side. Then definitely it is not going to work. It is going to work. Yes, Spark streaming, you cannot stop. If you stop, you have to run all the cells again. The other guy you can restart. So Spark streaming, so this is Spark streaming, hashtag trend. But now there is nothing.
It will come.
It is waiting for some time. Okay. So this thing, if I stop, I can stop this. But if I stop, I cannot say start. No. This thing, let it run.
This is receiver, right?
This thing, let it run. It will give you tweets. That's fine. This is where you're doing the analysis. This is Spark streaming.
My question is,
There you have to change. The other side, you don't have to change anything.
okay, I understand that. So here if I change and restart, right?
You don't have to restart. Okay, you have to run that cell. Exactly. If you change the code, you have to run that cell again.
Somewhere filter.
But then you have to rerun all the cells.
Up and rerun.
Wait. It is trying to get the port. Probably it will throw an error. Because last time we were using this port, maybe it is still bind. So it is running this cell now, right? It will say whether that port is available or not. It will say that listening to that port, right?
Correct. It will continuously listen.
It will display that message, listening on port number. It was in this state only. Okay, then let it run. Maybe it is a bit slow to display. Next. Now here,
This is my recipe, right?
here you can do one thing. Okay, this is better, right? If you want to run everything, you can simply say restart and run all. So it will restart the kernel and run everything. And I'll just clear the output. I think it ran. I'm not sure. Let me check. No, it is running now. See? 4, 5, 6, 7. But my point is, it should ideally print here.
I agree, but last.
Okay, so here it is running, but we are not seeing anything so far. And last time, were you able to see something here? Another question, when I gave you this file, these two files, it had some data already. So were you seeing that, or were you seeing like live? Yes, now it is empty. In my opinion, it is even stuck here, stuck in the sense like it is trying to get data through this port, but it is not happening. That's why the star.
Last time also it was same star.
Okay. Another thing is that everybody is trying. That also might have an impact, because same machine, right? There is only one machine where all the ports you are jamming, right? We'll wait for some time. Probably it will get, or else choose a different port maybe. Just change the port number to something else and rerun this. 420 is what? Error message, right? No. 420 will be given by Twitter, right? What is HTTP code 420? Can somebody check? It is client error. If I'm not, can you check HTTP response code 420? I mean, I think that is it, because you are getting 420. It's a client error HTTP. Because from the same machine, there is at least like 20-30 requests going in, right? Probably that is the reason it is saying. Try one by one, it should work for sure. Return by version 1 of the Twitter search and trend API when the client is being rate limited. Rate limiting. Like, so 420 is an HTTP code for rate limiting, when Twitter is rate limiting you. So there might be how many messages it can send to a particular client. So basically all of these people are running on single machine. Even though different port number, it's one machine. So they are rate limiting. They are saying we cannot send. So that is rate limiting, right? So some of you have to say I will not run, then others can run. Obviously everybody is running, right? So it will rate limit you. Who is able to get the tweets? I mean, see the tweets you are able to do. Okay. Who is able to get at least once? I mean, not like at least once you have seen, right? Who is not able to get at all? Twitter application is suspended. You got an error. Why? You search for something weird? No? That is client this thing, right? Well, one more information is there. In Twitter, now if you open that app's website, apply for a developer account. I have applied, so maybe this will happen very easy, probably 24 hours or something. You are not eligible for developer access. Only one. Oh, it is already running one SSE. That is why this error is coming. I don't know where. Probably the previous one is not shut down. This one, right? These two notebooks, right? Let us pick a port number. No, this data will not be saved. It is streaming data. So it will come through that socket. Even the output is not getting saved. We are just seeing the output. If we want, we can say write it into Hive or somewhere if we want. But as of now, we are not doing that anyway. So I will probably, so that is the system time, the time in which that computer is running. This is running in the cluster, right? So in that cluster, this is servers are there, right? Their time is 10:10. So the current time is like 4 o'clock, but there the system time. But usually what we do is that's a good question, because if you are doing this kind of analysis like Twitter, last time Flume we did, right? So those times when you are in a cluster, we will enable this NTP service, network time protocol. Otherwise the machines will not sync. So you will have an NTP server that will sync all the machines to time zone, and then only you do all these things. Otherwise time is a very big problem. Especially when you are running Flume and all, throw error. If any one of the machine is not in sync with the time, it will throw error saying that there is time zone issue. So NTP you have to run if it is in a production cluster. Here it is just taking the system's time, local time, right? Okay, I'll just close this streaming for the time being. Now they have a mandate. So previously everybody was able to log on to Twitter, like apps.twitter.com, and say create an application. So that is being misused a lot, right? Because anybody can do anything. So now what they are asking us is there is an option to apply. Again, you go to apps.twitter.com, there is an apply button. There they will ask your mobile number, I don't know, some details, and then only they will approve. Otherwise your account will be suspended, this app account, right? So port listening can be done in any system actually. So it is not the way you listen. I mean, what you process is different, because in Spark what you're doing is that you're listening to that port, and whatever data is coming in, you're chopping that to 3-second batches, right? Now, if that data is, let's say, very less, let's say you want to do the same sentiment analysis, okay? And if the data coming is very less, probably you don't need Spark to do it. Maybe you can write a Java code or something. You need to know the logic, what to do, right? How to extract and all. But Spark's relevance will come if that port is receiving too much data, which a normal machine cannot handle. It may crash. So in that case, what will happen is that whatever data you're coming in, it is distributing to the cluster. So that power it will get. And also, let's say you start receiving the data, but I want to analyze all the data came through that port number for last 1 hour, right? So my batch is last 1 hour. So if I start monitoring a port, if I monitor for 1 hour, I'll be getting a lot of data. So I need to hold it somewhere, right? So probably if I'm running Node or a local server, it may not be able to do that. But if I have Spark, I'm just distributing the data. My batch can be 1 hour or 10 hours or anything. So we had a similar situation. This Flipkart and all sale is happening, right? Freedom sale, some nonsense they're doing, right? Amazon, Flipkart. So there the same thing will happen. What they will do, they will be running streaming applications behind the scene, okay? And Flipkart uses Kafka. Everybody uses Kafka. So when users are browsing or buying stuff, right, all those information, like how many mobile phones. So let's say they put up a promotion on Moto G, just an example, okay? So Moto G sale begins only on Moto G. So people want to buy Moto G probably. So what they do is that they will run a streaming application which will keep on polling this Kafka topic, where the data will land what people are searching for and what people are buying for, right? And then it will publish every 5 minutes or 3 minutes the result. So it will be like in last half an hour, let's say 5,000 Moto Gs were sold and 10,000 people searched for it. So this statistics they need to see in real to understand whether they need to change the strategy. So in sale, that is how it works, right? Because that is real-time analytics. So there, if you're looking at it, millions of people are accessing the site, right? And Flipkart even tracks your mouse movements. So like I said, last year I was with the Flipkart for a couple of trainings with them. So they didn't allow me to go in depth into what they are doing and all, but they even capture a mouse movement, like this, right? So that will be captured, because they want to understand how the user in a particular UI, if they display the products, what are the chances a user will click an item on the right corner or left corner. So from a single user itself, huge amount of logs will come. So during a peak sale, they will get terabytes of data in real time. So that you cannot process using any single machine or a node or anything, right? So then they want to understand what people are searching for and how many are actually buying. So the buying, if you're actually buying, let's say Moto G, I don't know, whatever you're buying, that is not handled by big data systems. That will be handled by RDBMS, because there is reliability. If I'm paying money, I should either get it or not get it, right? So I cannot trust on any of these folks for that. So they have a big Oracle cluster setup where the financial transactions will happen. So when you place an order, actually when you pay, Oracle is handling the payments and all. And then it will mark as bought, item bought, and you paid money and all. That data along from Oracle, there is a CDC, from there read and push it to Kafka. That is how they know how many people are buying in real time. So how many are searching, how many are buying in real time, and then a lot of ML on top of this. That is how they make decisions in real time. Otherwise, how it is not like a blind sale. Doesn't happen like that. You cannot just conduct a blind sale saying that let people come and buy whatever they want. Doesn't work like that. Web and app. So they have their custom code to push. So they are using a combination of couple of languages. I didn't go in depth into what they are doing, but they have their custom code to read weblogs. Basically, they have written an application, and whatever the web server is writing as log file, it will read it, and it is a producer actually for Kafka. So it will push it to Kafka directly. So the log files will directly land on Kafka. From there, they are monitoring. Because let's say I'm purchasing something, okay? That purchase is a log entry, or I'm searching something. Now that information might be needed by multiple people. One set of group will be who are monitoring what I'm doing. Another set will be doing some machine learning, let's say. So if multiple people need this information, it has to be in Kafka only. So the storage place for all this is Kafka for them. They have a custom producer for pushing this to Kafka. From Kafka, they read in real time. So there, this batch and sliding all will be important. Like in the every 2 minutes, I want to know how many people bought Moto G last half an hour. Just like that, I'm just saying. So that I can adjust my strategy, right? And they have a very excellent decision-making team. So what they do is that when these sales are happening, every 15 minutes, there will be a shuffle-in plan. Shuffle-in plan means we don't notice it actually. So they will have some products promoted and some products like mobile phones. So like an Apple iPhone 10, 30% off, imagine, right? So then, so how these offers are coming up is that this Flipkart is actually buying from somebody, right? They don't produce iPhone. So they will have some people who will give them iPhone and they will sell iPhone, right? So if they say 30% offer on iPhone, these guys will not give them at 30% rate, right? If I am selling to Flipkart, I will not sell on a lower rate. Then what is my profit? So I will sell to Flipkart on my original rate. And then Flipkart has to sell on a subsidized rate, right? And that they do with bulk amount. Like if they can sell so many units, then they are. So initially they will put up saying that Apple iPhone, let's say 30% off. Okay. And then they will track real time how many people are visiting and let's say browsing for this mobile phone to see that. And if they see there is a less traffic for iPhone or something, they will start clubbing offers and displaying. They will say that now you also get 10% cashback or 5% cashback, because they have to promote the sale of that product. Then only, otherwise what they bought, the units all are waste actually, right? So real time they have to monitor and adjust the sales strategy. Then only this will work. It's a huge task actually. It is not so easy as we speak to conduct a sale and then sell things. It's not very easy actually, right? So this is a small part. It will not take much time, okay? And once we finish this, I will explain my case study, what I'm going to do, and then we will run the case study for real-time dashboards, okay? So now, so far we understood that we'll create something called streaming context, and then the data will come, we'll analyze the data, and like you saw the tweets, we'll just display whatever analytics we are doing. But the problem is, what if something goes wrong? What if something crashes? How do you recover in Spark streaming? So that is things you need to know about reliable Spark streaming. This is something which I already explained. So these are the popular frameworks. There is something called Samza, which is not very popular these days, but was there. Okay, I now remember when I looked at the slide. I have actually worked on Storm and Spark mostly. Flink little bit. Samza I have seen, but I have not gone into Samza. Then Akka is a very popular inter-process communication framework. And stream storage. Stream storage means once you are analyzing your data, then where will you store it, the result? You can use HDFS, you can use Kafka, AWS S3, Amazon Web Services, and this is EMR. This icon is EMR, Cassandra, so on and so forth. So we already know that storage is also like this. And these are the sources from where you can get. Have you heard about this MQTT? This guy? I forgot the expansion of this MQTT, but that is a source for IoT data. Like IoT data, if you want to consume, then the type of source is called MQTT source. Okay, I forgot the expansion, but yeah, from where can you get the streaming data? Through Twitter, Kafka, I don't know, Socket. This is Socket, and HDFS, from many places. Yesterday I told you that you can create something called file stream. Like you can monitor a folder, and if somebody places a file there, you can read it immediately. That is possible only in Scala. Python doesn't support it so far. So file streams are only supported in Scala, not in Python. Right? So file stream is not listed here, but yes, you can monitor a folder, and if somebody places anything in that folder, that stream will process. So let's say it is like 10-second worth batch. Within 10 seconds, how many files are placed in there, it will read it and start processing. But in Python, you cannot write that code. Only Scala is supported as of now. Yeah, so we already went through this. High level API is there, fault tolerant, you can integrate with these things. And receivers receive data streams and chop them into batches. Spark processes the batches and pushes off the result. So right now what we did, in the code, if you look at, we wrote the code like this, right? The code we wrote is ssc.socket text stream. This is the code we wrote, right? So what does this mean? I am using the Spark streaming context to create a socket text stream, which means I'm monitoring a port. This is the localhost, this number. So this will create something called a receiver, a process called receiver. Then that receiver is responsible for monitoring the port and getting all the data. So receiver is actually a JVM process, which is its job is just to connect with whoever is sending the data and get the data.
Let's talk about why data warehouses are essential for data engineers and what they actually are. A data warehouse is a centralized repository that stores large volume of structured and sometimes semi-structured data. It is designed specifically for querying and analysis rather than transaction processing. Think of it as a giant library of data, where data from different sources is brought together, transformed and organized to be easily accessed for decision making and reporting. For example, if you work for a retail company, a data warehouse could store sales data, customer information, and product inventories all in one place. This allows analysts and decision makers to query the data quickly, run reports, and make data-driven decisions without affecting day-to-day operations. Data engineers play a key role in designing and maintaining data warehouses. They ensure that data flows into the warehouse from different sources is cleaned and organized properly and is accessible for analysis. A well-designed data warehouse can improve data accuracy, speed up reporting, and allow companies to make faster, better informed decisions. For data engineers, data warehouse simplify the task of managing and integrating data from multiple systems. Instead of dealing with scattered databases, they streamline the process, improve performances, and ensure data is consistent. Let's explore the top data warehouse tools that are essential for data engineers. First one is Amazon Redshift, a fully managed scalable AWS data warehouse ideal for handling large data sets and integrating with AWS tools. Next, Google BigQuery, a serverless data warehouse known for fast SQL queries on large data sets, perfect for real-time analytics. Next is Snowflake, a cloud-native platform offering flexible storage, processing, and analytics across different cloud providers. Next, Microsoft Azure Synapse Analytics combines big data and data warehousing to provide powerful analytics on structured and unstructured data. After that, Oracle Autonomous Data Warehouse, a self-managing cloud-based warehouse that automates performance and security management tasks. These tools enable efficient, scalable data storage and analysis for modern data engineering needs.
What cloud computing is. Now, ladies and gentlemen, when you talk about the world of cloud computing, it becomes very important that you understand that cloud computing went from being a term which only researchers knew all the way to you yourself using cloud computing at this very second you're watching this video, right? So what is it? Well, to talk about the textbook definition of what cloud computing is, I think it's very important for us to understand that it is a very simple delivery of services through using the platform of internet. Now, to reiterate on what I just said, it becomes important that you understand that, whatever is that is a thing that you can do offline. These days, there's a very common saying that says you can do it online as well. So whenever someone says stuff like, you can do things online, right? Think about a favorite example. Maybe you want to back up all of your pictures to Google Photos, right? So maybe something might happen to your phone. You just want the photos to be there, very important memories and all of that. So you back it up somewhere. Now, where is this data going when you're backing it up, right? So Google is giving you a service which says, hey, you can use Google Photos to just push all your photos there. It's going to be safe. No matter what happens to your phone, mobile or laptop or something, your data is going to be on the Google Cloud platform or on the Google Cloud server, right? See, cloud server, Google Cloud platform. We're already talking in terms about cloud computing, right? Perfect. That's one example. Now, the second simple example that you might have heard the IT team in your office talk about is, hey, let's back all of this data up into a server or something like that. So when they say, let's back up this data into a server, or let's say, when they go on to clear things and they say, hey, okay, so we need space in our actual server. So let's move all the data that we have to a backup server. So when they say they're backing up something, it means whatever that they're trying to back up is important, of course. The second thing is that, are they backing up this data to a storage entity that's present in the office, or what we call as an on-premise network, or what it's also called as cloud computing, where, your data is not physically present on a hard drive in the office, but it can be present in one of the data centers, which could be like right next door, or it can be halfway around the world as well, right? So when they're backing it up to an online server, things like this happen, and that's a wonderful thing, right, when you think about it. Now, to talk about the third thing talks about the fantastic approach that is a new trend in the world of cloud computing today. I'll give you a very simple example. When you have to think about executing, let's say, Python code, right? Python is a programming language. When you have to execute its code, you're going to have to install Python. You're going to download it, install it, configure it. Maybe on top of Python, you're going to have to require a user interface. So you're going to download something like PyCharm or anything, right? So to make sure that your coding experience is easy and all that. All of this process that I just mentioned takes time. But now what, the world of cloud computing brings us, for example, with Google Colab, that is COLAB Colab, what they're trying to do is they're trying to give you a Python Jupyter notebook ready for you to just type in your code, hit the play button, and you're done. You don't have to download anything. You don't have to configure anything locally. You can use it on your phone, on your tablet, on your laptop, on wherever you can open a web browser. You can go on to write Python code. So you might have a question now that says, hey, okay, so where is the processing power coming from for all this Python code to execute? All the processing power, all the storage, all the data elements, everything that is required to run Python in this particular instance is coming from the Google Cloud platform, right? Google Colab. It's a fantastic Python Jupyter notebook that I see myself using a lot, right? So guys, these are some of the really nice examples of cloud computing. Now, when we discuss popular applications, again, we're going to look at a lot more of these things, and I'm sure we can pick up, 3 or 4 things that is literally around us, that we can talk and bring towards the domain of cloud computing as well, right? Perfect. Now, to talk about the second important thing about, cloud computing is, why do we even require cloud computing, guys? The first reason that I can think of is probably, the ability where you can move an entire organization and, just say, hey, you're an organization. Let's say you're 100 people, you're a 100 people organization. You want to move all the data that you have into a server or a cloud computing platform. Well, it is easy as probably 3 or 4 mouse clicks. How simple is that, right? All the data that you have, drag and drop, and it's going to be on a cloud computing platform. I mean, it's not as easy as that to move an entire organization, but it is simplified. People sort of realize for so many reasons that having a server in your office, or what is also called as an on-premise network, will make it very difficult in multiple regards. Let me talk to you about one very important thing. For all of you all who are watching this on a laptop or watching this on a computer, you might know that your electronics heat up a lot, and heat kills electronics, right? So in this particular case, if you have a very, very powerful server that can cater to thousands of people, it demands cooling. It is not like cooling is an option there. It demands it. If you don't cool it, it's gonna shut off because it'll literally fry. That's how hot things can get. Now, when that is the case, you have to make sure that at no point in time does your cooling equipment fail, because if they do, your servers fail. If your servers fail, your data fails, your application fails, your website fails, whatever that you're trying to do, right? You get the point. Now, that's an important thing. The second thing is, when you have an on-premise network, you have to make sure that you have people to maintain it, right? Now, buying a server is a simple thing. Just put your credit card out, buy a server, bring it to your office, keep it there. Who's going to configure it? Who's going to maintain it? Who's going to take a look at how it works? Who's going to integrate it into the already existing data? Who's going to create backups of that? Now, you're going to need a guy. You're going to need when I say a guy, of course, a person here who has the capability to do all of this, right? So that's a very important thing that you have to think about. All of the things that we're talking about adds an immense amount of cost to the company. But with cloud computing, you will not require any hardware. You can run your entire company if you have a good enough internet connection and probably a laptop or a computer. So everyone connects to a common platform and everyone uses the storage of that platform, the compute power of that platform. And I think this is the primary reason, why cloud computing is popular. So we've covered the first point. Now to talk about the second point is, yes, whenever you take a look at data storage and powerful processing, the amount of flexibility that you get is fantastic, right? Let's be very honest here. Your laptop or your computer probably has 500 gigabytes, 1 terabyte, 2 terabyte, 3 terabytes of hardware space, and how expensive it can get to replace, buy another hard disk, right? So as of what I was checking, an external hard disk, a 2 terabyte hard disk retails for somewhere around 5 or 6,000 Indian rupees. That is pretty expensive, considering if you're an organization, you can probably fill up 2 TB like this, right? That's a fantastic thing that you have to think about, knowing that you'll have to spend so much money for it as well. Now, you and me, we're going to take probably a couple of months or years to fill 4 or 5 terabytes. But then, hey, you never know, right? It gets, especially in a working environment, terabytes just goes. You will not know. So that's an important thing. Paying for all of that, maintaining all of that. Again, hard disks are prone to fail, right? They keep going. Now, I have a hard disk which doesn't work anymore. It has fantastic data, very important data that I want 2 terabytes worth of it, and I'm trying to recover it, right? So if this happens to your official data, well, guys, you already know it, right? So having less headache, where a company itself is maintaining all of this for you is the best way to go. Companies realized this. Companies who are worth millions, billions, and trillions of dollars realize that this is, when it comes to even these tiny things, cloud computing platform is winning people's hearts, right? Perfect. The third thing is the wide variety of services that are offered. Now, when you're talking about the big guys, Amazon Web Services, Google Cloud Platform, Microsoft Azure, all of these big guys are providing so many services on their platforms, right? These are the top 3 cloud computing platforms out there right now. When you're talking about what you can do with the cloud computing platform, a right question is to ask, saying, what can you not do with your cloud computing platform? Because each and every one of these platforms are unique in their own ways. They do things similarly, they do things differently, but at the end of the day, for an end user, the amount of services that they provide is absolutely absolutely huge. So using all of those effectively will depend on how well versed a person is in cloud computing as well. So this is where we'll be tying up at the end to talk about how you guys should be learning cloud computing as well. It's a very important thing that people skip, but to give you guys a complete clarity, I think we have to discuss that, right? Let's discuss the fourth point of why cloud computing is required. Guys, the fourth point is the most important one. Is the pay as you go plan. Now I'll give you a scenario. Think about you guys having to require maybe 2 terabytes worth of space and an i5 processor powered computer for 15 minutes of some task, right? Now, would you go on to spend maybe somewhere around 50-60,000 Indian rupees to just use a computer for 15 minutes? Or would you probably pay 10% of that amount to hire it as in not physically hire it, as to use a cloud computing platform who's giving you that compute power and just pay for the 15 minutes that you use? What would you pick? 15 minutes, right? That's the reason why, again, cloud computing platforms are popular. Whatever you use, you exactly pay for that. Do you want to use a platform just for 45 seconds? You will only be billed for 45 seconds. Do you want to use it for only 38.5 minutes? You can only use it for 38.5 minutes. If you want to use it for 2 years, you can use it for 2 years as well. Again, all of these are chargeable as and when you want it and how you want it as well. That's a huge advantage for a company, regardless of the size, be it a small company, be it a medium-sized company or a huge company as well, right? You guys get the point here. Perfect. Now we know what cloud computing is. Now we know why cloud computing is required. The third most important thing that we have to discuss is, what was the world doing before cloud computing came into the picture? Now, if you're wondering if cloud computing is a brand new concept that came up in like 2010, 2015, all of these new periods, it is sort of not the case. We're going to come to that. Firstly, let us go back a couple of years. Let us go back 80 years when the world was completely depending on mainframes. 1960s was a fantastic period for computing. And if you guys don't realize, 1969, at the end of this particular era, is when humans first stepped foot on the moon. The processing power of the entire aircraft, the spaceship that took humans to the moon, had a RAM, the RAM space, random access memory, somewhere around 0.00014 MB. That sounds funny to you, I'm sure. 0.0014 MB, while the phone I have in my hand right now is powered with probably 6 or 8 gigabytes. So it's a million times, 6 million times probably faster than, not 6 million, hey, it could be in the billions as well, right? So it's exponentially faster than the entire spaceship that put humans on a very different, soil, very different environment, right? Think about that. This was the era in the 1960s. Computers were slowly developing. Then came the 1970s. 1970s was a very fantastic period because this is when internet started coming up. It wasn't called internet back then. It was called ARPANET. It was mostly used for military purposes, but it started then. People realized that you can connect with someone else. You can connect two machines together to probably use them together. You can connect two machines to, probably move data around, move services around, all of these things. So it started developing over the next few years. 1980s, virtual machines came into the picture. Virtual machines was using the power of an actual computer to do multiple things at once. That was the era of the 1980s. And 1990s, the internet blew up like anything, right? The World Wide Web came into the picture. So by early 2000s or maybe late 90s, people realized that, hey, you can not just connect two computers sitting next to each other, you can connect the entire globe if required. And that sort of gave way to the world of modern clouds that we have right now. Look around you. Everyone or majority of the people are using smartphones, smart devices, or anything that would make them want to connect to the internet for anything, be it social media, be it to listen to music, be it to listen to watch videos, be it to watch TV shows, whatever it is, right? People are on the internet for a variety of things, and whenever they're doing any of these things that I just mentioned, they are using cloud computing platforms, right? So way back from 2004, 2006, 2008, this is when people like Amazon came up with Amazon Web Services, Microsoft came up with Azure, Google came out with Google Cloud Platform and all of this. So they started very slow. They started putting 1 or 2 or 3 services. First, it usually starts with storage. Storage is very easy to implement on a cloud computing platform, but having compute power, bringing DevOps together, working with machine learning on the cloud, and giving you probably 100 other services is not an easy task, and that is when cloud computing really flourished. But before that, to get to this point of all of us being interconnected with a cloud computing platform, well, you know what's happening for the last 80 years now, right from the 60s to the 2000s. We're already in 2021, so the discussion goes way back. Now we talked about where we were and where we are now. One important thing that we have to talk about is the requirement for cloud computing. What is the need for cloud computing? Why is it considered to be so important today? We can discuss about this all day long. In fact, in the previous set of slides, I've already given you 5-6 very good reasons of why we require cloud computing and why it's becoming popular as well. But, at the end of it, when you think about the actual requirement for it, it is very vital in all the fields of our lives. Now, whenever you're trying to think about the requirement of cloud computing, think about 3 things: strategy, operational efficiency, and flexibility. In terms of strategy, cloud computing is changing the way we look at data, it's changing the way we work with data, it's changing the way we store data, and eventually, do anything we want with it. All of this on someone else's server, all of this on someone else's platform, all of this on another part, the other side of the globe itself, right? So it opens up your domain. Now, maybe you're an Indian company who's catering to US customers, right? When the US customers want to connect to your database, to make sure that they have very quick access, you can set up servers in the USA itself to make sure they connect to it easily, right? Strategically, that's helping you a lot. In terms of operational efficiency, we've already discussed hardware costs, we've already discussed software costs, we already discussed about having an actual employee to maintain all of these servers, right? So when you're removing all of that, eventually, a good thing is that your process becomes way more efficient because you don't have to spend man hours doing all of these things. Third thing, flexibility. Now, when we're talking about flexibility, pay as you go is the first highlight that we have to talk about. The second most important thing that we have to talk about in terms of flexibility is that you have a choice of picking up whatever service you require for your product, or pick up whatever it is that you might need, you might need in the future. So you can steer your company into these cloud computing platforms, realizing and understanding what it is that they provide. Now, there might be a service that Microsoft Azure is giving you, which AWS might not, or there is something that GCP, Google Cloud Platform, is giving you that both of these guys are not doing, right? It's usually between these top 3 guys that, as soon as one comes up with a new service, it is usually seen in the next few days in the other as well. So they're constantly neck to neck fighting to be the best platform out there. And as of now, AWS has the majority market share, but then trends seem to be changing. We'll see how Azure and AWS, we'll see Azure and how GCP catch up on that, right? That's a discussion for another particular, another module. But for now, to highlight a little bit about the 3 points that we spoke about, let's talk about strategy. Strategy is a fantastic thing, even in all the points which I didn't mention right now, because see, there was a time when people had to be face to face to converse, right? Before phones came, you had to be in front of someone to talk, to literally talk. You could of course send email, mails, telegrams, and all of that. But at the end of the day, you had people face to face. But today, it's in a situation where people are saying, hey, we have 5 times more collaboration, and we don't even have to meet the person. So someone sitting on the other side, they have their camera on, they have a microphone on, they have internet connection. We are being 5 times more productive with that. How fantastic is that, right? The second point is that whenever you have your own servers, whenever you're trying to host a server on your own, you have to look towards software aspect of it. One thing with software is software upgrades, right? There's usually bugs, and people keep fixing those bugs, improvising things, improving efficiency and all of that. So again, it's your headache to go on to fix all of these things. But if you have a cloud computing platform, latest softwares are always in use, right? Third point, whenever I told you about efficiency is that you can spend less man hours on the things which you can automate and put man hours where it's required. What are you trying to do? You're helping your business focus on the important requirements at hand. You're giving your business the opportunity to make sure that they can put in their required manpower, to go on to do important operations, which will eventually probably bring them revenue or something, right? An important point to consider. The fourth thing you have to talk about is how, maybe today your company is working in one way, maybe tomorrow they're trying to do something else. So you can pick up and set up a new service if you require it. If you don't require a service that you're currently using, drop it. You will not be charged for it if you're not using it, right? So whatever you're using, you're paying only for that. If you want to try a new thing, well, use the service, see if you can do something there. So you have that kind of a flexibility in terms of strategy as well, right? That's an important point. Perfect. That was point number 1. Now we have to talk about point number 2, which is operational efficiency. In terms of operational efficiency, pay as you go should be the number 1 point, right? No matter what extra costs you have, it will be cut to a very good degree if you have the pay as you go policy. We've already discussed this. The second point is that whenever you're trying to look at efficiency as well, whenever you have data, you have to secure it, right? Data that is present on the internet is usually never safe. That's a common saying, but the trend is changing these days, right? All these cloud computing platforms, they have huge amounts of security physically for the data centers, where you have armed guards, where many of the cases where there are ex-military people having loaded weapons. So if you try to get into a data centers, bad. Do not try to do it. It'll end up really bad, right? So it's illegal to go on to break into a data center. And first of all, they are so well protected, right? So check out these videos on YouTube or Google, which says Amazon's data centers, Facebook data centers. You will see how well they're guarded. 10, 12 layers of security before you can even see the server, right? Probably once you have physical access to the server, you can do something to the hard drives, you can plug in a virus, whatever it is. Because if you're outside the data center, their firewalls are so fantastic that there is a good chance, there's a 99% chance that you cannot hack into their servers, right? So data security is fantastic. So you don't have to break your head about keeping your data secure. The third thing is, one thing you have to talk about, maybe you have an office on the coastal side of things, or maybe you're in a country where there's lots of earthquakes and all of that. So what happens when, the ground beneath you shakes, or when there's water rushing in from the ocean, right? Electronics cannot survive all of these. They tend to go bad. So, of course, you will lose data if you happen to be, if you happen to be active during a calamity. God forbid that doesn't happen. But if it does happen, you lose the data. To make sure this isn't the case, what these data centers do is they take all these required precautions, they take all of these disaster recovery methodologies in a way where if you store your data with a cloud computing platform, even if something happens to the data, they will have backups, or they'll offer you options of how you should back up your data in case something happens bad on their servers itself, right? They're giving you a lot of flexibility here. The fourth thing that we have to discuss is that whenever you have cloud-based applications, the most important part is you can access it from any corner of the globe. You can be outside the globe. You can be sitting on the International Space Station. You can be in the moon. You can be on Mars, and you can still access the data if there are satellites, giving you internet connection there, right? That's a fantastic thing. Now, this recently happened to me where, I had to go to the airport because I had a flight to catch. And at the end of the day, I probably forgot to switch off the light for my aquarium, right? It's a very simple use case, but at the end of the day, if you keep the lights on constantly, there's a good chance that the light might heat up the water, it'll evaporate quicker. It's not very comfortable for the fishes as well, right? So all I had to do was I had to pick up my phone. I had to say, hey, Google, check if the aquarium light is on or not. So, Google was speaking to a cloud computing platform, which eventually had an IoT device sitting at my home. It's a smart device which connects with the platform. It checked, it said, hey, your light is on. Do you want me to turn it off? I said, yes, please turn it off. And I spoke to my phone, and my phone spoke to the cloud computing server. The server checked with the actual device sitting in my home, and the light was turned off. How fantastic is this, right? I gave you a very simple application. You can have critical applications like this. Maybe you forgot to turn off the stove. Maybe you, left a light on. Maybe you turned off your smoke alarm. Whatever it is, you have to be really careful with all of these things, right? And with cloud computing platform, you're just voice message away with your phone. You can say, hey Alexa, what's going on with the house. So you can say, hey Alexa, open up the security feed of my house. Whatever you want to do, it is possible wherever you are sitting across the globe, right? Perfect. Point number 2. Point number 3, flexibility. Flexibility talks about how you can go on to customize your requirement in a way where the cloud computing platform is giving you so much that you'll feel like, hey, these are way too many features that I'm going to use, right? It's rather good to have extra features than not have features at all, right? So you're better off to not use certain features that they're providing rather than being in a platform where they don't provide the feature that you critically require. That's flexibility. The second option is that whenever you have workloads which might be fluctuating, right? So let's say you're a website, you're an e-commerce website like Amazon or something. Today you might have had 1,000 people who would have purchased something. So your website has handled 1,000 clients. Tomorrow it so happens that you have a sale and now 1 million people want to buy a new phone or something. So when there is this constant up and down of fluctuation that's happening, you always should not and cannot host a server which would occupy for 10 million people. If you have 1,000 people coming and purchasing on your site, it costs a lot of money. So what these cloud computing platforms do is they have the complete capability to, customize themselves, so they can scale up as and when required and scale down automatically. If they're seeing 1,000 people, if your cloud computing platform is seeing only 1,000 people of traffic, it'll only allocate that many servers to cater to it. But then suddenly if it sees a surge of people, it can automatically scale up, copy all the operating systems, copy all the data, copy all the details, and make sure that right now you have a server ready for 1 million people. How fantastic is this, right? Now, the third thing that we have to discuss is about a hybrid model. Now, when you're talking about a hybrid model, maybe you want to keep all your organization's data in your office, but you want to use services which are present in the cloud computing platform. Can you do that? The answer is absolute yes. You can have this kind of a flexibility where you can have the data stored on the cloud computing platform. You're going to use the computing power that you have, vice versa, both. Whatever is the permutation combination here, you can go on to do it. And this kind of a hybrid approach which gives users what? Flexibility, right? Perfect. Now, the fourth thing that we have to speak about, as I just told you, is rapid scaling, right? Today you have 1,000 people coming in, your server is only working for 1,000 people. Tomorrow you need a bigger server, it's automatically given to you. If it happens in the middle of the night, you're sleeping, you have absolutely nothing to worry about. Your cloud computing platform can automatically scale it up, and the next morning you woke up, you'll be like, oh, okay, so these many people came in, my cloud computing platform took care of it, right? So how does it work, cloud computing? Well, guys, I want you to head to the comment section and tell me what your thoughts are about, how you think cloud computing works. So head to the comment section and let me know. And, while you guys go on to do that, let me talk to you about two of the most important components. In fact, it's 3 components, but I'll tell you why these 2 happen to be the most important ones, right? So, in a cloud computing environment, an important thing is we divide the working into 2 parts. One is the front end and the other is the back end. Now, when someone says, hey, we're trying to do something in the front end, especially if you talk to web developers, right? They are usually, throwing around this term front end, back end and all of that. So what does it actually mean? To give you a very simple example, let us actually go into the terms of web development itself. When you go on to, Amazon's website, maybe you want to buy new shoes or something, right? As soon as you click Amazon.in, you go into their website, you see all of these shoes, that is the front end. What you interact with directly, the images, the prices, there's a discount, there's an offer running, you can see, what address it has to be delivered to, everything, right? So whatever you can see, feel and interact on a web page is considered to be the front end. Now, there is this kind of a division that happens saying, hey, data is not stored on the front end, but data is stored in the back end. What do we mean by that? Now, whenever you have to show something on the website, you have to have data for it, right? For example, images of all the shoes that you want to buy, the image has to be stored somewhere physically. Now that image actually is stored on an Amazon server in the backend, right? Now that server can be as always, anywhere across the world. Now that becomes the backend. There is a link that goes on between the backend and the front end in such a way that whatever data is required and, addressed to by the front end, the backend has the capability to provide this if it is applicable, right? Now, when you usually search for images of shoes, you usually don't get images of let's say food or shirts or something, right? You get the picture of shoes. because the backend knows what it is being asked for, and then it provides the exact same thing to the front end. This again is a very important thing. This distinction that has been created, because the front end is a very, very complicated thing to work on its own, and a back end thing is again another completely different entity which is very complex to work with. Data storage, data handling, data manipulation. You have to do so many things to make sure that your back end is readily giving the data to the front end, right? So in this particular case, when we go on to dive a little deeper into understanding why there's a split in between these two, we have to understand what it is that we're doing this for, and of course, why it is considered important. The front end is a very important thing. It will give you access to everything that is stored on the server. Instead of you directly connecting into the server, you look at an interface which connects to the server on behalf of you. Of course, indirectly you are still connected there, but it is not like you are opening up multiple folders of data that's present in the server and then looking at pictures of shoes, right? So the same thing happens on cloud. In fact, the web development example I gave you also works on the cloud itself, right? So wherever the user has to access any sort of data, it doesn't have to be data. It can be a very simple button which says add to cart, remove from cart. All of these are operations which are making your user experience better, right? So this is what defines the entire aspect of user experience. So whenever someone says, hey, Amazon has such a nice user interface, Flipkart has such a nice user interface, or any other app or web application or anything that is, it is because the front end has been designed in such a way that they know what the users are asking for and they're providing the exact same thing. That is why the front end is popular. And of course, whenever you use your applications as well, right, you're using the front end of YouTube right now. It is not like you're typing in zeros and ones and directly heading to the server and accessing the file that is present there, right? The same file is coming to you through the front end. Perfect. Now to talk about the backend. Backend is where everything, right? All the servers, all the data, and everything that is ever needed by the front end is actually stored there. Now, to give you a quick examples, whenever you go on to see some websites, right? Now, there are many sites which give you like a graph or something that shows how far away the COVID-19 pandemic has spread. By each country, you can see which cities have the most amount of infection and all of that, right? So you look at this beautiful looking graphs and dashboards. Now, to power all of these graphs and dashboards, there has to be certain data which went into creating all these graphs, right? Especially if they're real-time graphs, as in the graphs that keep changing, as in when the data is changing, the data is directly linked to it from the backend. So directly it can access the data from the server. It can send a request and the backend, responds to that particular request. And this is how the entire world of cloud computing is in fact catered. Front end always puts out a request, back end checks if it's a valid request or not, and then it responds to the request. And be it any simple service, be it any complicated service, this kind of a transaction that happens between request and response is the foundational concept of how you would connect to a network yourself. Right now, whenever you go on to Amazon's website as well, you're trying to request something through the front end, which again the data is going to be in the back end to bring. So I hope this clears up everything that you have to know with respect to the front end and with respect to the back end, right? Now there's a very important concept, another one called as middleware. Now, this is specifically in the world of cloud computing because middleware is actually a software platform, which acts like a bridge in between two devices or two applications. Now, middlewares are very, very common here. It is used by the end users directly. When you go on to use your laptop to access Amazon's website, or you use your mobile to access Amazon's website, what you're actually trying to do, you're using your device to connect to another device which has the data, right? So there has to be certain software which understands what it is that you're requesting and what it is that the server has to give back. So it sits in the middle, as it sounds, right? Between the server, between the user, the middleware acts as a bridge, right? It's a software platform. It's a very important concept. And at the end of the day, when you think about it, direct usage is not there. You're using it, of course, right? You're not building the bridge, but you're crossing the bridge. That's an important thing you have to know. Directly, it's not used by the end user, but by all the developers who want to make sure that their cloud computing platform is accessible to the world. And whenever your application is on this platform, that it can be accessed via multiple hardwares and softwares across the world, right? To go on to do this, middlewares are very, very important. It is considered as, one of the most important aspect of how you can expand your world of cloud computing, right? If you just had one laptop and one server and there's nothing else that could connect to it, that would not serve as a cloud computing platform, to be honest, right? A cloud computing platform must be able to be accessed through from anywhere across the world if you have a stable internet connection, right? Now, I hope this clears up three important things: the front end, the back end, and the middleware. The introduction to cloud providers. All right. Now, to make things clear, I think it should come as no surprise to you that the cloud providers that you see on your screen right now are in fact the most popular ones out there, right? In fact, there are many providers out there. When you think about it, this entire market is not just governed by these 4 or 5 people that you see on your screen right now. It is just that these guys are doing things in such a right way, or these guys are catering exactly to the requirement of the industry in a way where everyone just wants to use them, right? Now, when you think about companies who are looking to move to the cloud, the first thing they'll want to see is how easy is it for them to get there. The second thing is how much is it going to cost them. The third thing is the cloud computing platform a new one? Is it reliable? Can you trust them with your data, right? All of these points we have already checked out in the previous modules. But at the end of the day, when you think about all of these points, right, the 5 or 10 important points which add value to the providers themselves, I think it should come as no surprise that these guys are here, right? Because again, there's trillions of dollars worth of companies that you see on your screen right now, be it Amazon, be it Microsoft, be it Google, be it IBM, DigitalOcean, all of these guys, right? Now, usually DigitalOcean and IBM Cloud are, they sometimes do take the backseat when people are talking about it. You always hear people talk about AWS, Azure or GCP and a little less about DigitalOcean and IBM. In fact, DigitalOcean is actually breaking through the trend now. It's breaking through the chart. It's becoming more popular than ever before, right? So we're seeing these new companies grow up and come to the same scale as the 3 big boys that you see on your screen, right? Perfect, guys. Now you understand that there's many providers out there. Let's quickly take a look at each one of them. Now, if we have to talk about Amazon Web Services, or AWS as it's called, let me tell you a little bit about AWS first. I think when someone thinks about Amazon, they do think about a good amount of trust, right? Now, I have shopped a lot on Amazon. I'm sure if you're watching this, you might have shopped a lot on Amazon as well. So once you're shopping with them, you're giving them your money even before they deliver a product to you, right? So it's not a company where they take your money and they don't give you the product, something like that, right? So it is trust. You're giving your money to them and they're they're giving you what they're promised, right? So this is a monetary transaction. Now, when you think about a data transaction, the same level of trust actually holds, in fact, even more, right? Now, if you give Amazon $100 and they're supposed to give you something back, a product worth $100, but if they don't, well, it is a monetary loss. But then if you give them certain data which is confidential, which is used to run your multi-million-dollar business, and if you don't trust them, and if there's a chance, and I'm not saying that they will misuse it, but if you give it to a company who might go on to misuse it, think about the effects it'll have on your company, right? Every company has its own secrets, its own ways of working, its own trade secrets, which it doesn't want the world to know. Well, at the end of the day, again, you have to think about all of these things, right? Perfect. And of course, coming back to the point, I think AWS is very popular because the world trusts Amazon, right? Perfect. Now, these guys, the cloud team actually in the world of Amazon came up with this wonderful product called as Amazon Web Services way back in the year 2004. It was announced in the year 2004. People were very excited for it. And in the year 2006 was when it was actually launched and it said, hey, we are here to provide the cloud computing platform. But then if you look at at the trends of cloud computing, I think it was until 2010 or 12 that AWS or Azure didn't really take off as quickly as people thought it would. But then now it's skyrocketing beyond control, right? So at the end of the day, from then onwards, from 2006 to today, Amazon Web Services is powering, guess what, hundreds of thousands of companies out there. Now, each of these companies, be it small, be it medium companies, or be it large scale companies, generate some amount of revenue, right? So at the end of the day, if they're giving a good chunk of money, if 100,000 businesses are giving their money to Amazon Web Services, I think it shows that that these guys are good enough to handle anything that you would throw at them. Now, I already told you that the cloud market is worth somewhere around $400 billion today, right? But when you think about the market share, when you think about who holds the majority share, right? Who gets the most customers, who makes the most money in this industry, I think it's AWS, because they hold a 35% market share, in an industry that is worth $400 billion. Now, guys, you quickly open up your calculator, just type 400 into 0.35. You will get the amount in billions, which shows you how much they are worth, right? It should be somewhere around $150 billion. And how amazing is that, right? And it's not just that. When you think about experts, when you think about practitioners, when you think about people who have been in the cloud computing industry for a really long time, 10 years, 20 years, 25 years, back when, the cloud computing industry itself was at its infancy, right? So when you ask them, hey, what cloud computing domain would you prefer? The majority of them said, hey, we understand that there's a lot of guys right now, AWS, Azure, GCP, and all of them, but we do prefer AWS for so and so and so reasons, right? Now, when you have experts say, these guys are the ones who made cloud computing industry the way we see today, and if they attest to the goodness, the amount of services, the professionalism shown by AWS, and of course the very powerful services provided by them, I think definitely we can take their word for it, right? So this is something that you guys should understand. But then coming to a point where you have to understand why AWS has become so popular these days, right? Because at the end of the day, I think it all comes down to trust, guys. I'll be very honest with you. We've discussed this in the previous modules, and I think you know where I'm coming from on this particular point. As I just mentioned, if you have a lot of data, be it confidential data, non-confidential data, it can be a simple photo, right? A simple photo of you is a personal thing for you. You do not want someone else to see it. You do not want someone to misuse it or whatever it is. Even a simple transaction of you clicking a picture of yourself on a vacation or something and uploading it to the Google Cloud, you have to make sure that it remains safe and only you are authorized to access that, right? So when hundreds of thousands of companies pour in their trust to a company, I don't think there should be any other big reason apart from this, right? So that's why I thought it'll add value to show you guys that this has to be the number one reason that AWS is popular. When you look at technical side of things, yes, we're going to take a look at the next point, which is going to add so much value for that. On the tech side of things, if I'm being very honest with you, when someone thinks about the cloud computing platform, the first thing that's going to come into their head is usually photo backups. The second thing that is going to come into their head is probably a transaction over the internet, maybe like email, or something like that, right? But at the end of the day, cloud computing platforms are so much powerful today that they can cater to any sort of workload that you throw at them. Be it game development. Now, for all you gamers out there, I'm pretty sure you guys know the amount of resources it takes to first of all run a game, and the immense amount of resources it takes to build a game and create a game, right? So in the field of game development as well, AWS is extremely popular there. And then when we're talking about data processing, when the world generates terabytes worth of data by the time I do this, right? So there's so much data that was generated right there. It could fill up my hard disk 10 times and probably fill up 10 other 10 terabyte hard disks 10 times over just by the second I did that. That is how much of data that the world is generating, every single minute of the world. Now, at the on the onset of that, it becomes very important for you guys to understand that when you're talking about data processing, it's not just the large amount of data that needs to be processed, it is also the computing power that is needed to process this large amount of data, right? First of all, you're going to need storage. Second of all, you're going to need compute methodologies to help you to do the actual processing, to do the actual analysis. There again, AWS is pretty popular there, and no matter how much you throw at it, you will never bottom out with AWS, right? There is always headroom there. There is always some space for more, and you can just add more and more. I don't think there is a company in the world who have ever tested AWS to its complete limit, to its max, and said, hey, we have this amount of data, we have this amount of processing, and we're going to take up the entire bandwidth of the platform that you're going to provide. I don't think so that any company have done that, and I don't think there can be a company who can do that, because the amount of services, the amount of servers, the amount of compute power that AWS hold in today's world is the reason why they are the most popular guys, in the industry, right? Perfect. And of course, the same reasons that I said spill over to the next industry as well in the case of data warehousing. Data warehousing also requires, a lot of people working on it, first of all. Secondly, again, you're going to have experts who are, trying to use data warehousing on the AWS platform as well, which again, at the end of the day, shows why AWS is considered, for this particular domain, again, it's considered to be very powerful. At the same time, the other thing that we haven't talked about until now is efficiency, right? How efficient is AWS at handling your data? How quickly can they process it? And if you upload something to AWS for data processing, how long are they taking to give you back the result that you're expecting, right? Now, that is another thing which is very popular in the field of data warehousing. Now, I think the next point that we're going to discuss, is the reason that makes AWS so popular is that with AWS, the thing is there are so many services, there are so many things that makes your life easy as a cloud developer, right? Now, if you're a person who's an application developer, using AWS, at the end of the day, your job is mainly going to be focusing on your writing your actual code, creating your application, and making sure it deploys easily on the cloud, right? So you will not be breaking your head about how best should you look at other things like compilers, interpreters. First of all, to get your code to run, you will not have to break your head to think about 100 different things. The time that you would have spent there is now saved, and you can use the same time to build the logic, to build a better application, to look at the various development methodologies, to look at the various deployment methods, and you will probably spend more time, to be very honest with you, about researching how best you can use your application, right? You know that you have your application, you know it is good, and now you want to find the most popular way of how you guys can go on to put it out for the world to use, right? Now, you will actually sit, I've had a lot of, friends in the industry tell me this as well. So they'll be like, Anirudh, we were taking a look at this particular app, we were taking a look at this deployment methodology, and we were confused about what to use, because every offering at the end of the day is really good, but we have to be very careful about what we use, because that is what is going to remain as the foundation for the product going ahead for that company as well. So there's so many things that goes into this particular point as well. Perfect. I think the next point is something that I am a huge fan of. It's the AWS Mobile Hub. Now, AWS Mobile Hub is an application that's available both on the Android Play Store and of course on the Apple App Store as well. So if you guys use Android and iOS or multiple other operating systems, you guys have access to this. With your mobile phone, I think these days it's a common trend, right? Having more power, doing a million things that you would do on your laptop specifically that you wouldn't do on your phone is the trend that is changing today. Now, there was a time when you couldn't click pictures on your phone, and now look at where we are. You can do a million things. Do you want to write Python code? You can do that. Do you want to run your entire company which is on the AWS platform using your mobile phone? You can do that as well, right? Now, that's the advantage. You can monitor so many different services. You can check what's happening. You can quickly change things around. There's a lot of things that we can go on to discuss about the AWS Mobile Hub itself. But then, for you guys, the most important thing right now is for you to understand that there is a feature such as this, and the world is very keen on it, and they do have millions of people going on to use this application for that purpose as well, right, guys? Perfect. Now, once you understand mobile access, the next important point we have to talk about is a little deeper into what they offer in terms of database services. Now, cloud computing is a domain where usually when a client comes in, they're very particular about the type of database that they want, or how they want their data to be stored, what is the amount of redundancy, what is their application, what is their dependencies on the data. There's so many things that they will say, hey, this is what I want, and I will not move away from what I want. In that particular case, if you have 10 people coming and saying, I want a relational database, I want to go on to use something like SQL, MySQL server or something like that, but then someone else comes in and say, hey, no, I want MongoDB. I'm not going to use anything else for my application apart from MongoDB. You have to have the capability to provide for both of them, right? That is the train of thought that has led AWS to give us this kind of an amazing versatility in terms of databases, right? Do you want to use relational databases? Of course you can. Non-relational databases, yes. Data warehousing solutions, again, absolutely yes. In-memory storages, yes. Graph databases, yes. So regardless of where you are, regardless of what industry you come from or what your application is, you can be rest assured that in the scenario or in the usage of databases, at least AWS has something for you guys in a way where you would not be surprised to say, hey, oh no, I did not have this particular database on AWS, so I had to migrate to something else, or I had to move my data into another type of database, something like that. You will never come to a situation like that in most of the cases because AWS does provide so many things, right? Perfect. The next thing that we have to talk about is their storage facilities, right? At the end of the day, Amazon is very, very well known for their storage services, be it Amazon S3, be it Amazon EBS, be it Glacier, whatever it is, right? With EBS, you usually are very keen on block level storages, BS stands for block storage as well. At the end of the day, there is so many things that, each of these storage facilities can do. If you look at Amazon S3, right? When you say S3, it stands for S, S and S. That's why it says S3. It's also like S cube, something like that. So at the end of the day, S3 actually stands for simple storage service. It's a very popular one whenever usually the files which are accessed by the user, like videos or something like that, they usually are sitting on Amazon's S3 as well. And when you look at Glacier is a very popular storage facility, usually for backups. Be it automatic backups, be it manual backups, we don't call it backups all the time. We'll just say, long-term storage. So maybe you store something here that you probably want 1 year from now. And if something crashes to your main system, there's going to be that entity there which is sitting there for a while, and we call it what? A backup, right? So that's what Glacier is very popular for as well. So guys, we just took a look at databases, we just took a look at the storage facilities, but then the other thing which is most popular, which I absolutely love, is the case of security, right? When you take a look at what AWS does in the case of security, they do provide amazing stuff. Protocol level security, done. Do you want port level access? That is also there. And they have the complete capability and a very, very strong firewall which can filter out any incoming and outgoing traffic in a thorough fashion. Now, when this is the particular case, when things are being tracked to its most elemental state, I think that it becomes very difficult for people, to have unauthorized access, to break into the servers, to hack into the network, something like that, right? So when people, again, I think this point directly relates to trust, don't you think? Because if they are being very secure, you will eventually trust them more with your data, right? Perfect. The next point that we are going to have to discuss is the AWS Marketplace. Now, AWS Marketplace took off like a rocket ship. There was absolutely no holding it back. It launched in the year 2012, and it's like this online store where you would go and, buy softwares which are ready to use. You would integrate it with your own application. You would deploy it using 1 or 2 clicks. And the best part is when you go on to buy a software on Marketplace, or go on to use a service there, the best part is you would still use this service called pay as you go, right? So just for what you use is exactly what you would pay. It's not like you're using a software maybe to a certain extent, but you have to pay the entire amount to this. Again, when we're talking about this basis, it is usually in the $100,000 or something like that for a very big multinational corporation, right? So it is something which is helping even the newcomers, even the entrepreneurs who are launching on AWS, be it the mid-tier companies or of course the multinational corporations who make really good use of AWS marketplace as well. So perfect, guys. This was everything there is to know to get quickly started about AWS. We checked out the introduction, we checked out the key features, we understood why it's popular. But then now I think it is very, very important for us to check out the next big competitor in line, who's Microsoft Azure, right? Microsoft, I think, is a name that is tattooed in the world of information technology, because at the end of the day, I am using an operating system that is powered by Microsoft, right? So they are the ones who created the Windows that I'm sitting and using right now. And similarly, I think hundreds of thousands of people across the globe, even for a person who is not initiated into the world of IT, will know Microsoft in one way or another. That's the best marketing for a company out there, right? Now that would definitely help in an industry worth $400 billion, right? When AWS came out, actually Azure was the second company ever to say, hey, we are going to launch our own platform, our own cloud computing platform, just like AWS. And these guys launched it in the year 2010. Since Microsoft was a brand which was already very well established by Bill Gates with respect to the operating system industry and so on, they were already established. They really didn't have to work with customers not having to trust them. They really didn't have any issues to get started with as well. So that is the reason why they grew up to popularity really, really quick, and now they stand head to head, neck to neck with AWS as well. The third important point that you guys have to know about Microsoft Azure is that these guys hold the second biggest market share in the industry. We know that AWS holds 35%, but the second number, I think it's 8%, is of the $400 billion industry is held by Microsoft Azure, right? When you talk to experts on this particular domain, when you ask them about their opinion of Microsoft Azure, every time I've asked about 10 people saying, hey, what's your view on Microsoft Azure, 7 or 8 of them have always come back to me and say, hey, you know what, when you're thinking about the world of DevOps, just think Microsoft Azure. When you're thinking about deploying machine learning solutions, think Microsoft Azure. When you think about IoT, Internet of Things, think Microsoft Azure. Right now, these guys are the pioneers. These guys are the pundits in their own domain, and when they come and say, hey, you know what, if it's your requirement is that, you should just check this out, and of course probably check your other options as well, but you should champion this because these guys are doing it really well. I think it adds a lot of value in this particular domain as well.
When you talk about AWS in particular, there's a service called as AWS CloudFront. What AWS CloudFront does is it actually lets you go ahead and perform these CDNs or create these CDNs for your AWS network or CloudFront distributions for your AWS network. As the name suggests, AWS CloudFront is a service that speeds up the distribution of your static and dynamic web content. It can handle files in formats like HTML, CSS, JavaScript, and even images. So basically, as it says, it speeds up the process of distributing your data across different servers, different regions, right? So basically it is a CDN service that AWS provides to you. What are the pointers it considers? One is your routing, the other one is your edge location, and the third one is your availability, right? So when you say routing, so basically what we are doing here is we want to move our data through the network, and it has to be delivered to different regions, right? Different servers, different locations. So data routing becomes important. So when you talk about CloudFront, it routes your data as well. It controls your domain names as well, so that it knows what IP addresses to connect to and how. Okay. Edge locations. When you talk about an edge location, again, edge location is nothing but your distribution or a location that is close to the area where you want to serve your data. Okay. Availability. When you talk about availability, ensuring that your resources are available 24/7. Is what CloudFront lets you do. So these are some of its features. Let's not get into the details of it. It's not very important, but I believe you have a gist as to what CloudFront does and what CDNs are. Okay. So how does it work exactly? So I had explained this when I was talking about CDN. Let's talk about it from a CloudFront perspective, right? So basically, let's assume you are a user, right? Now you set forth a request for a resource that is again based in Mumbai server and you're based in Chennai. So the amount of time it will take through normal latency is a lot and it would be frustrating for you. But let's assume that you have AWS CloudFront with you. What it will do is there would be a CloudFront distribution that would be created, an edge location for you. So whatever request you send, it will go through S3 bucket and CloudFront where a copy of this data is maintained. Okay. And once it fetches that copy, it will make a copy of it at the edge location and it would be distributed to you as a copy that you requested for. And whatever requests you put forth going ahead, the requests get speed up because now there's a copy maintained at the edge location. So what are the applications of AWS CloudFront? So when you say applications, right, there are quite a few things that you can do with AWS CloudFront, or there are quite a few features that AWS CloudFront offers to you. One, it accelerates your web content delivery, and that is obvious, right? So when you talk about your web content, if it is moving through a network that ensures there's no latency or lesser latency, you are not spending a lot of time waiting for the resources. I mean, good examples of this are the streaming websites that we use, right? You always have data that is cached somewhere, and whenever you put forth a request for it, it gets available to you right away. Serve on demand or live streaming as well. So as I've just mentioned, I mean, it serves both for your static data that you want to move and also for your streaming data. So when you talk about streaming data, the streaming data is delivered to a particular edge location or your server in packets, right? So no sooner these packets are available, those start getting streamed or delivered to your location one after the other. Okay. So in the form of packets in this case. So that is what live streaming also is supported by your AWS CloudFront and the CDN service it offers. Data encryption. Now there's an option of data security as well. You can encrypt your data that you want to move over the network. Okay. So yes, there's an option for data encryption as well here. Okay. And customize your edge locations as well to ensure that there's proper data maintenance there, security and ease of transfer to the closest region that you want to transfer your data to. Okay. So this was about CloudFront features. Okay. Let's just go back and take a look at the demo that CloudFront has to offer to us. Okay. So I've actually gone ahead and came back to my console. So let's just go ahead and create a CloudFront distribution to see how it works. Okay. So for your CloudFront distribution to work, we would be needing two important things. I think I have those with me already. There you go. So guys, there's a Great Learning logo that I have. And I have an index file. Let me delete this for now. I'll create a new one instead. Okay. So let's just say HTML, right? Okay. So I made a blunder out of there. I hate HTML, to be very frank. Hate as in I do not like using it. I know it's fairly easy, but not one of those things that I'm fond of. These tags make me confused a lot or get me confused. So next one is your head tag, and inside your head tag, let's call it, say, okay, demo, right? And let's have a body tag as well. Let the body tag say successfully routed data. Okay, and let me just save it as index.html. So there you go, my HTML file is created. Okay, so we are gonna go ahead and create a CloudFront distribution and try to access these two files there. Okay, let's just come here, and for that we'll need to create a bucket to start with. So we already have a bucket with us, right? Let's just go ahead and say delete, and then upload the files that concern us. So I say upload, I go to desktop and AWS demo, I select this file, I select this file, and I say open, and I say upload. So both my files are here with me. Demo for today, demo 2 today is the name of the bucket. So guys, now we are going to go ahead and create a CloudFront distribution. For that, I'll have to search for AWS CloudFront. I open it. And I say create a distribution. Okay. So there are two options. One is that says create a distribution for static data, and the other one that says RTMP is for your streaming data basically. So let's create the first one, and let's use this bucket, right? So it will use it as my origin domain name. Okay. So it has created a domain name based on the bucket that I have. Okay. Original path, I do not have to get into these things, do I? No. So origin ID, it is this bucket, right? So it will use this bucket as a server that I want to use. Are the other things that I need to make changes to? Restrict bucket access. I say yes. Choose an identity. I would say create one on your own. Okay. If I say do not restrict bucket access, anybody can access this bucket. I think this will create a problem for us, but let it be for now. And redirect my HTTP to HTTPS. Okay. Rest, I think we do not get into the details of. Let's just go ahead and say create. So this creation takes time, guys. It takes like a few minutes for your distribution to get created. CloudFront private content getting started, using CloudFront to serve private content. So basically it's giving me some information as to what all is happening here. So as mentioned, guys, the distribution will take time. If I go to distributions, so as you can see, guys, this thing is taking a lot of time, right, to load. So it might take like 5-6 minutes more. Once that happens, we should be able to basically go ahead and access a piece of data. So basically what it will do is, since I have my data that is rested in my bucket, right? So whenever I actually go ahead and type a particular domain name, right? So what happens is, let's assume that I have my data residing in my bucket. Now in this case, my bucket is that server point of connection, right? So you can see that there was a domain name that was created. So what it does is, when I look for that particular domain name and for a particular file, it would fetch that file for me from the bucket in first place, and then put it on the CloudFront distribution, so that going ahead, whenever I want to access it, I can access it quicker and faster. Okay, so you can see that our CloudFront application is up and running, right? So let's just go ahead and use a particular piece of domain name. Control C. Let's type it here, and let me say index.html. Okay, there's an error here. It says access denied. So let's just see what we can do. Okay, let me go through the S3 bucket first. So inside this S3 bucket, guys, let's see. Block all public accesses. Don't do that. I say confirm. And then I open the bucket and I have certain files, right? Make public. Now my buckets are public as well and the objects as well. So let's just try it out now if it works. Okay, it should. Demo successfully routed data. It will basically route the data to me through my distribution at a faster pace. Let's try it out for the PNG as well. There you go, right? The logo that we had put forth. And if I look for index.html, it does that instantly for me, right? Because it is getting distributed to me through a cache that I have, and that is located close to the region that I'm based in. Okay, so this is what CloudFront does. It ensures speedy caching of data and delivery to you that is closest to your place. Okay, so this was about some of the popular networking services that we have in hand. Let's now just go ahead and see what all can we talk about. But ensure one thing, that before you leave, you delete your distributions as well. Okay, so if I select this now, it would say delete. So delete your resources, disable this one to start with, and once it is disabled, and once this is disabled, you can actually go ahead and delete it as well.
So guys, I hope this comprehensively put together hands-on helped you a lot in terms of AWS. Now again, let us start with a couple of demos. The first one that we're going to be doing is building a simple chatbot with AWS.
So what exactly is HoneyCode? Well, when you talk about HoneyCode, it is a fully managed AWS service. It lets you develop powerful mobile and web applications without writing any code. Yes, you don't have to write code. You can write certain basically you can put in certain filters or basically put in certain conditions that are similar to writing code. So that is why I've said that almost zero code in the title. The reason for that is you could be required to code a little if necessary. If not, you can have it as a plain usage as well, right? So that is what HoneyCode is. It is more of a worksheet access kind of a thing where you can create worksheets, workbooks, and on top of that you can build applications that you can share with others, and you can interact with those applications as well. And you do not need to code for this particular service, that is AWS HoneyCode. I'll give you a walkthrough as to how it works, right? And it is very true what you see here. You can build apps in minutes and you do not need code for that.
Alright guys, so it was really easy to go on to build that chatbot, right? Now what we're going to do is, as discussed in the agenda, we're going to take a look at AWS HoneyCode and Amplify and see how we can get started with building our own first mobile application using AWS.
The next one is your AWS Amplify. It is an end-to-end solution that enables mobile and front-end web developers to build and deploy secure, scalable, full-stack applications powered by AWS. So again, with Amplify, you can build web apps, you can build mobile apps. Now you would wonder, as in when you have HoneyCode, why do you need something like Amplify where you are gonna code? See, there are quite a few functionalities that you can add using Amplify, right? Whether you want to connect to a backend, right? Whether you want to build applications and migrate it for different platforms, you can do all these things. So you get more functionality here. When you talk about HoneyCode, it was released in May, June, July, somewhere during that time this year, and it still has quite a few functionalities that needs to be added to it. Say for example, now you can add Honeycomb APIs to basically connect with the backend, but that has started recently. So there are not a lot of options that you have with HoneyCode. But the best thing about HoneyCode is if you do not have coding knowledge, you can still work with it. So we're gonna go ahead and build an app using HoneyCode, and post that I'm gonna also tell you how you can actually go ahead and approach building applications process using AWS Amplify.
Alright guys, now that we checked out the theoretical aspect of things, it's vital that we have a hands-on experience with it. So let's get started with the demo of building our first mobile application using HoneyCode.
I'm going to switch into my console here. So guys, for people who were asking about AWS free tier, while we start the demo, I'm going to answer quite a few questions. All you have to do is look for AWS free tier console. You would be redirected to this page and it would ask you to sign up. Enter your credit card or debit card details. They would charge you like 2 Indian rupees I'm not sure about the US charges, but in India it's like 2 Indian rupees for the verification process. Post that you won't be charged anything. Okay, all you have to do is ensure that you follow the free tier limits and you won't be charged. So when you do that, and if you log in, I'll show you how the AWS console looks like. Yeah, there you go. So it's logged in now. You see, this is how the interface looks like when you talk about AWS, right? So again, some of you asked about what are these security options that we have. If you click on services here, you see there's a separate domain for security. It should be somewhere here. Scroll down. And where do you read security in here? You see security, identity, and compliance. So there's so many services that you have which serve different purposes, right? From encryption to SSHing to IAM accesses, right? To getting in firewalls in place, right? Whether you talk about putting in shields, right? All these things can be taken care by these services that you see here. Security, identity, and compliance. Okay. Internet of Things. Somebody asked me about that. See, you can connect or do these many things. All these different things let you set up the infrastructure, right from setting up a router kind of a thing where you can connect to other devices, have a central management system, to basically having one-click devices and audio, video streaming, and all kind of these options that you want. So all these things can be done by using IoT services that AWS offers. Now, the question on our plate is, what can we do when you talk about HoneyCode? I search for HoneyCode here, it would take me to a new page. So guys, once you connect to HoneyCode, so this is where it will bring you. Don't do that. Just look for this particular link, right? So this is the developer link that you have, and it's this, that is builder.honeycode.aws. So you would be redirected to this page. So guys, again, you would be required to sign up here. Once you do sign up, you can do quite a few things with this particular tool that you have, which is an AWS product again. So note one thing. All you have to do is put in your email ID and your password, and you would be logged into this thing. Another thing that you can do is you can download this thing on Play Store so that you can actually go ahead and take a look at all the workbooks and applications that you create. So in Play Store, go ahead and look for AWS HoneyCode, and you should be able to see this app there. If you download it, you'll be able to see all the apps that you want to. Let's create a workbook, guys. This is a fairly simple thing. I'll show you how can you actually go ahead and set up an interface here. Again, guys, there are options for you to go ahead and create custom applications, right, which are true for web and for mobiles. And you can also go ahead and basically create everything from scratch. So I'm going to show you both the processes. So let's start by creating a workbook quickly. Since we are very less on time, I'm not going to add in too much functionalities here, and we are not going to spend too much time beautifying our app. I'm going to rather quickly show you how to get this done, and I'm sure you all can do it. Okay, let's call this workbook as demo workbook. Okay, and I'm gonna say create. So guys, if you've noticed, I've selected an option called as create from scratch here. Okay, so you can actually go ahead and use custom templates as well if you want to. That is also an option that you have. I've personally never tried creating custom templates. So when you do that, you get more functionality there. But since it is so easy, why create custom templates, right? You can do everything from scratch. So the first thing that I have is I have tables here. So I can put in my data in the table. Do not worry. I'll tell you why HoneyCode is important. What are its applications? But let's just go ahead and quickly build an application from scratch first. Okay. So let's just assume that I want to have an application where I'm managing my employee attendance. Okay, so let's just go ahead and try and do that. Okay, so again, this is something that thought came into mind right away. So I've never built an employee app before. I've mostly built other apps, but for now, let's just try and build one. There's no rocket science here. Let's rename this particular folder and let's call it employee attendance. We would first build the backend part of things, right? And once we are done with that, then we'll actually go ahead and see how the interface looks in the front end. Okay, so I'm going to hit the enter button, right? So the name has been changed now, and let's just give this column a certain name. Let's call it, say, name of the employee. Okay. What are the other things that we can add here? ID, right? And what is the other thing that we can add here? Attendance. Okay. So we are building a very basic app here. Okay. Do not put in a lot of thought process. Let's give in certain names. We have Ram, we have Shamprati, right? We have Mudita, we have Chirag, we have Bhavya, and we have someone like Vishal. Okay. Let this field have IDs, right? And let's just go ahead and add attendance here. Okay. So okay, so we have one table that is in place. We'll align everything later, but that's for the later part. Let's create another table here, right? And let's just go ahead and say, let's call this table as what should we call it? Let's call it, rename as ID. I do not want these. So this table is not adding a lot of value, but still let's have one, right? And I'm just gonna take a look at some of the data that we have in this table quickly. So we have 6 records here. Let it be 6. Let me add one more table now, and let's call this table status. That is for the attendance that we have. Okay. So let's call it attendance stat. Let's delete these. Let's delete this as well. So if I go to employee attendance, I have present and absent. There you go. So guys, the table is in place. We have all these 3 tables with all the records that we need. Now let's go ahead and create an interface for the app that we need. So we've created a workbook in which we've put in certain sets of details that we require. I'm gonna go ahead and open this workbook again, and I'm gonna come here and say, click on builder, add a new app. You can use an app wizard that again beautifies stuff for you, so you can try those things out. The aim is you understand how the basics work here, right? So for now, let's not get into the details of those things. Let's call it employee attendance to start with, right? So once you do that, you should be having an interface that you need to put in place. Let's just go ahead and add some other features, functionalities here, right? Now we know that we have these things in place. We can also go ahead and beautify these things a little. So you have an option of adding an object here. So this is how the template would look for you, more or less, right? So we can just go ahead and say add. When you say add, you're gonna go ahead and add a content box here. Let's call this content box as details, maybe daily details. And inside this, I'm going to go ahead and add a list here where we are going to go ahead and import all the data that we put in 3 tables that we've just created. So employee attendance is what I want to do here. And within a minute, you should see that this has been put in place. Let's see if we can beautify this a little. I'm going to select this part and I'm going to change color for this particular theme. Let's keep it a little formal. So I'm going to go ahead and use maybe this color. And in the interim, let me go ahead and change this piece of color. Let's make it white. So there you go. We have our text in place. We have all the details that we need. Let's bold this text that we have, right? So that it looks a little better. And I'm going to select this text as well. Unfortunately, I cannot format it. I do not know why that is the case. I'll have to look into it. But as you can see, we have a template in place, right? So what you can also do is you can actually go ahead and have a different table here in that table, or different list here, where you can add some functionality saying that if somebody is present, then show that person's attendance here. If somebody is absent, you can go ahead and show that person's attendance here. That is doable. Okay. So let's just skip that for now. Let's just go ahead and see how does this app look like, the one that we've created. So I'm going to view this app here. And so guys, when you create these applications and if you download the HoneyCode app from your Play Store in your phone, whatever changes you make here, those would be visible in your app that you have with you. So make sure you go ahead and take a look at that as well. Okay. So guys, you see the app is visible now, right? In the web domain right now. If you want to take a look at this app in your mobile, you can take a look at it and all this data would be visible there as well. Again, the formatting is not in place. You can edit that later, but that is not our purpose right now. Our main focus is how to go ahead and create an app, right? So again, if somebody is present, right? So what I want is I want this present or absent button to have a specific color. So can I go ahead and add a button here instead, right? Let's try and do that. So when you talk about somebody being present, let this content box, can I add a particular color to it? Right, I can. So let's add your text a particular color, making it white, right? And instead you can even have a button here if you want to. So you can add buttons here. When you add a button, if you click on this particular thing, it will have certain functionality. You can make it move around. So that is the other thing that you can do. Now, if I go back to the app again, you see there's an instant reflection here, right? So guys, when you ask about these kind of applications, you might have a question here, right? What is the use of this kind of an app? Now, if you add more functionality here, as I've mentioned, you can have another table here. Let me show you. Then probably that would make a little more sense to you. Let's just select a column list. And in the column list, again, import this data, right? And as I've mentioned here, you can actually go ahead and represent the data where people are present. So if you can just go ahead and delete this for now and add a button here instead. So in this button, you can have another text like present, and you can probably add in some colors. Okay. So if you just come back here, okay, this is not reflecting here. You see it's reflecting now. Unfortunately, it is showing that everybody is present here. That is not true about this data though. What you can do is you can actually come here and select this functionality and probably add a source code here, right? So if you add a filter here saying that for the particular table and particular column, what is the name of this thing? Attendance equal to present. So if you do that, only the people who are present in your table, that data would be reflected here, and you can do that. So again, you might ask a question as in what is the benefit of having an application like this, right? What all can you do with it? Okay, so let's go ahead and continue with the session that we are having on our plate, right? Let's just go ahead and talk about the stuff. So guys, this is how you can create an application. I stopped midway when I said that what is the use of these kind of applications? So when you add functionality here, what all can you do is you can actually go ahead and ensure that you can actually go ahead and add in more functionality. Like we could have even had an application here where you can actually go ahead and process attendance for people, right? What if we have an in-house tracker that we need, right? In a company, you have tools like Jira and all those that you use, which are very good. But again, their functionality is very structured and you have to follow the structure that is there. What if you need to have an in-house or in-team app that works differently for the team? You can create an attendance tracker there, right? You can create a sheet that meets your particular requirements, and you can probably share it in the form of apps where people can view that on their mobile phones, on their web apps, and whatever changes the admin or whoever has access to can make to it, those would be reflected for everyone and everyone can see those changes, right? So that is one benefit. You can also have basic setups. Let's assume that you want to start a business where you want to deliver groceries to people. Please forgive me, guys. There's a call that my mother's getting since I've tried all the mobile phones to connect to the internet. So that is the reason there are a couple of mobiles lying here and her phone is unfortunately not on silent. Let me just quickly make it or put it on silent. Yeah. So let's assume that you want to create an online grocery delivery app. You can do that, right? You can create a worksheet here, put in the products that you want, and you can have buttons there. So people can actually go ahead and put in all the information that they want. Now you might ask, can we connect it to a backend? The functionalities here are still limited, but that is pretty much doable. Okay. So this is how you actually go ahead and build an app. As I've already mentioned, you can go ahead and create some template apps as well. So if I just come back here, right? And if I just come back here and if I delete this workbook, all that I've created would go. Okay. I want to do that. The reason for that is I'll show you why. Let's say create a workbook now. And this time, let's say I want to pick something that is more of a template. So if I use a template, say team task tracker, create. So these are some templates that AWS also gives you, right? So let's just go ahead and see how it works. And there you go. There's a template in place for you. You can actually go ahead and create, right, an app for this. There's all the information here that you need. So you can actually go ahead and just come here and say, build an app. Let's try and use an app wizard. I've never done that before. So I'm doing it with you people for the first time. I'm just gonna say next for now. Choose a table, it says, right? So what was the name of the table that we just created? Team tasks. Let's see if we can just go ahead and have a team tasks table here. So there was some table that I randomly picked up. I just want to see how does this wizard work for you, right? So after that, we are making an app for you and it is getting that done for you on its own, right? So for this M team, there's an app that is getting created. I'm not sure how that app is going to look. Let's just go ahead and see. So it shows my name there as well. That's nice. And if you try to share this app, which I cannot for now, I'm just going to say next to see how does this wizard work. And I say apply. So by default also, you can go ahead and create a template. Let me just see how does the template look like. So I've just picked up a random table, a random data set, and I've just gone ahead and seen how it looks. This is how it looks. It's not very interactive. So this is a basic app that it has created. You can go ahead and create one more yourself, right? Come here and just say, create an app. This is your team tasks app that was created by default. And you see all the functionality is here, right? So if you view it in the app form, you can see there would be some interaction that you can do with this app, which is again a template app. Okay. You see, these are the details about the work, whether it's in progress, is it high on priority and all those things, right? So it's created a daily update tracker. So you can add filters here as well. What are the filters? You can select an option. A newsletter is what you can look for, right? Assignee is Vishal Padghan. Again, guys, this is something that I'm doing just for the namesake. I'm just not aware about all the details. So there's no such thing in this record. So whatever data I've entered, it's not valid for assignee Vishal. So he's not worked on any of these kind of projects. So the task says there's nothing that we can display. You can actually go ahead and do quite a few things in AWS Amplify as well. Let's just come here and look for AWS Amplify, right? I'll just tell you what all can you do here. You see, in AWS Amplify, you can again develop web apps. Here, Amplify provides you frameworks for command line interface and library for creating applications. So if you come here, you can choose all these platforms for web applications. And for mobile, you can use your Android. Again, there are step-to-step guides here how you can go ahead and do that. If you start the free tutorial, you'd be actually going ahead and putting in all these requirements. You have to create an Android Studio project though. So it's a time-consuming process to start with because you'll need to install Node.js, Android Studio, and Android SDK. That is Android API level 29 basically, and also install AWS Amplify CLI. So once you install all these things, you can actually go ahead and create a project here as well. But again, this is something where you'd be needing coding. Say for example, if you come here, this is the Android Studio that you look, this is how it looks like. If you just click on new project, right? You can just come here and say, select a basic activity, click on next. You can go ahead and say create an application. All the details are here. I'm using Java platform. You can use Kotlin as well if you want to. That's up to you, right? What platform do you want to use? And just say finish. And if you click on finish, within few minutes, your application should be, your basic code should be up and running here. Now you might wonder, as in, once I have this code, this is something that is giving me an application in my Android Studio. What is AWS doing here? In that case, guys, what you people can do is you can actually go ahead and edit this code. How do you edit that code? You see, if you come here, there are certain instructions here. What they want you to do is in your main activity file or in your XML files, just replace some of these steps that are mentioned here. You'll have to replace these certain pieces of code with the AWS Amplify code. And once you do that, and if you set it up using the framework terminal here that you have, you see you have a terminal here. If you set it up using the terminal, you can actually go ahead and install these applications. And once you build it, you can basically have it run on your mobile phones as well, and also on the cloud. So since they are based on AWS cloud, now these applications is something that you can put in your Play Store as well. But again, this is a tedious task and a complicated process. So if you want to, you can definitely give it a try building these applications here from the scratch. Okay. So by now, I believe, guys, we've talked about quite a few pointers. I hope that you understood how to go ahead and build HoneyCode apps and what AWS Amplify is all about.
We have covered everything you need to launch your journey as a data engineer. First, we clarified the differences between data engineer and data scientist, helping you understand their unique roles. Then we explored the data engineering lifecycle, detailing how data is collected, processed, and stored. Next, we introduced Python, starting with the basics and advancing to key libraries like Numpy, Pandas for data manipulation. We also delved into data visualization with Matplotlib and SeaBorn, culminating in a hands-on Python projects using IPL data to apply what you have learned. We moved on to SQL, where you gained an understanding of its fundamentals, data types, and saw a practical demo. From there, we tackled big data technologies like Hadoop and Spark, which are essential for processing large-scale dataset. Finally, we discussed data warehousing, focusing on tools like Amazon Redshift and Snowflake, and highlighted the importance of cloud computing with platforms like AWS. Thank you for watching. If you are ready to take your data engineering skills further, be sure to subscribe for more content and keep learning.